Good morning.
Is mine working?
Добро
Yeah, it is.
утро.
Okay.
Ако колегите, които са пред залата, ни чуват, молим ви, заповядайте. Вече
Колегите
сме
пред
започнали от
залата.
10 минути.
Чуваме ли се? Кире, получи ли?
Заповядайте на
вътре сме.
За колегите, които сте тук, имаме нужда от няколко минути, за да дойдат всички и да започнем.
Хората се регистрират, виж, аз още не съм се регистрирал.
Време ти е да се регистрираш.
За всички в залата ще ви помоля сега да ме изчакате 5-10 минутки да отида да се регистрирам, да се върна след това, за да може да започнем цялата тази история.
Докато чакаме останалите, и се извинявам на български, ще превключим на английски след малко. За колко от вас това е първа ISTA? Дигайте ръка, ако ви е първа ISTA.
Вау.
Wow. За колко сте идвали над 30? Поне 3 пъти сте били.
Има.
Добре. 5.
10. Единайсет.
Всички. Тук някъде е Георги Гергинов, той е бил на всички исти, така че
не е вярно,
се
Георги мисля, че миналата година не беше.
Не беше ли? Добре.
Жоро, къде си? Дигни ръка. Той избяга.
Добре. Може ли нашия шампион с червената буза стани, обърни се нататък, аплодисменти за него. Силни аплодисменти за него.
Сега да ти кажа и другото. Търсихме човек, който да открие и намерихме един в залата, който е бил на всички исти, така че заповядай тук.
So good morning, guys.
We're going to get started. You want to?
Yeah.
You sure?
Time to kick off.
Good morning. Still sleeping? Let's try this again. Good morning.
Good morning.
Nice.
Good
All right, guys. It's been a while. I usually am up on the stage whenever we have ISTA, holding as a regular conference in venue. We started this conference 12 years ago, in 2010. It was a QA conference, then it evolved into a more general one around innovation, around software technologies, around automation. And for 12 years, up until 2020, we were always in this kind of setup. That's what we're used to. That's what we want to see. People coming together, people listening to interesting lectures, and people networking, people socializing with each other, people from the sector being together at ISTA. But in 2020, things changed dramatically, I should say. How did things change? We were locked down. We couldn't hold ISTA in the way that we're used to. And so we had to move online. 2020, do you remember? We opened ISTA 3 times. Why? Well, sound wasn't coming through the first 2 times. So that was our attempt at streaming a conference at the time. And 2021, it was slightly different. We didn't have the technical issues. We learned from that, but it's not the same conference. And we were dreaming. We were dreaming of coming back to the usual setup that we've had over the years. Now, the 12th iteration of ISTA is coming back to normal. But that was so far. Now, what's about to come?
What's about to come is a hybrid event. And I'm sure that's not the first one that you have. So there is a good bunch of people today, right here, right now. But there is also a good bunch of people that is actually attending ISTA online. So welcome to everyone that's in person. Welcome to everyone that is online as well. What do we have for you today? We said that the motto of this year's ISTA is about dreaming, exploring, and inventions. And speaking about dreaming, we have, and I'll speak about a few of the topics that we hear today. So we have Ingu Muscenec, apologies for the name, who's going to present software architecture and the future of the city. So dreaming of the next generation of the cities, the smart cities, I suspect, we're going to hear in a while. Speaking about exploration, space, satellites. So actually, how do we make sense of this data? And you're going to hear from Pavel Genevsky and Georgi Genchev about it today as well. And of course, inventions, which is the birth. This is how this industry is practically moving on. We're going to hear from Vinci, just in a second. But before we go to the interesting topics, I have few logistics that I need to take care of as well. And once again, we have people that are here today. We have people that attend online as well. So talking about everyone that is here today, what you need to know, we have 2 tracks. So in this hall, which is hall 1, you typically have track 1, what we call track 1, so the first set of lectures. And you can see the agenda on this small leaflet, which you actually have for you. This is how you could easily select where you want to attend. This is hall 1. Next is hall 2 as well. So the second track is basically going to be held there as well. Speaking about the nice perks and the networks, and Kosi was talking about the fact that ISTA is about networks more than anything else. So you have the nice coffee breaks, the coffee machine, the one is over there. This year we decided that we want to be environment friendly, which means that we want to use less plastic. So this is why you have the water machines. You don't have that big bottles, and they don't have the big pile of plastic outside when the conference is over. Of course, you have a nice lunch if you're here. If you're not here, enjoy the nice lunch at home, which I assume you're going to prepare as well. And what we have at the end of ISTA is the raffle. So this is where the companies, the sponsors, are giving the different prizes, the different raffles to everyone. And in order to attend, you got this when you enter in the room. So that's basically a number. So go to each one of the stands, just give them the representative ticket as well, and we're going to have the raffle at the end of the conference. The raffle is not the end, the closing is not the end. One of the most enjoyable things that happen at ISTA is actually the after-party cocktail. So watch out for the after-party cocktail. It's going to be held here. Last time it was Johnny Walker. This year, let that be a surprise. We'll see who supports us with that. And speaking about how we make all of this possible, of course, it's our sponsors, and Kosi is going to tell us a bit about them as well.
So after Ivan massacred some of our speakers' names, I'm probably going to massacre some of our partners' names, but I'm going to give my best, and I'm going to try not to do that. Of course, this type of conferences are not possible unless we have other companies supporting us in the organization and through the logistics and mostly the financial part, of course. And we got to thank all of them. We got to mention all of them. So our main sponsors, Merkle, Bosch, Progress, Resolve, Axway, Commerce Bank, Ocado, Stripes, TIC42, and DevExperts. And we have a few more, which are Design Technologies, Scale Focus, Chaos, Andava, and Intellius. And last but not least, we have to mention the 5 companies that are actual organizers of the conference, and those are VMware, Experian, Infragistics, Musalasoft, and SAP. And again, give a round of applause to all of our sponsors, because this type of conference is actually not possible without them. So before we came up here, Monica told us you guys have strict 5 minutes, so we're going away and passing it back over to Ivan.
So what we said is that this year we're going to dream, explore, and invent. And talking about inventions, we could welcome the first inventor on stage, because invention is how this industry is moving on. So Vinci, welcome on stage.
Hello, everyone. My name is Vince. You can call me Venci, Vencislav Galergiev. Uh, Let me tell you a little bit about myself first, and then we can continue on discussing the dreaming and the exploration and a little bit of an invention that happened in the last few years for us at Alcatraz. So again, my name is Vince. I'm the founder of Alcatraz AI. Um, I I started Alcatraz with the dream to kind of change how people interact and authenticate in the physical environment, kind of like Face ID, but not on the phone, but in the real world. Um, Prior to this, I used to work at Apple. I led the team that created kind of Face ID and the integration of Face ID into the iPhone, including some iPhone and iPad development as well. And prior to this, I used to work at NVIDIA on chipsets that used to be integrated in cars. Mostly, I used to work for Tesla, the first iteration of Model S, all the way back in 2011, 2012. What can I tell you about me? Originally, I'm from Russia, from Bulgaria. I was born 39 years ago, studied in the English language school in Russia, and I was never supposed to be connected to IT. My grandma used to play the violin. She was the first violin player in the Russia Philharmonic, all the way back in the 40s, 50s. She even called my mom Violina, because my mom was supposed to be a violinist player, and I was supposed to be a violinist player. I started studying, I started playing the violin, symphonies, concerts every year. But then when I was 12, my parents bought me a computer for my birthday. And I didn't have time anymore for violin. It was just my computer at home. Back in the days, in the mid to late 90s, we didn't have a lot of internet, a little bit of a dial-up. I was never about gaming. I was always dreaming to create something that people use and kind of feel useful, that it's in their daily life. So back in the days, we used to play with some software, how to make dial-up faster. We were connecting wires through Russia to have manual LAN networking, so things are faster in our town. And that's how I kind of started my dreaming, my exploration, my maybe a little bit of an invention in the computer business. My parents always wanted to send me away, not for good, just for a few years, just to learn some English, and then come back to Bulgaria. And the idea was I can go for a few years in high school, I can learn English. Initially, I went to Oxford High School. It didn't click for me that much. I came back to Bulgaria, and then I said, well, why don't I go to US, maybe for a year or two. I'm sure I'm going to like it. I've seen all the movies. They all look great. And I can come back. So my parents sent me. I almost came back the following week because there was a mix-up. Back then, there were not a lot of agencies that sent high schoolers from Bulgaria to US. I was sent. I was supposed to be in a host family, because you cannot just go when you're 16 somewhere else by yourself. But the host family ended up being this Native American a prison guard that had a lot of wolves at home. He believed in a lot of gods. I had to feed the wolves. I had to ride the bus in Florida for 2 hours in the morning, in the evening, while going back and coming back from school. In the desert, and I was like, wow, I actually like Bulgaria so much more. It doesn't seem like US is right like in the movies. I want to come back home and start on September 15th with my all my friends and continue high school. And just on my kind of like the last couple of days of me going back to Bulgaria, had a birthday. One of my classmates told my story to her parents. And her parents came to me and said, well, if you want, we can be your host family. We will adopt you. Just stay. And I did. Very different experience. Studying in, you can see here in the picture, Interlachen High School, which is the deep, jungly desert in Florida, but also connected to a lot of Christian activities. My family was a Baptist family that spent every Wednesday, every Sunday going to church, and I spent my weekends and going to Disney on church trips and so on. So this was great, and the following couple years I stayed. Then I stayed a little bit for school, then a little bit for post-undergrad research at school, just kind of studying to see how I can create actual stuff. I studied electrical engineering, microelectronics, how to create stuff with your hands that people can touch and actually love and enjoy and use. Eventually I graduated, and my first job out of school was for a company that really admired called NVIDIA. NVIDIA makes GPUs for PCs, for servers. Not many people know, but NVIDIA also makes GPUs for cars. Back in the days, in 2010, 2011, this was just starting up. NVIDIA was trying to make GPUs on embedded system on modules that went into tablets and phones. This thing failed a little bit because the GPUs were kind of big and expensive, too hot. But they were very, very good for cars. And since the technology was tried out and it was transitioning to be more for an automotive use, NVIDIA said, well, this is before self-driving cars. This is before mapping all the roads in 3D. But what we can do is we can go and talk to all the vehicle companies. We can create all the partnerships. We can use our GPUs for their multimedia systems. And then eventually, when self-driving cars pick up, then we can use the GPUs for everywhere else in the car, including all the cameras. My first project at NVIDIA was in the automotive division for Tesla. Tesla, even now, but especially back in the days, it was only situated within a few miles away from NVIDIA in the Bay Area. Right next to San Francisco, there is Silicon Valley, San Jose, and the Tesla factory was in Fremont, and their main development office was in Palo Alto. So I spent the following couple of years basically camping out in the factory at Tesla, bringing up the multimedia technology, so the big screen, the small screen on the first Model S, before it actually came out for people to use. Initially, it didn't work at all. I mean, it couldn't run for more than 10 minutes at a time on any car. And eventually, with hundreds of people and a lot of testing, a lot of development, it actually kind of worked. Although the first test was when they came out in 2014, they still had some issues. They're fine now, and you can see what's going on with Tesla. So that was my first kind of project out of university. And it really taught me how to create something, again, that people love to use. It was kind of visible that Tesla is ahead of its time, and it will be different than any other car company because it was creating technology, not a vehicle with some technology in it, but technology inside just a vehicle wrapping. The main idea that Elon Musk had is not only going electric, but also creating an amazing experience for people to really enjoy when they're in the car. Maybe not enjoy the noise of the engine, not a lot of noise, but everything else around the car, acceleration, experience, and UI, UX, it's really different in a Tesla. So I was traveling around the Tesla factory, NVIDIA, when NVIDIA said, well, we're doing this with Tesla. We like what we see. We're going to go for all the other car manufacturers to see if they can adopt the same technology. And we started traveling. We went to Ferrari and BMW and Audi, Mercedes, Volvo, a lot of the companies out of Europe, some companies even in China, NVIDIA was trying to get into. While traveling, actually I was on a plane or in between planes, someone from Apple called me. She was a recruiter, and the first thing she said when she called me on the phone is, hey, I'm calling from Apple, but our conversation should be kept between us. We have a position open. It's kind of rare that this thing opens up. Come to Apple. We cannot tell you anything more. Come to Apple. We want to show you what it is, and maybe you can think about if you want to join. So so that's how I went to Apple. Back then, the spaceship was not built yet. There were plans for the spaceship to be built. This was back in 2013. And I found out the team and the projects and the actual responsibility was exactly what I was dreaming of. It was actually more. It was about taking what Johnny Ives, which is the main designer back then at Apple, taking what Johnny Ives imagines and what Johnny Ives' team prototypes just with their hands with some plastics and material, not functional, just wrapping around a product, taking that and making it functional from early on stage all the way eventually to try out for this to be scaling to mass production. And you know, you hear about Apple, you see their products come out. What people don't know that's happening behind the scenes is usually when Apple develops one product like an iPhone or an iPad, there are 20 other iPads and iPhones being developed with the same at the same time with just a little bit different technologies, and then a few products that are not at all in the same category of what we've seen. And eventually Apple sees, okay, out of those 20 different prototypes of iPhones with different technologies, this technology is not ready yet for market. Maybe software is not ready, maybe yield is not ready, maybe the UI, UX experience is not ready. This is ready. This is not accurate enough. For example, sensors in the Apple Watch need to be very accurate for Apple to release a sensor that people can use and depend on. And that's what we were doing. We were just playing around with a lot of prototypes, not playing around, actually developing them at Apple first, then in the factories in China to find what sticks, to find what the best use cases are, the best experiences, the highest accuracy that we can get out of some technology, and then it can go into almost mass production. So those were my first few years at Apple. It was kind of like an engineering boot camp. You know, I would always remember the feeling of Sunday evening, because usually, you know, Sunday evening in California is Monday morning in China, and the factory wakes up after a Sunday, usually off time, and things start breaking in the factory, and we get a call Sunday night, our time, hey, line down, we cannot solve it, someone needs to come. And it's 10 p.m., my manager calls me, can you go on a plane in a couple hours, going to Hong Kong, then to Shanghai or Shenzhen, line is down, there are 20 other people that we're flying in to bring the line up. Because every day, every hour is key, especially for something like an iPhone that needs to be released on a very specific date, which means it needs to be ready to mass produce and all the new product line to be copied to 100 lines in China, and then they need to start manufacturing 5 million phones that are ready a week after the announcement of the phone, every day counts. Every day is hundreds of thousands of iPhones not being built. And it's really important, especially after announcement, Apple to have enough supply when there's a lot of demand. So yeah, you fly basically an hour and a half after you get the call. You go directly to the factory, you camp out for a couple of days, maybe sleep, maybe you don't sleep, you don't shower, eventually line is up again, everyone is happy, you go back to the hotel, you sleep, you don't even want to shower at this point. And you know, that's kind of the experience of a boot camp, creating a product on a very contained timeline, basically doing everything you can, no matter what the budget is, no matter how many people need to be involved, no matter if you need to call the government of China to unblock holidays and worker compensation and everything around the factory and in the region that may be happening in China. You do everything you can to make sure something like an iPhone has 10 million iPhones on the day of announcement, so they can actually ship. A few more things about Apple that you may be interested in. So Apple has, as many companies, Apple is developing vertical products like iPhones, iPads, Apple Watches, Apple AirPods, but also Apple and other companies are developing horizontal technologies that can be applied to many different products. So in this case here, I'm showing the Lightning connector. There was a reason why Apple developed the Lightning connector to have this secure handshake between their products and everything else, including power and accessories. And they usually develop this technology and they apply it per a good fit within those vertical products. One of those technologies that I was involved with, that I would say is one of the most complex horizontal technologies, is Face ID. So people know about Face ID a little bit. Maybe you have an iPhone, maybe you're using it. My grandfather is 95. He has an iPhone, he has Face ID, he doesn't know he has Face ID. I think he doesn't remember that we enrolled him. He's just swiping up, and it just works for him. That's the magic of Face ID. But people don't realize how complex something like Face ID is to really develop and deploy into maybe 500 million products, and almost all the time, and by almost I mean 99.99999% of the time, it should actually work. Apple was really ahead of their time on developing something like that, and even up to this date, nothing like that exists. Nothing like that exists even on Android phones. I'm sorry, Android fans, it's a little different there. Nothing like that even exists in the physical world. It took Apple many years, many acquisitions, probably hundreds of millions of dollars, maybe over $1 billion to create this. And you know, why it's so difficult? It's complex, but the thing is, it needs to be very accurate. It needs to work all the time, all lighting conditions, all kinds of people. It should not be spoofed. One of the biggest things about facial recognition is it needs to work all the time. It needs to let you in, but also it should not let someone else in, which is a real hard part, right? You can show a picture of someone on the other side, or now you have those deepfake videos. It needs to work all the time using 3D and infrared and RGB cameras and hybrid different neural nets to really make sure it's dependable. People can trust that technology. And then on top of it, it needs to be cheap. It needs to be small to be integrated in a phone. It needs to be not running hot. It needs to have all the check marks to be able to be deployed in 500 million phones and always work with a yield, from a manufacturing perspective of 99.99999. So that was Face ID, very technical product. Now it's been deployed into iPhones, into iPads, and we were really excited to kind of work on it even from early on when there were just schematics and layouts and some of the prototypes from the different acquisitions that Apple did to kind of get the technology in. This was an amazing experience. And what it taught me is how to create something that's so transparent that people kind of know about it, but they don't have to realize what's going on. It just works all the time, but somewhere on the side. This is the actual magic of technology. But then at the same time, even at Apple, even in all the factories, we were walking around and we're just looking at the physical environment and we're seeing badges, all the employees badge in, and guards, guards standing by the door asking people to badge in. Especially at companies like Apple, security is very important. You sign NDAs not only when you go in the company, but for every single project you work on, no matter if it's horizontal or vertical. Different rooms change security, access control rules. Maybe today the iPhone testing lab will be in lab 1, tomorrow is lab 2, because there are different technologies in there. People move around and tools move around, and the security guards, they don't know. They may be my friends knowing my name, maybe I've shown them pictures of my wife and my kids. They wouldn't really know if I'm tailgating someone after someone badged in, because they've seen my face go through this room 1,000 times in the last couple of months. So how do you solve for this? Well, a guard will kind of look at you. They will do manual facial recognition of your face, and maybe the picture on the badge, comparing it. Okay, you look okay. You can go in. You may badge in, but then someone else can go behind you. And if the guard knows that person, they will let them in. You can solve this with turnstiles, those revolving gates, asking people to badge in all the time. But those turnstiles are not really fit for everywhere around on campus. Maybe in the lobbies, but that's it. So as we were developing Face ID, we said, well, what if we take facial authentication and apply it in the physical world, in the physical environment, in the built world for enterprise, for government, where there are high security applications, where maybe companies like Apple can afford 1,000 guards, but not all companies can afford 1,000 guards, and have the same kind of level of security as if you have a guard, actually better than a guard, for a fraction of the cost, using hardware, software, machine learning, computer vision. So that's how we were thinking about the early stages of Alcatraz. And then we decided, well, it's going to be easy. We did Face ID, piece of cake. We know how to do it. We just have to make a big iPhone and put it on the wall, and we call it a product for enterprise. Not really. Very, very different to develop first something from scratch, something that Apple doesn't develop, and you don't have the thousands and thousands of people as an infrastructure and all the vendors in the world actually fighting to work with you, because they know eventually they will have a contract for millions of something that they will sell to Apple. Very different to develop something that's not in your hand, that you can kind of control the environment of, especially in regards to facial recognition. When you have to deploy it somewhere and forget about it, but then especially in an enterprise environment, which is how we envisioned our product to be used, you have many people going at different angles, different velocities at the same time, different environments by themselves, single door, dual door, corridors, hallways, people going in and out, people not interacting with technology very well. Maybe one person will authenticate with their face, but the second person will have a mask, or maybe they'll be texting. You have no idea what the actual use cases and people's experiences will be, but you have to design for all of those people to make sure you're letting the right people in and you're blocking the not right people out from the facility. So that's what we designed. Very quickly, I'll show you a few videos here to get an idea. Later on in this afternoon, around 1:32, we'll have some of our team members doing deep dive into machine learning, computer vision, hardware, on our embedded product, and how we do the full stack on-prem and cloud development with a bunch of AI, and how we integrate into the infrastructure of those large corporations that we call our clients. I'm just going to go high level here. So that's our product. We call it The Rock, which is the nickname of Alcatraz as an island, as an ex-prison. Now it's kind of like a museum that, you go one time, you just don't want to go again. And the idea for The Rock is it does a lot of things by itself, and we call our category of access control autonomous access control. Just how you have in cars autonomous vehicles, and level 5 of autonomous vehicles is you may not be in the car even. You just maybe stay at home, the car drives around, maybe the car makes money for you as a taxi, and no one actually needs to watch the car. The same thing is the idea for The Rock. People should not really look at it. People should not be interacting with it. It will make decisions by itself based on access control and environments and people, and always have the correct people in and the incorrect people out. A few things on how we developed our technology. We had to make technology that's based on AI so people can enroll fast. Instead of you going to the badging office, you can just badge in a few times with your current badge, and we'll just learn who you are based on your face and badge. And at some point, we'll say, well, we've seen you enough. We kind of know who the owner is. The next time you show up, we'll just see your face, but we output your badge number as if you badged in. That's how we train our algorithms when we deploy The Rock on campus. And then after you badge in, now you can do single factor, dual factor authentication. Single factor is easy, you just go. You can see the experience in the video on the top right. You just go. By the time you touch the handle of the door, it's already unlocked. A lot of complex 3D, RGB, infrared facial recognition with anti-spoofing is happening. Tailgating check in the back to make sure no one is tailgating, and eventually we output the badge number to the access control system to open the door. But the magic is you just touch the handle, and it's already unlocked. Dual factor is something like what we've seen in like online. When you log in into your bank account, you get a text message with a code, but in the physical world, you don't want to wait for a text message or an email. We do badge and face, and the face verifies that you're the owner of the badge, and that's how we let you in. And then tailgating is pretty easy to explain. You go, someone else may follow behind. If they don't belong, then we'll notify security. So what are the challenges really that we experienced doing this innovation? So it's not only about innovation of the product, it's an innovation on how you pitch, how you get investments. It's innovation about how you change the legacy mindset of the buyer, as the buyer is a little bit of an old school type of person, and innovation on how to get real traction fast as a startup. So you actually have the runway to show off revenue. So on the VC side here, it's really hard to get an investment for hardware. We do hardware as a service, but still, to create such a complex hardware, it's kind of like a robot without arms that we had to create. It just takes a lot of money, a lot of time, a lot of people involved. This is not just an app like a Snapchat where you can put it in the App Store and then you can debug if people are having issues and add features and have an MVP within days or weeks. It took us 4 years and $20 million to actually create something that's functional, that we can deploy legally in those companies and people can actually use and even start giving us feedback. VCs don't really invest in hardware because their mindset is, well, almost no hardware companies go to IPO. Almost no hardware companies have huge exits of tens of billions of dollars or even unicorn level status. So the risk is really high. Risk of how complex the product is and what can go wrong in manufacturing. Nowadays, supply chain issues through COVID. How long it takes to develop and test, especially when you go to large enterprise. You don't really get the feedback needed from your customers since they don't really want to talk about there are issues in security and how you can fix those issues. It's just there are too many unknowns, and it's really hard to get investment. I probably heard more than 300, maybe more than 400 no's in my life, and it kind of plays a little bit of on your mindset that, is it good enough? Is the product good enough? Are you good enough? Is the company good enough? And I think the takeaway here is never give up. You just keep going, you learn, you perfect, you just get better and better. So investment in hardware is hard. That's the point here. Going into a large enterprise with a complex product, also very hard. I put down here some of the things that we had to work on, that we kind of call our product. It's not only about the hardware product that we have called the Rock, which is the embedded hardware with all the machine learning and computer vision algorithms. It's about its privacy of the templates and the security infrastructure of the corporations we deploy in. Our customer is a typical Fortune 1000 company, government agency with very high security standards. All the requirements on networking and IT infrastructure, a lot of enterprise level certifications that you have to show, like penetration testing, UL standards, ISO standards, SOC 2 standards to kind of prove that you cannot be hacked, that you know what you're doing with all the biometric data. We had to create this. And then going to those large corporations, we learned early on that they wouldn't allow cloud. We had to develop an on-prem virtual machine, kind of an infrastructure to run all the templates and create our own Alcatraz infrastructure in those companies. The legacy mindset is also a huge challenge for us. So think about who's the chief security officer at Google. The guy can be ex-FBI, ex-CIA cop, 30, 40, 50 years of experience. That guy's job, the main job, is to de-risk security, to de-risk how the employees feel day in and day out around campus, to de-risk maybe cybersecurity in the corporation, to de-risk all the vendors that are deploying software and hardware for security in a company like Google. And those guys don't really want to do anything to do with startups. Startups die, products fail, products are not really well tested. They're early on, especially complex products. So it was hard for us to convince large corporations to give us a try, because then we have to compete with the Nokia, the BlackBerry of the world. Yes, but those guys are well known with 50 years of experience. The security guards, the security guards and the decision makers, they know them. They've been in conferences with them. They've talked to their executive team. They know them in person. And us as Alcatraz, no one knows us. So, and it's kind of hard for us to talk about our real customers, because no one wants to be talked about. No one wants to show publicly that they have Alcatraz as a product within their environment. The last thing I want to mention that was a challenge for us is how to gain traction with the investment that we had. So it was very hard to get investment through many rounds of funding. Usually, this is a good graph, a good time versus revenue graph of a software as a service company. You have an idea, you get a little bit of an investment, it's called pre-seed, then you develop your MVP through pilots, you do some pilots, you get more investment, because now new investors, current investors will see, okay, there is a customer here, a customer there, they are willing to give you some money. If we give you more money, then you can hire more people and scale, and then you get a seed round, Series A round, larger investments to really go maybe into different markets, maybe create new products, and have a successful company on a contained timeline scaling. So that's a good, typical, I would say, SaaS traction representation of what should happen in a company with a potential product market fit. What's going on with hardware companies is it's a bumpy road. It takes a lot more money. You can see here the differences in the dollar signs in the pre-seed, seed, and Series A and Series B rounds. It takes more money, more time. It's a non-dependable sales cycle, especially when you go to large corporations with decision makers that take too long, with many customers inside the corporation, with many signatures that need to be done on the privacy, security, networking side, actual sales cycles that are so long that you really, as a company, as a startup, you don't know what to expect. And investors say, well, we need to give you 5x more money. There are so many unknowns with hardware, with manufacturing, with deployment, with maintenance and operational scalability of the company. It's too much risk. We've seen the other 1,000 companies that create hardware, no matter how magical it is, and 99% fail. It doesn't work for us. So that was our challenge, how to quickly run, and with a little investment and a little more investment, we show our investors there is a real market for this, and we can actually make it. We just have to get a little more money, and we need a little more time. So that's kind of my long story short. I think I want to finish with a few takeaways here. Always have an open mindset, no matter if you're creating your own company or you work for a company that's creating products. The product needs to give real value, and your customers need to love the product. Always talk to the customer and iterate, no matter how hard it is. For us, it was very hard initially to talk to anyone because no one wanted to share the heavy issues with physical security. It's okay to fail. I failed hundreds of times when listening to various nice, gentle no's by investors and other 100 times by customers. It always takes, here it says double, but actually triple the time, triple the money, triple the effort, triple the tears that you will have through a journey to create while dreaming and exploring. Thank you. Q&A now or later? Ivan. Ivan, Q&A now or later? Or Rado? Now? All right, Q&A. Any questions? What are the prospects for us to deploy our technology in private homes? Great prospects. As a company, we're always thinking about how to expand our market and go downstream into mid-sized businesses, small businesses, and eventually residential homes. It's just the technology needs to be more mature, I would say cheaper, be able to be created more at scale. It's actually easier to deploy facial recognition technology or facial authentication technology for homes, because then you don't have to enroll thousands of people and moving templates and enterprise environment with all the certifications. It would take some time to make it perfect for homes, but you can look out for those kind of things in a few years. Kind of like a Nest or a Ring doorbell, but with facial recognition. It will happen. Yes. Can you speak up, please? Can someone repeat that?
Sorry, can you hear me now?
Yeah.
About the bootcamp, if that saves that much money, why weren't you there pre-hand? I mean, if that happens so often, getting a call at 10 p.m., why weren't you there pre-hand so that can be avoided? And yeah.
You're talking about the bootcamp in China, and if it happens so often, whether, so there are many companies, including Apple, that have local engineers, thousands of engineers in those different facilities, like Foxconn, Pegatron, the different factories, the different vendors, bringing up the technologies and eventually integrating the technologies in a new product line to eventually go to mass production. But there is development. As the technology is being developed in China, there is also development in Cupertino, or in the actual office where engineering is congregated in a company like Apple. And every once in a while, we learn about some bugs that only a few people did analysis on. They're experts in those fields. For example, a display technology or a touch technology. Think about PhD, ex-students that dedicated all their life on how to create the best possible touch technology to give you the best experience, for example, right? Though not all the time those people can be camping out all the time or move to China. They may be in California or Germany or somewhere else. And if you need that expert to solve some kind of an issue, through testing, calibration, or bringing up software and hardware, you have to ship that engineer or team of engineers to China. And there's so many issues and so many experts around the world, especially in Cupertino. You just move people around all the time, every week, every day, to really make sure you expedite the line down of that different technology, because you cannot continue through the line when developing a product. If one of 1,000 things, one thing fails, you cannot continue on the next process of the testing or calibration.
One question regarding the long kind of prototype phase here.
Oh.
Sorry. How do you keep the team focused during this long prototype phase? Like, how do you know that you're really focused on the core things and you're not like building features that are not essential or will not improve the actual end customer value? Like, how do you basically know that you're doing the right thing? What is your feedback cycle in this kind of long prototype game?
Yeah, good question. So if talking about Apple, there is no customer feedback, right? Apple invents products with the vision of you make them and people will buy them. You delight the customer after they've seen the product or the product category that Apple is inventing. Many times now, Apple is not inventing a category. They're joining a category that's already there, but they create something that's more perfected, more well-rounded. At Alcatraz, it was really hard for us to get feedback by the customer, because again, the customer is a large corporation or government. They don't want to give us feedback. Most of our products, they're deployed on-premise, air-gapped. Alcatraz doesn't have access to the data. We can't even log in and see what's going on. Even if they tell us our product doesn't work, we have no idea what doesn't work. For them, it doesn't authenticate. So we have to fly someone, an engineer, in to debug the issue. Through this, we kind of get the feedback, okay, that's how we used it, that's what happened. Maybe it's an infrastructure, some kind of wiring issue, and we always try to iterate. Early on, when prototyping, we had some hardware issues, some machine learning, different corner cases of different lighting conditions. For example, I remember a large corporation that also has a huge presence in Bulgaria as a large office. They were doing a pilot with us, and they call us and they said, well, your product doesn't work. We've been testing it, but there is this guy that's trying to authenticate, and it doesn't work for that guy. Fortunately, this was cloud connected, so we could see what's going on. Well, the guy had a mask, sunglasses, a hoodie, and then kind of zipped up to here, and he was trying to run towards through the door with a light shining behind him. And we're facial recognition technology. We need some form of a face. It's like doing fingerprint scanning, but you have gloves. It's hard to authenticate. Fortunately, we were actually able to solve a lot of those challenges with just data and training of new neural nets to kind of compensate for the different lighting conditions, different skin tones, maybe not needing the full face, but a portion of the face, which affects accuracy, but the experience is also important depending on the deployment and how many people enrolled. And then you just go. You deploy the new software to the customer, and you get their feedback. And then if it's great, then you deploy to everyone else. And that's how you kind of solve for all the different corner cases of whatever you didn't test in the lab, right? But it's one out of many, but not enough feedback cycles we have, just because our customer is not a typical customer. They're very limited in what they want to share. Thank you so much.
Здрасти. We have 10 minutes break. Моли?
Радо.
Иво съм аз.
Аз Иво.
Здрасти.
Ти си Врабчев? Не,
Връбчев,
Връбчев, как те представя?
много
Да.
трудно може
Да,
да
аз
се
се чудех, като понеже аз ще представя.
Пробвал съм и суи само не става.
Извинявайте. Андрей,
Ако
чакай,
сбъркам.
тук ли?
Не знам къде е. Не съм го виждал.
Този с злата глава ли там?
Аз не съм.
Той е неокабелен.
Добре, трябва да му кажа.
Да.
И аз ще го представя.
Ники?
Аз съм за другата зала.
Аз се защо да ви чакам тук.
Тук ли се? Ама той микрофон трябва да стане тук.
А къде е? Къде го видя, Андрей?
На стената трябва да се окабели.
Аз чакам да дойда тук, защото ще чуя какво става.
Гледайте имената на хората, защото и те се бъркат коя зала коя е. Това е другата зала.
Ама да върнем микрофона.
Върна го. Реклами? Да, винаги реклами. Винаги в чивката реклами.
SAP focused on making businesses run better by pushing the boundaries of innovation and impacted the world and people's lives beyond anything the founders ever imagined. With 50 years of groundbreaking work, SAP will continue to lead the way with innovation and help the world run better and improve people's lives.
Значи това електро на мен ми трябва да го представя само.
Искате ли такъв или дръжка?
Често казвам, май така по-добре да можеш дръжката да...
Stripes Bulgaria was founded in 2008 by the Dutch entrepreneur Koen van Wijk. His vision was to create solutions that exceed customer expectations. Since 2014, Stripes is part of the ICT Group in the Netherlands. ICT Group is a stock-listed company on the Amsterdam Stock Exchange and employs more than 1,000 professionals. Since 2017, I have the privilege and honor to drive Stripes forward in the role of CEO. We offer solutions to our clients in digital transformation, smart applications, and infrastructure. Our mission is to build smart solutions that create business impact. We are Stripes.
We're a pretty resilient species, and that's true now more than ever. So we deserve app experiences that are as resilient as we are. This starts with apps that can scale to keep pace with shifting demand, or update at a moment's notice to support entirely new business models. In a time when the app experience has become the human experience, being future-ready means keeping people at the heart of innovation and flexing to meet their needs. Because technology really can change the world, but the best technology changes with it.
Merkle започват официално в България на 1 януари 2022 година, но двете компании, които обединява са на нашия пазар доста по-отдавна. Isobar Commerce и Life Area стартират съвместна работа като част от новата бизнес линия на Merkle Commerce and Experience. Аз съм част от това семейство от 13 години и заедно с много мои колеги преживяхме най-различни метаморфози на фирмата. Започнахме като малък стартъп, наречен Nicomera през 2008 година. Тогава
Okay, so it's time for our first lecture. Our first speaker is Andrei Shakirin. He has long years of experience in splitting monolithic applications, and now he's going to share his experience with us.
Hi everybody. Let's see that my slides already working. Yes. Yeah, so after very interesting presentation from Vince, we'll dive a bit more technical stuff, and I would like to share my experience regarding microservices today. Shortly about me, I'm working as a software engineer in Vivint Labs. So basically our style of work, we make a very short engagement by the customers, very different customers from very different business domains, and try to help to teach the customer to modernize the applications. Normally it's legacy applications, or applications have some problems, some challenges. We have normally 4 or 6 weeks to understand the problem, find the way how to modernize it, and take a small slice and get it ready until production. This is my kind of daily work. Also quite active in the open source community in Spring and Apache projects, and sometimes I speak in the technical conferences. What is the plan for today? I would like to make a short introduction what is the difference between monolith and microservice architecture. Should be highlight that there's no bad or good architecture style. Every of it has pros and cons. After that, we'll stick into the one use case I did 2 years ago for e-commerce online shop. This is very good case to demonstrate how monolith architecture iteratively split it and transmit it to the microservices. Also, we'll go through the pros of the monolith architecture. There's a lot of pros of that, and go in the way how to iteratively migrate or evolve the system to the microservice world, and to go through the challenges of the microservice and highlight the solutions for these challenges. Make some conclusions and lessons learned and recommendations. So first of all, what is the difference of the monolith and microservice architecture style? From my point of view, there are some aspects. This aspect is the most important. The first is system design. So monolith system is designed from scratch as a single large complex system. Yeah. Microservice is designed as a set of independent subsystems, let's say more or less independent. Of course, there are some relations between them, but the goal is to keep these relations as less as possible and as weak as possible. So it's more or less loosely coupled. Codebase. So normally for the monolith we have a single repository, monorepo, and for the microservice we have repository per subsystem. It's a bit different in terminology, business subdomain and microservice. We'll go on that later on. So for the subsystem, here I mean really business boundary context. So for the business domain, we split based on the business logic and domain logic. Not based on some technological or technical aspects, but really from the business side. And we try to find kind of the boundary context. What is the areas more independent from the other, but really from the business point of view. And after that, you design a microservice. It could be the case that we have more than one microservice per business boundary. We'll talk a bit later about that. Deployment. So in monolith system, we have no other chance as deploy the whole system. Yeah? So either all or nothing. Microservices are independently deployable. Data store, normally also monolith system use a shared data store, where there's different components talking with that, and microservice vault, where that data store is split, is independent, is also per boundary context. Communication in the monolith system is kind of local communication, and microservices, we have to communicate remotely, so either using REST, HTTP, or messaging, asynchronous communication. Technology in monolith, we have to use single technology because it's normally deployed as one process. And microservice, we have a choice. We must not, but we have a choice to use different technologies for different processes, different microservices. Okay, so let's go to the concrete example I did 2 years ago with my team. It was e-commerce domain, so the online shop, and setup was so the business domain was just typical functionality of e-commerce. So we need to implement backend and frontend functionality to manage users, able to show the products, add the product to the carts, go to the checkout, pay for that, organize fulfillment, delivery, and so on. This is the domain and use case. It was 4 teams, each team about 7 or 8 persons. Technology was initially use Java, deployed on OSGI container, use a Hibernate, PostgreSQL, Karaf as a container deployment, ActiveMQ for messaging, and Apache CXF as a REST implementation. And it was used as Scrum methodology. If we look into the architecture, in the middle, I have see as a backend that exposes some REST API for the external clients. Of course, the front end that provide a web interface for the users. There are some external consumers, special consumers also use this REST API, mobile applications. There's some storages, PostgreSQL later on use also MongoDB, ActiveMQ for the messaging. SAP was used for financial and Buchhaltung. It has also connections to some external creditworthiness check system to check the customer, is it able to pay invoice or not, and online finance system payment providers to pay. If you look inside this backend, you see there are already some kind of services with a REST API, but the whole application was deployed in the single container. So it's all run in the single Java virtual machine in a single process. We have already some splitting here with some user service, card service, article service, but the team decided we have some shared functionality between the service, let's put it into the domain. So if there's some functionality shared between service, it will come into the domain. And this one is also usual case, some common stuff, utilities, common business logic. Let's use it everywhere. Let's put in the located in the core domain, and it was quite big. Connection to the SAP messaging and database was done using connectors. This is the internal architecture of the monolith. What was the good with monolith? What is the good experience with that? First of all, I would say with monolith we can make a very fast first steps. So first achievement was really fast with the monolith. We should not care about distributed architecture, distributed system monitoring, just develop in the single repository, deploy it, and it works. Build-in deployment was quite simple. Yeah. We also have a single pipeline where all the teams are using for the build. Communication between the system components. We also shouldn't care about some distributed stuff and remote communications, or it was just local Java interfaces. So there's some isolation, some splitting between the components, but it is done using the local Java stuff. Easy monitoring. So it's just single process, single Java virtual machine. It's monitored, it's quite easy. Teams have also the same deployment, development and deployment rules. So they could be not optimal, but at least it's the same for all teams. And administration for DevOps perspective, it was also easy because it's homogeneous. So just one process, one kind of storage. It's from DevOps perspective, it's easy. Yeah. So this is really was pros to use to start with a monolith architecture. And I normally also, by a customer, I recommend to start not to start with the microservices, start with monolith. I'll discuss the reasons afterwards. But from other side, especially when the teams are growing and system are growing, we're faced with some problems, with some issues. The first one, what I observe, that the upgrade to the new version of Java, versions Hibernate becomes more and more difficult. So, for example, migration to Java 8 takes about half a year, so 6 months until all components will be migrated. The reason of that is we should migrate the all applications. They have no other chance. So all the teams should migrate the all components. Yeah, so in the separate branch, should be tested for the long time. We need to keep a parallel version of the whole system. It's quite long, quite difficult process. Second one, resilience. Yeah, so our container use the same thread pool and database connection pool for all components, for all services. And for example, if we have a high load on the product service and the thread pool is hosted, then we have also a problem with the user service, login with the card service. So basically, the whole system stacks. Shared deployment. Yeah, it's easy. A lot of cases when the one team not care about their part and make a deployment is read, and all other teams should wait until the deployment is repaired, because all the stuff, all the components are deployed in the single container. Development cycle. Yeah, development cycle becomes longer and longer. So this time until you commit, make changes, and you can test this change grows, because also locally you have more complex system, complex deployment. Especially if something doesn't work, you need a lot of time to find out what exactly the problem is. Innovations. Yeah, so try something new and adapt something new becomes also a bit difficult with the system, because you should care about other teams, interconnection, other components. Not all products is adapted and working in the OSGI container, so it becomes a bit problematic to try some new things. Scalability. I said already, some services in the e-commerce have a different load. For example, product service have very high load, and user service not so high. So users not so often log in as a search for the products. But we cannot scale it separately. We either have a chance to scale the whole system, the whole monolith, or nothing. Therefore, a lot of resources is unused, so the scalability is really limited in this case. And learning curves, if the new persons come into the team, I see that there's more and more time to understand the whole system, how the system works, how the deployment works, and start is really slow down. So sometimes people need 2-3 weeks or 4 weeks just to make a first commit and try something. This is just my observation. The decision was, yes, we perhaps need to split the system is too large. There are a lot of people working on the same stuff, and we need to somehow to split it. We go to our managers and say, yeah, it's not very nice situation, so time to business is very, very large. We need more and more time to develop new features. We need to split it. And we need perhaps, I don't know, 6 months time to redesign the whole system. Management says there's no chance. Yeah, we have a plan for new features. Our customers waiting for that. Sorry, but we cannot stop development for the 6 months. What is the solution of that? We propose kind of iterative approach. So I also recommend for all customers to do it iteratively, not to try split and redesign, re-architect the whole system in one time as a big bang. Try to identify the parts and split it, make it working in production, deactivate in the old system, then find another part. So really do it iteratively, and after each iteration, the system should be deployed into production and working. So it's not only kind of experiments, but it's really production works. And the first step, I say step 0, what is very important, to abstract the consumers from the container. So consumers will talk not directly to the REST API of the container, but we put a component with a gateway, with name gateway, that have a control, they have a flexibility to redirect a request either to the old monolith system or to the new microservices. Sometimes we also do canary releases, not for all parts. That's some part of the traffic still goes to the old monolith services, most of the traffic. But we try, for example, 10% traffic for the new, already new world, and see if it works stable, it is okay, we redirect more and more traffic, and then switch the 100% traffic on the new system. This is a step very important to abstract consumer from the details of your API and have a flexibility to redirect the requests. Step 1, I also often recommend the customer what is a good start. Yeah, what is a good start to split a big system. I recommend to find the easiest service that have less as possible dependencies or the others, and go the easy way first. So that take the easiest one. In our case, it was address microservice. It was quite isolated. It was simple one, and extracted. So it improves the motivation of the team if we have a first achievements already, and also the team trains how it works. And all the technical aspects of the microservice, like monitoring, tracing, deployment, is also tested on these simple components. I always recommend to start with the simplest one. So in our case, it was microservice. We split it quite easier. Like I think we need about 2 or 3 weeks to get it to make it into the production. The next step was a bit more complicated, and decision was made because scalability. So I said the price and availability microservices have very high load. So almost every request for the card or for the product detail page requires to display to show product details and prices and availability of products, of course. Therefore, load of this service is not comparable with load, for example, with a user service. Therefore, we need to scale it independently, and this was the reason why we extracted. So the price and availability microservice was extracted. It was also not a very complicated stuff, yeah, but this already we have some achievements that we can scale it. So you can we can arrange more than 3 instances of this, arrange 5 or 10 instances to make it also flexible, depends on the load. So the middle day or in Christmas time, it's more instances as another time. The next step was more complicated, so I show the architecture. They have these domains. And domains was a huge problem because they share it between the different services. So the teams, different teams works in the same code base. It's already was quite painful. How to deal with that? I decided that time for very easy solution. Perhaps I also recommend for a lot of customers to go this way. We just make a copy of the domain the first time. So every domain becomes a copy specific for this service. And we have a clean split of the code. Of course, we have some duplication. Yes, so the dry principle, don't repeat yourself, is violated, definitely. And for some bug fixes and features, we need to do it in the 2 or even 3 places. But the gain from that was the more important as drawbacks. So the teams, every team has their own code base, they own the code, and have the full flexibility to improve it iteratively. So they delete the stuff that they don't need. Redesign, of course, it takes a bit time, but they can work independently, have their own plan, and they really own the code. They also increase motivation of the teams. Also, a huge problem was the core domain. This the staff common component that the all common functionality living on. For this, I decided to split. Recognize business related stuff and business related functionality common into the also services domains will be joined to the service domains, and some technical functionality that's shared for the all projects was put in the kind of third-party library. So you have it still has its own repository, has its own release lifecycle, and we just use it as a third-party dependency in the services. So this way, but it's only technical stuff, not any business-related functionality is there. Yeah, so after that, we reach this state that the servers are independently deployable. For deployment platform, we use a Google Cloud with a Docker and Hibernators. But it's not cleanly independent because it still uses the same storage. So for example, user service, card service still have a user table with a foreign key to the card, and service user joins to get this information. Therefore, they're not completely independent. If the card team changes something into the schema, into the data entity, user team should also adapt their own code. So it's also still possible to break it. Or if some table has a forgotten index or log, then the other service immediately fill it. So it has influences still interdependency between the services in sense of storage. And I would say, yes, it's unfortunately, it's the most complicated part. So split the code is not so difficult, split the components. You can copy, in the worst case, you just copy it and live with the application. But split the data, it's the most challenging part of the splitting microservices from my experience. We use two different approaches to resolve it. First, is related to user service. They just instead go indirectly to the database, to the user tables. It uses the REST interface of the user service to get this information. So if you need some information about user, just call user service using REST API. Yes, it's a bit, in performance sense, it's a bit longer. But as far as we have horizontal scalability, a good network, so the performance impact is not so bad. But the gains is, of course, so independent deployment and independent scalability. That brings a lot in this case. Another solution, it's a bit different between cart and checkout service. We use a different approach. In this case, have kind of replication, asynchronous replication between the services. So the card service has our own table, card tables in their own database, and checkout service has basically a copy, so replicated copy of the card information. And if something changed in the card, we just publish a message. Checkout service listen for this message and make appropriate updates in the card information in their own database. So in this case, the database is independent, and they are synchronized using the messaging mechanism or asynchronous mechanism. So after that, we reach the state when the services are independent. They use independent data storage. The teams could deploy they are separately independent one another. And the time to production, the feature development, they really improved essentially. Yeah, so instead implementing feature 2 weeks, we need sometimes 1 day or 2 days to bring them in production. So the management really sees the goals of that. But the microservice is not a free lunch, and we faced for some challenges, and we need to solution for some for these challenges. So I split it to the 2 groups. The first is technical-oriented challenges. Okay, the first one is quite easy. We definitely need the CI/CD. There are no chance. With monolith, basically you can do some steps manually or investigate something manually. For microservice, no chance. So if you have more than 10 microservices, to do something manually is absolutely no-go. Monitoring solution. Yeah. Also, sometimes for monolith applications, possible to start monitoring tool, see what happens in the production. For microservices, a lot of number of processes, virtual machines, so we need some kind of central monitoring stuff, which we see the health status of all systems. It's absolutely necessary. Logging is the same. For microservices, it becomes more complicated because in the monolith, have basically one place where all logs are. You can just look at, grab something for error. Microservices, you have about 15 or even more if there's a lot of instances created machines, and every machine has their own logs. And looking something into the distributed logs is not possible at all. And it's absolutely necessary, in my point of view, to have a central place we can search for the all logs. So that's the problem. It's really helpful. We need solution for that. Message tracing. Also, microservice, what is important to understand where the problem happens. If exception happens, in which components it was. If you have a slowdown, to understand who is responsible for that, especially in chain calls. Is one service called another service. So we need to understand where the message is. So for that, tracing, so traceability and debugging possibility is absolutely necessary. There are also some organizational challenges. Features requires changes in the multiple servers. Sometimes it happens in the business that we need to, make it feature to go with feature into production, we need to changes in the some microservices, how to manage it. Wrong splitting and the team responsibilities. Yeah, sometimes we make a mistake by splitting the components, the microservices, and they are quite expensive, I would say. Release cycles and central quality assurance was also becomes more difficult because in the monolith world, we have a clean lifecycle scheduler, and after each period of time, or after each phase, QA validates the system, verifies, and say, yes, we can go to the production. In microservices, every team is responsible to deployment, and deployment, so release cycles are not synchronized, so every team decided when it's deployed, and central QI was not so easy. Yeah, it's still possible, but not definitely more difficult as a monolith world. Sometimes it's also difficult to recognize, is it feature already in production or not? So is it all teams, all domains are implemented already, and we can enable it for user, or not, because the teams deploy independently. Okay, what about the solution for that? For technical CI/CD, yeah, we use Jenkins for that. this Spring Boot application was packed into the Docker container and using the Jenkins deployed into Kubernetes cluster in the Google Cloud platform using Helm charts. So the build was completely automated. Even in later on for some services make based on commit. The whole integration, when the whole integration and system tests are green, the components will be automatically deployed into production. So for some service, it's not for all services, but for some service we have such kind of state. Monitoring. We use some commercial product named Instana for that. So we also provide some product to monitor the stuff. I just say that's quite important to have such a tool and monitor not only system resources like CPU, memory, state, number of threads, but also would be nice to monitor the durability of calls, how long the calls takes, how long the database communication takes, and so on. So such kind of parameters. Sometimes also business parameters, how much requests per second we are processing, and what kind of request is coming on is absolutely necessary. So I was quite happy with Instana. Get a huge job, good job. But as a commercial product, you need to buy the license. For login solution, what we did, every service produces own log, written in the system out. And we use a flying bit parser to prepare this kind of logs and put it in the central Elasticsearch log server. So you can really, single central place, you can search all the logs that produce the system. For the tracing solution, we use Spring Boot Sloys based on Zipkin Brave, and idea that every message becomes an ID, and you can monitor the round trip of the message, and you can really recognize which component message is coming in, coming out, how many times it takes to process the message in the single component. So the round trip and message was monitored. I really recommend to look on that. It's open source. Sloys is a component of Spring Boot that based on the Zipkin Brave open source project. What we do with organizational challenges. Features span multiple services. Most important was if they make some changes in APIs, so external APIs which are used in another component, do it in the compatible way. For example, if we need to rename some attributes, we just first add the new one, wait until all the system is migrated, only afterwards deleted the old one. So the change should be compatible. In this case, you still can deploy independently. So if you deploy the new version, all components, all other microservices not broken. Communication between the team is still necessary. Yeah, so if they develop the feature that goes through the many microservices, it's still possible, still necessary to have some communication and common solution. But I would say if it's too much such situations, if you see that every feature requires changes in more than one microservices, perhaps something wrong with your splitting. You should rethink either your boundary context is still correct. Perhaps go a step back and refactor, redesign the responsibility of the microservices. Splitting seamless responsibility. So it's exactly the point. Mistakes in the splitting of the microservice is expensive because it also requires some organizational change. If you split microservices in the wrong way, you split the teams in the wrong way, and to fix it, it's quite expensive. So you need to reorganize the teams, reorganize the repositories, pipelines. Therefore, it's also the reason why I recommend to start with monolith. In monolith, you can take the experience sometimes and really see where's your boundaries, where's the boundary context, where's the stuff functionality that fitted to the microservices. But of course, system evolves, and with the time, you need to refactor, rethink your responsibility, especially the signs, really, if the feature requires changes in 1, 2, 3 microservices, perhaps something wrong, and you need to compose it together or split it, split it in more smaller part, or merge the services together. Release cycles, the central QA, here it just, the teams should really take responsibility on that. Still, from the development, from the implementation feature to deployment, and also care about production bugs and if something happens production. DevOps, central DevOps is still there, but they just provide the rules and help the team to resolve common problems, but they not take responsibility for every production error, production problem. Conclusions. So the most important is no silver bullet architecture. They're not solution for all problems. So for some situations, some cases, monolith is the right choice for some microservices. Especially for the start, for the greenfield, I always recommend to start with monolith. You have a fast progress, you understand your business domain better, and you make the splitting later on with high quality. Starting with monolith is faster. Also, splitting monolith to microservices not only because it's cool. Microservice architecture is cool, and we produce 20 microservices and nano-services. But you really need to have a good reason for that. I mentioned this. This could be scalability, could be responsibility between the different teams and business domains. It could be performance and resilience, that you could abstract communications with some external team from the external components, external systems from the rest of the system. But you really should have a good reason to extract the microservice from the model. So it's really not prefer, I would say it's must to do it iteratively. Not try to do it from scratch as a big bang for the whole system. Start with one simple server microservices, try it, then decide to do it to the next one, and after some iteration, the whole system will be migrated. Starting splitting with a more simple and less dependence services to have a good experience set, and after that decide for the next candidate. And of course, so be aware about the technical and organizational changes after the split, and care about solutions for that, like CI/CD, central logging, tracing messages, monitoring, asynchronous communication that you will need for the microservice architecture. Also, the mistakes in the boundaries are quite expensive. Here, we really need to think more than one. And already in the monolith, you can recognize, you can also design. It's a bit independently already to isolate, decouple it using Java interfaces first. And after that, the Java interfaces will be based on the external API for the microservices. And you can test a bit in monolith stuff, and only after that extract it. So basically, it's all from my side. From my experience with this project and some other projects. Do you have any questions?
Hi, I'm Dobry from SAP. I wanted to ask about your opinion related to the feature flagging services, like services that can help you to bring some consistency in the releases when you roll out the new features that are deployed in several microservices or require the changes in several microservices. Do you explore such solutions? Do you try out of them? What is your opinion?
So when the changes really influence and have into the more than one microservices, you mean? Yeah?
Yes, and do you use such feature flagging techniques like feature tolling, central service for the feature flags, and so on?
Yeah, so the first one, I really a big fan when the new feature or fix happens only in single service or single boundary context. So boundary context could have also some microservices technically. A typical example of that, if you have some service, it's exposed functionality, and we have some batch process, for example, that one per day scans something and imports the external information. They works with the same data and they belong to the same boundary context, and they is the single team responsible for that. And I'm a big fan to have every feature is limited to the one boundary context. It's not goes through the all or more than one boundary context. In this case, it's quite simple. So the team, only one team responsible for that. And normally 80–90% of features should be in the single boundary context. Yeah. But of course, yes, it's real life. We have some exceptions of the rules. And there are some features that need to be done in more than one boundary context and deployed more or less synchronously. In this case, yes, most important is to not to break the changes. If one team is faster as another, they implement the change, make the compatible API first, that not to break the other components. Also feature toggles I use for that, so you can deactivate features on the first time, and then after all other team are ready and deployed, activate the feature toggle. Yeah. And of course, communication with the team is important. But I would say if you see the 30 features takes more than 80%, then perhaps something wrong with your splitting into the microservice or boundary context. Yeah. You need to rethink it to minimize the features that go across more multiple servers.
Okay, thank you, Andrei. And let me remind you that if you have more questions or something to discuss, you can reach out to Andrei in our Meet the Speaker point right after this call. And another thing to remind you, next session will start in 5 minutes. Thank you. it is time for our next session. Our next lecturer is Ivo Vrubchev. He's an experienced solution architect and DevOps engineer, and he's going to talk about another hot topic, software and sustainability. Welcome to ISTA.
Thanks, Rado. Hello, hello, everyone. Welcome to 12th edition of ISTA conference here at Sofia Tech Park today. I'm glad to be here with you and see so many happy faces. Today, we are going to encourage smart people and full of energy people like you to dream, explore, and innovate. My name is Ivo Vrubchev, and I'm Global AWS Lead Architect at SoftwareOne, as well as I'm AWS Ambassador. Hence the reason all my examples today will be related with the public cloud provided by Amazon. The climate is changing, right? Temperatures are going high. We see a lot of anomalies out there. Day after day, year after year, in the last decades. Here's the reason, compared to the NASA report, the last 10 warmest August on record have all occurred since 2009. It's obvious. Our planet is struggling. Here's the reason it needs our help. It needs your help to contribute to global sustainability. Let me see how many of you are doing something in that space. Who is using paper bags instead of plastic bags? Please raise your hand. Good, good, good. I'm glad with you. How many of you are driving electric vehicles? Yeah, they're quite expensive, huh? Hope we'll see them soon on the comparable market with other vehicles, but we'll see how it goes. All right. The other things that we can do is eat less red meat. At least my wife is telling me that. I know, like IT person, it's quite tricky because most of us like burgers, right? So this is one of the things that I am still refusing to do, but know that it can contribute to the global sustainability a lot. At the moment, there are 4 areas of focus that we can contribute to. Decarbonization, water, where our ultimate goal is to consume less and keep clean the water. Social responsibilities, know your supply chain and what the companies that we're working with, they're doing, what their practices within the company. And last but not least, circular economy. A zero landfill is our North Star. Recycling, it's the next one. Let's see who of you is collecting its garbage separately for recycling. All right, very well. So we can continue in doing more and more, day after day, week after week, and improve our contribution to the global sustainability. Everyone is responsible for that. But there are big players in the market today that are putting giant effort to improve the overall situation in the world. Public cloud providers, for example, are one of those. Amazon committed to become net zero till 2040. Those are 10 years in advance before the agreement, the Paris Agreement that has been made a couple of years ago. The ultimate goal for all the companies is to become net zero by 2050. That's the reason we have a lot of investments. Some of those probably are reasons for the energy crisis that we are seeing today, but we'll see in the future how it goes. Next important thing that AWS are investing in is to achieve this decarbonization is fully using renewable energy. At the moment, they're on their path for all processes, data centers around the world to use renewable energy by 2025, which is just 3 years ahead of us, and 5 years ahead by their commitment. They promised to done this in 2030, but they're almost fully renewable. Hence the reason, if we start using public cloud today, and the examples that I'm going to give you are related to AWS, but they can easily be translated to other public clouds as well, because those giant companies are putting same effort all over the world to improve the situation. If we use the public cloud today, we can improve our consumption of energy by up to 80% compared to conventional data centers. This is very important because all the resources are not unlimited, and using renewable energy is the key for us to improve. Just going to the cloud, it doesn't mean that we don't have anything else to do. Last year, AWS announced shared sustainability responsible model, where we're talking about sustainability of the cloud. This is the area AWS is responsible for. What materials they're using in their data centers. How much energy they're consuming into those data centers. How they're patching the servers, how they're doing the cooling, how they're spending the water, how they're cleaning it. We are not responsible in that. This is all done by AWS. And using the modern technologies, they're optimizing it day after day. But our responsibility is sustainability in the cloud. When we build something into the cloud, it's key for us to know that we need to properly manage the storage. We need to use code that is more efficient. We need to use platforms that are scalable. And software application design is important as well. Data and the utilization is also very important for us. And we should focus on those elements while we are building our architectures. Since 2015, we have well-architected framework. I'm pretty sure that those of you that are using public clouds are familiar with well-architected. It had 5 pillars: operational excellence, security, reliability, performance efficiency, and cost optimizations. 6 consecutive years, those pillars were not changed. During the reInvent last year in Vegas, very good place to announce something, AWS came up with sustainability. Oh, apologies, the slide looks like a little bit broken, but the sustainability pillar. This shows us how serious AWS are taking the sustainability. In that pillar, we have 6 design principles that are helping us to streamline our architectures. Understand your impact is the key. Establish sustainability goals and measure them and improve them day after day is very important for us in order to be able to understand and maximize the utilization of our architecture. Anticipate and adopt the new hardware and software is also the key, because things are changing. We should not use old architectures or hardware or software when there is a new one, modern one, that is consuming less power, it's more green, and help us to achieve better sustainability. If we rely on managed services that public cloud providers are giving to us, we are already inheriting all those practices implemented by their team. Reduce the downstream impact of your cloud workloads is also important for us. So following those 6 design principles, we can streamline our architectures. How many of you believe that sustainability living is expensive? Please raise your hand. Yeah, you're right. Most of the time, sustainability living is expensive because sustainable products are costing more than the conventional ones, because the raw materials are expensive and the technology is not advanced enough to help us to build something with less. We're in transition phase. I hope in next decades we will see this assumption to disappear and this to become the new normal. Sustainability living is important. In the cloud, this is not true. Digital transformation means also sustainability transformation. Sustainability means consuming less and getting maximum of it. It's very important to understand that because when we consume less, that means our cost is going to be decreased in the end. Where to start from? At the moment, AWS have a lot of renewable farms all over the world. In Europe, we are safe. Almost all regions are fully renewable. States are following the challenge in Asia. We all know why. But where we should start from? We should start by picking up the right region. Of course, for our business, we need to store our environment close to the business, but also we need to pick the right region with sustainability in mind. We need to place our workload close to the renewable farms because that will guarantee us we are using the right green power for our computer servers, containers, everything that we use to build our modern application. We can improve and architect our environments on 4 different layers, doing small things, and grab the low-hanging fruits. Then on the network layer, we can do read local, write global, and also compress the data that we're transmitting over the network. If we implement that, we will consume less energy and we will need less devices to transmit all our data all over the world. Next one is the storage. We must stop assigning giant hard disks into our servers. On every project that I have been working till now, there was no case where at least one server had 100 times more space than it's actually consuming. This is a huge waste, right? If we have 1 terabyte and we're consuming 1 gigabyte, there is no sense to sit there. We need to remove it. We need to decrease that storage. By decreasing that storage, we will optimize the overall consumption. Data formats and compression are also key. For example, we need to compress, we need to use modern formats that are consuming less storage in the end. For example, columnar formats are consuming less storage compared to row-based. Packet for JSON, for example, and CSV, we can replace those formats based on our needs. Next one is the compute layer. Here, we can do a lot. The public cloud is built to be elastic. Pay as you go, you know what are the benefits there, but we need to properly architect them. We should not treat it as the next data center. We need to scale based on our demand. We should not keep plenty of servers up and running, just sitting and wait for connections. We need to optimize them, build out-scaling groups, and also right size for those that need to stay there. We can leverage a lot of benefits if we use modern CPU architectures. For example, Amazon have their silicons because they're investing in that space as well. Graviton 2, Graviton 3 can give us up to 3-4 times better performance per watt, which is a significant improvement. They have deep learning chips for computer vision, which can give you more efficiency because they're built for specific reason. Hence the reason, if we know all those things, we need to build our architecture properly, and in the end of the day, we will consume less energy and be more effective. There is no sense to have one server that is most of the time 10 to 20% utilized, and in the end is serving few connections. We need to right-size this. We need to properly estimate what we need and utilize it based on our needs. And of course, the top layer on the application layer, I'm glad that Andrei go before me and explain you all about the microservices and how to change the monolithic to microservices. This is important because if we have just one monolith, we cannot do much with it. It needs to stay there, needs to be up and running all the time. But if we break it down to microservices, we can start leveraging the serverless architecture approach together with the event-driven, which means we will consume specific elements of the infrastructure only when we need them. They should not stay up and running for us. We can request when this is needed. And last but not least, we should pick up our languages very properly. Because I love Python, don't get me wrong, but Python is 75 times more energy consume more energy compared to C, for example. So if you have a heavy lifting process that requires a lot of compute operations, we need properly to plan and reorganize our software with efficient languages and serverless approach. Let me give you an example of on a project that I have been working last year. We had to migrate a workload from on-premise to AWS. Typical workload, 20 virtual machines. We did lift and shift. We put it there. After the first month, the bill was 50K. Because it has giant virtual machines, it has heavy operation inside. And we decided, OK, let's modernize this. We start doing exactly those things. We break down everything to microservices. We consume them only when we need it. We change the storage. We put tiering. The frequently accessed data was on the hot storage. The infrequently accessed data was moved to colder storages down there. In the end, the result was quite good. We become more sustainable, but also we saved a lot of money. The next month, when we applied the modernized version, our bill had been decreased by 10 times. The total cost that we paid, it was 5K, not 50, which is significant impact. And we can achieve that if we follow all those practices that public cloud providers are giving to us. Before I wrap up, I would like to introduce you the AWS Custom Carbon Footprint tool. This is something that we cannot see every day. There is no single tool in the world that can help you to measure our emissions, right? But since last year, we have a tool that is helping us to see how many emissions we are saving by using AWS, and also how many emissions we are estimated to save and measure based on our improvements. So month after month, we can measure all the small changes that we are doing in our architecture, how they're looking in the end, and how we impact in the environment. Let's build, optimize, modernize with sustainability in mind, because that will help us to save the environment for our future generations. Thanks. In order to catch up with the schedule, I will take all the questions into the Meet the Speakers room. Thank you, everyone, for being here, and let's go and be more sustainable tomorrow.
OK, we'll continue in 5 minutes.
SAP focused on making businesses run better by pushing the boundaries of innovation and impacted the world and people's lives beyond anything the founders ever imagined. With 50 years of groundbreaking work, SAP will continue to lead the way with innovation and help the world run better and improve people's lives.
Stripe Bulgaria was founded in 2008 by the Dutch entrepreneur Koen van Wijk. His vision was to create solutions that exceed customer expectations. Since 2014, Stripe is part of the ICT Group in the Netherlands. ICT Group is a stock-listed company on the Amsterdam Stock Exchange and employs more than 1,000 professionals. Since 2017, I have the privilege and honor to drive Stripes forward in the role of CEO. We offer solutions to our clients in digital transformation, smart applications, and infrastructure. Our mission is to build smart solutions that create business impact. We are Stripe.
We're a pretty resilient species, and that's true now more than ever. So we deserve app experiences that are as resilient as we are. This starts with apps that can scale to keep pace with shifting demand, or update at a moment's notice to support entirely new business models. In a time when the app experience has become the human experience, being future-ready means keeping people at the heart of innovation and flexing to meet their needs. Because technology really can change the world, but the best technology changes with it.
Merkle започват официално в България на 1 януари 2022 година, но двете компании, които обединява са на нашия пазар доста по-отдавна. ISTA Commerce и Life стартират съвместна работа като част от новата бизнес линия на Merkle Commerce and Experience. Аз съм част от това семейство от 13 години и заедно с много мои колеги преживяхме най-различни метаморфози на фирмата. Започнахме като малък стартъп, наречен e-commerce през 2008 година. Тогава празнувахме успешен декемврийски ден на коледно пазаруване с цели 1000 онлайн поръчки за 24 часа. През 2015 година e-commerce беше придобита от ISTA и стана част от бизнеса на Денцо. Това ни позволи да спечелиме нови вълнуващи клиенти и на последния черен петък през 2021 година достигнахме пикови стойности от 1000 поръчки в минута. През цялото това време сме разработили и внедрили над 400 transactional сайта. Работили сме с клиенти в над 60 държави и имаме онлайн магазини на 6 континента. Качеството на кода и поддръжката ни е ненадмината. За това свидетелстват и нашите клиенти, с които работим заедно вече повече от 13 години. Днес сме Merkle и целим да поставим нови рекорди с качеството на кода, който пишем.
Няма
Well, it's time for our next speaker. It is Krasimir Kostadinov. He's engineer, architect, and programmer and passionate speaker. So the stage is yours.
Thank you. Hi, everybody. Today we'll talk about distributed architectures. First, we'll see more about me, microphone work. Oh, thanks. So, since 2004, I'm a professional engineer. Since 2015, various managerial roles. I have various interests, and currently I'm CTO of Scale Focus and director of Scale Focus Academy. So, what is a distributed system? Roughly speaking, you'll find various descriptions online, but most of them include a system built of components that work together in concurrent fashion, and most importantly, they produce more complex behaviors together than they can do on their own. Also, there is a lack of global clock or a global mechanism to oversee and direct every piece of the system. There is an independent failure of components, which basically means that parts of the system or single components can fail, and the system itself can continue to, although at some degraded functionality or performance or whatever, continue to do its job. And most important, and actually the philosophical part, we are not interested in the behavior of the components. In a distributed system, we are interested in the emergent properties, which means properties that are not inherent to any of the components of the system, but only emerge when the components work together. So the best theory, by the way, that we have about what consciousness is emergent property of the neurons working together. So basically, that's a distributed system. Let's see it in action. So basically, to use the words of Douglas Adams, life, universe, and everything else works on distributed systems. Everything that you see is a distributed system. Complex weather patterns, and so on and so forth. So it's natural to use such emergent properties in computing. But why should we go distributed? There is a handful of reasons that are quite strong. First, data. We are in the business of wrangling data, working with data, storing it, computing against it, analyzing it, whatever, distributing it. Data in global terms, every 3 years, pick any 3 years, and get the data that was created by humanity in those 3 years is more than the whole previous history of humanity, any 3 years consecutive. So basically, that means data is growing exponentially. And we are delivering more frequently, smaller pieces of code and functionality and value. So that's an entirely different topic. We are more frequently delivering compared with the 80s, not compared with 2015. In the last few years, there is a trend actually of having less deployments on average. But compare it with the big picture, we are delivering more and more software ever more often. So, another big reason. Moore's law, to put it for a lack of better word, is dead. Regardless what you can Google online, some people say it is, some people say it's not. In its purest form, it says 18 months, you have twice as many transistors on a chip. That's no longer true. We are in about the 50 to 80 billion transistors per chip now. And there is a physical limit, an actual physical limit, which basically, if the gate length becomes twice as small as now, about 7 nanometers, then quantum tunneling becomes a thing. And we no longer can be sure that we are stopping the flow of electrons past the gate, because they can tunnel on their own due to the Heisenberg uncertainty principle. And don't take it from me, by the way, the founder and CEO of NVIDIA, Jensen Huang, basically said Moore's law is dead 2 weeks ago, actually. You cannot expect the same performance for half the price in 18 months, or for the same price, twice the performance. That's not happening anymore, at least not with silicon. There are carbon-based technologies and so on. And on average, you can see the graph, per year, for the last few years, the average performance gain per year is 3.5%, which is laughable. So we cannot grow higher and produce ever more powerful systems to work with our exponentially growing data. What can we do? So Metcalfe's law basically states that the usability or the usefulness of a system grows with the second power of the number of nodes. So what that means, that's a fancy word, but basically it means when we started hauling bigger loads, we didn't do that by breeding bigger oxen. We just tied more oxen to the load. That's an old practice. We didn't discover that recently. But is there a limit to Metcalfe's law? Can we tie indefinitely many oxen to the load? And it turns out there is. It's called Amdahl's law. And basically, if you have a part of the process that cannot be stripped down further into smaller pieces and distributed, basically, the longest such process becomes the limit that you can optimize to. Project managers among you call it the critical path of a project. You cannot optimize over that limit. So there is definitely a limit, but Amdahl's law takes for granted that we use the best architecture there is for distribution, and we rarely do. As Conway noted, organizations tend to produce distributed systems that mirror their organizational chart. So flatter organizations produce flatter architectures and more hierarchical organizations, architectures. So we are not even doing the best architectures we can for distribution, so we are far from Amdahl's law. So a few things to beware. So that's Lawrence Peter Deutsch's fallacies of the distributed system. Most developers nowadays creating distributed systems are falling in at least half of those fallacies. I won't go into detail over them. And the other thing is, those are the properties of a distributed system. So it should be resilient, it should be scalable, it should be partition tolerant, it should be effective, and so on and so forth. But the most important part is, everybody knows about them. Some call them architectural significant requirements, architectural quality requirements, and so on. But the thing that most people miss is that all those are connected. For example, if you have to gain more resiliency, you tug and you get less effectiveness because you have to provision more and more. Basically, the system becomes less financially effective, less energy effective, and so on. So those properties are connected, and you cannot get a free lunch. If you get too much of something, definitely you're losing something. If you don't know what you're losing, please make sure to understand that, because down the road, architectures tend to be hard to change. So, other things to beware. By the way, that's called the Brewer's theorem, or the CAP theorem. Eric Brewer is VP of infrastructure at Google. And he coined that theorem for basically distributed storage. So when you have distributed storage, Brewer basically said that, yeah, you can have consistency. Basically, for example, the thing that I read now is the last write to the system, to any of the nodes of the system, for example. That's consistency. Availability, which means whenever I want to read or write, the system is there, and it responds, and it behaves in a certain way. And partitioning, or partition tolerance. Basically, the system should be able to be spread out across multiple nodes. Those nodes should be able to fail independently and not bring down the whole system. So, and by the way, there is a cynical description of what a distributed system is. It's a system that failure of a computer that you didn't know existed brings down your own computer. So that basically is poor partitioning. But with a distributed system, we cannot bargain about this. We should be partition tolerant, which means, because the theorem states that from those three, you can get only two. Pick two, any two, but not three. So basically, we are saying, yeah, we are distributed. OK, then do you want to be consistent, or do you want to be available? You cannot be both. That's the gist of the theorem. And some services, like, for example, Airbnb or Booking, choose to be available. Some systems, like banks, choose to be consistent. Many people tend to be angry at banks when their money are missing. So, but that means banks cannot operate 24/7. They do have certain periods in which your transaction will not go through, and so on and so forth, because they need to get their consistency in order. And the other thing is, ACID is quite hard to achieve. So in transactional model, that's atomicity, consistency, isolation, durability. You can usually achieve base, which means basically available. Even though some parts of the system might not be working, you are using at least part of the functionality. Soft state, which means the system itself does not care about making things consistent. Software does. So engineers, if anything is inconsistent, software engineers are to blame. And eventually consistent, which means at some future point in time, the system will be consistent, but you cannot say when. But if you are fine with those, you can have availability. OK. And last but not least, I want to demonstrate how a distributed system works, because it's kind of too abstract, too academic. So imagine, if you will, a coffee shop. A normal coffee shop tries to make money out of the number of cups or the volume they sell. Basically, they have limited time in the day, limited resources. They want to sell as many cups of coffee as they can. So what do they strive for? A coffee shop, you have seen it, no doubt. It has multiple baristas. It has various systems, whatever. It's a distributed system, like the ants making a bridge and carrying over grain. So they can choose. They are distributed, but do they want to be consistent or do they want to be available? And of course, they want to be available. To give you an example what a consistent coffee shop would look like is basically to use the so-called two-phase commit. So the first phase, you go to the barista and say, hey, I want whatever, hot chocolate, for example. And the barista would say, yeah, that's fine. And he then locks all the resources he needs, or she, to make that coffee. So milk, hot chocolate, whatever the recipe requires. He will take your card, he will check that your card has the funds necessary, everything. And he will lock those and no other baristas can use it. That's first phase one of the two-phase commit. And then he will do your coffee or hot chocolate or whatever. And they will be sure in that fashion that they will not ever throw any coffee away. Because there will be no situations that I start to make coffee, but the milk is out, or the customer doesn't have enough funds to pay for the coffee. They're absolutely sure. But they are able to make less coffee in a day. So they're fine with throwing away some cups, or making the wrong coffee, or making the right coffee, and then discovering that the customer is not able to pay halfway through making the coffee. But they're fine with that, so long as they have throughput. You can always order. That's the important part for them. So that's the basic idea of how a distributed system works. And of course, you know how available coffee shops work, because you have seen those in action. No coffee shop in the world is consistent. So those are a few things to beware when designing distributed systems. If you have any questions, we have 4.5 minutes. Okay. So thanks for the attention, and hopefully it was interesting and you found out something new today. Thank you.
Rasi. Well, for the last session before the lunch break, we have actually 2 speakers. We have 2 machine learning enthusiasts, Pavel and Georgi. It's your time. Имаме проблем с микрофона.
Така ще говоря. Проба. Чуваме ли се? Здравейте, аз съм Павел. Казвам се Павел Геневски. Това е колегата ми Георги. Ако може и слайдовете. Proba. Hi, my name is Pavel, and this is my colleague Georgi. I'm a research expert at SAP Labs Bulgaria. I've been doing this for more than 10 years. We do applied research and try to apply all those innovations in the SAP products. And my colleague Georgi is a developer who did a fellowship in my team working on the topic of satellite Earth observation, which is what we're going to talk about today. So first of all, maybe you don't know, but the European Space Agency has launched a number of satellites circling around the Earth and doing observation 24/7. It started around 2014, and as of today, we have like 7 different missions equipped with different instruments that are looking for different things on the Earth's surface. And we're going to focus on Sentinel-2, which is specialized in Earth observation in the visible and infrared spectrum. So more or less it does something like pictures. It circles the Earth. It's 2 satellites that circle around the Earth in this strange orbit that you see on the right-hand side of the slide. And they provide global coverage every 5 days, which means that you see new images of the Earth, of every place on the Earth every 5 days. And the data access to those images is free of charge. You can download them. You don't have to pay anything. All you have to do is create an account on a website that I'll show in the moment. There's tens of terabytes of data produced every day, and already around tens of petabytes of data accumulated. And there's also some commercial offerings that try to make life easier, but we're mostly going to focus on the free and open data access in this presentation. And before I show you a little demo, let me explain what's in the data. The instrument that's on the satellites, it's something like a camera, but not quite, because it has more bands, actually 13 bands. And it also sees in the infrared spectrum. And each image that you get from the satellite is around 100 by 100 kilometers. And those bands have different resolution, ranging from 10, 20, and 60 meters per pixel. So it's not quite the details that you see on Google Maps, but still quite useful for use cases like ecology, climate change, digital farming, and so on. And all this complexity is packaged in image format called JPEG 2000, which not only supports multiple bands, but also lets you embed geospatial information so that you can correctly reproject those images on a map. And now it's time for our first demo. It's how you can download data manually from the European Space Agency website and visualize the data in an open source program called QGIS. What you see on the map is the website of Copernicus. You just have to go to the location that you're interested in and then select the area of interest. Once you do that, you can specify additional search criteria like the ingestion period in which you're interested and also the mission and the product type. We're selecting here the bottom of the atmosphere images, which have had some correction applied. And then you just select the product from the list of products and start the download. It's quite a big file, about 1 gigabyte, and once it is downloaded and unpacked on the file system, inside you can see folders, and one of these folders contains the actual band data. We're interested in the 10-meter resolution bands right now, and what I'll show you here is the so-called true color image, which is some sort of a synthetic image of some bands combined. In QGIS, we add an OpenStreetMap layer so we can get ourselves around on the map, and then we just open this file that I showed you, the so-called true color image. And as a result, we should see something on the map. And there it is, this teeny mini image down there. And if I zoom in, we can see that it's actually something that looks like a picture, and it's correctly reprojected on the map that and overlaps with our city. However, if we look closer on the image, we can see that what they call true color is not so true, because it doesn't correspond very well to what you would see if you get on an airplane and observe the Earth from the same area. And the reason for this is something that my colleague is going to explain on the next slides.
Thank you. The problem here comes from the difference of the color matching functions of the satellite camera and the human eye. In the top image, you can see the functions that the satellite uses to convert the spectral reflectance to its own color space, Sentinel-2. And underneath, you can see the functions that the human eye uses to get color out of spectral reflectance. The main difference, as you can see, is that the human eye has only 3 bands, which are the popular red, green, and blue. And the satellite camera has 13 bands, which, some of which are in the infrared spectrum. Now let's focus on the 3 selected bands in the top image. We are skipping the first one because the image that comes for that band has 60 by 60 meter resolution, which is too rough for our purposes. And now if you look at the direction of the arrows, you can see that a direct mapping between those 3 bands to the human eye functions is not so accurate here. Sentinel-2 uses just this type of mapping to produce their true color images, which Pavel showed. And, but can we do better? Indeed, we can get a better color estimation by trying to solve the following problem. The only data that we have is the satellite image, which contains the Sentinel responses. The full spectra is currently unknown, and we are trying to find a mapping to XYZ color space, which represents human vision. One approach that you might think of is if we can try to reconstruct the full spectra from the Sentinel responses, but this task is really hard because Sentinel responses are only 3 or 4 numbers in the visible spectrum, while a full spectra is represented by 400 numbers. So we should attack the problem from a different angle. If we have the full spectra, then we can calculate the Sentinel-2 responses, and also we can calculate the XYZ responses. And now by having these 2 data sets, the problem is reduced to finding the best mapping between them. But where do we get the common full spectra data set? Fortunately, NASA has created EcoStress Spectral Library, which contains more than 3,000 popular natural and man-made materials, which can be found on the Earth's surface. Around 2,000 of those materials contain data in the visible spectrum, which we are interested in. In the left image, you can see the data from a single example of this library. Over the x-axis, we have the wavelength in micrometers, and over the y-axis, we have the reflectance in percentage. On the right, you can see the data zoomed in only in the visible spectrum. And from that image, you can get a hint that the color is more likely to be brown than blue. But to get the exact color estimation, we need a way to apply the XYZ color matching functions from previous slides. And here comes the Color Science Library, which is a free open source BSD licensed Python library, which contains many algorithms and data sets in the color science field. On the right, you can see the representation of the library as a graph. For our purposes, we will use the path from spectral distribution to XYZ color space, which is one of the most important color spaces on this image, because it can represent all visible colors to the human eye. But unfortunately, that color space is not so suitable for displaying on computer screens. So we need to convert it to sRGB because of the limited color capabilities of computer monitors. And now that we have this nice library, we can proceed to the first step of the natural color estimation, which is generating the XYZ data set. You can see on the top a single example of this EcoStress library. Underneath, there are the XYZ color matching functions. And by using a simple one-liner from the Python library, we can get the XYZ responses. And repeating this task for all the examples in the data set, we can generate the first data set that we need. Then we should do something similar for the Sentinel-2 responses. And we use the spectral response functions of the satellite. Unfortunately, this wasn't implemented in the Color Science library, so we had to do it ourselves. And now that we have the 2 data sets, this is a common machine learning problem, and we need to find the best mapping between them. The biggest challenge here was that we do not have lots of data, because we have only 2,000 examples. And so we had to implement a very small neural network. Yeah, and this gave us quite good results, which are shown on the next slide. On the left, this is the example from the XStress library, some kind of soil displayed in sRGB so we can show it on the screen. This is what you should see. In the middle, this is the XYZ responses that correspond to the true color image conversion that Sentinel-2 uses. And on the right is the result from our approach with the neural network, which seems pretty close to what you should see. But wouldn't it be nice if we can explore the data in the browser? For this task, we have created a simple POC system that can display natural color images for a given date range. And I will show you now. This is a map implemented with the help of the open source JavaScript library Leaflet. We have chosen the OpenStreetMap as a base layer, and we have selected the date range to be from 10th of January until 20th of January. And now we enable the Sentinel-2 layer. Implementing this layer required the use of quite a few algorithms from the open source library GDAL. For example, cutting the images to the shape of Bulgaria, reprojecting the coordinate reference system, and generating smaller tiles. Now let's zoom in so we can see some farm fields better. Let's go to the small town of General Toshevo, which is my village, and see what has been going on there. As Sentinel-2 provides an image every 5 days, we should be able to see some difference if we go back in time. And yeah, as we can see, this map can be a good entry point for a more complex system that contains other useful features like monitoring land temperature, crop yield, or other things that farmers may use. But what are the key takeaways of this presentation? There is free satellite data available out there, just waiting for you. There are also lots of open source tools that you can use. And last but not least, there are many use cases where satellite images can be applied. For example, in digital farming, as we already showed. And in ecology, you can, for example, monitor pollution, deforestation, drought, etc. And yeah, we encourage you to try it out. Thank you very much for the attention. We'll be happy to answer your questions now or after the presentation.
I know it was quite of a complex topic, but still, if you have some questions, even if you think they may be stupid questions, don't be afraid to ask. There's no stupid question. Every question is valid.
So you're working with SAP, right?
Yeah, we both work for SAP, and we're focused on digital farming.
So why is this project related to SAP? This is my question.
Sorry, I couldn't hear very well.
How is this project related to SAP's
It is
product?
related because of digital farming. It's a new area that's emerging right now. There is a lot of investment. And one of the major use cases is digital farming, where farmers would like to observe their land. Of course, we only showed you the visual part of the images, but there's also infrared and also other satellites that can give you information like wind speed, surface temperature, and so on. And when you combine all of this data, it can be an indispensable tool for the farmer and for the people who operate a lot of land. There's, of course, other use cases as well, like for climate purposes, for disaster management, for deforestation monitoring. Another very prominent use case that comes to mind is for controlling the give out of subsidies in India, for example, where people are incentivized not based on the plot size, but based on the yield, and they currently apply very complex methodology to estimate the yield and the harvest. And this technology has a lot of uses. One of these is, of course, to reduce the level of corruption and those government payments.
Okay, thanks, folks. Let me remind you that after this session, we have a lunch break. We are a little behind schedule, but the next keynote will start on time. So enjoy the lunch.
And if you have more questions, even technical ones, we'll be here for you. Thank you.
Thank you.
SAP focused on making businesses run better by pushing the boundaries of innovation and impacted the world and people's lives beyond anything the founders ever imagined. With 50 years of groundbreaking work, SAP will continue to lead the way with innovation and help the world run better and improve people's lives.
Stripe Bulgaria was founded in 2008 by the Dutch entrepreneur Koen van Wijk. His vision was to create solutions that exceed customer expectations. Since 2014, Stripe is part of the ICT Group in the Netherlands. The ICT Group is a stock-listed company on the Amsterdam Stock Exchange and employs more than 1,000 professionals. Since 2017, I have the privilege and honor to drive Stripe forward in the role of CEO. We offer solutions to our clients in digital transformation, smart applications, and infrastructure. Our mission is to build smart solutions that create business impact. We are Stripe.
We're a pretty resilient species, and that's true now more than ever. So we deserve app experiences that are as resilient as we are. This starts with apps that can scale to keep pace with shifting demand, or update at a moment's notice to support entirely new business models. In a time when the app experience has become the human experience, being future-ready means keeping people at the heart of innovation and flexing to meet their needs. Because technology really can change the world, but the best technology changes with it.
Miracle започват официално в България на 1 януари 2022 година, но двете компании, които обединява, са на нашия пазар доста по-отдавна. Isobar Commerce и Life Area стартират съвместна работа като част от новата бизнес линия на Miracle Commerce and Experience. Аз съм част от това семейство от 13 години и заедно с много мои колеги преживяхме най-различни метаморфози на фирмата. Започнахме като малък стартъп, наречен e-commerce през 2008 година. Тогава празнувахме успешен декемврийски ден на коледно пазаруване с цели 1000 онлайн поръчки за 24 часа. През 2015 година e-commerce беше придобита от Isobar и стана част от бизнеса на Денцо. Това ни позволи да спечелиме нови вълнуващи клиенти и на последния черен петък през 2021 година достигнахме пикови стойности от 1000 поръчки в минута. През цялото това време сме разработили и внедрили над 400 transactional сайта. Работили сме с клиенти в над 60 държави и имаме онлайн магазини на 6 континента. Качеството на кода и поддръжката ни е ненадмината. Затова свидетелстват и нашите клиенти, с които работим заедно вече повече от 13 години. Днес сме Miracle и целим да поставим нови рекорди с качеството на кода, който пишем.
SAP focused on making businesses run better by pushing the boundaries of innovation and impacted the world and people's lives beyond anything the founders ever imagined. With 50 years of groundbreaking work, SAP will continue to lead the way with innovation and help the world run better and improve people's lives.
Stripe Bulgaria was founded in 2008 by the Dutch entrepreneur Koen van Wijk. His vision was to create solutions that exceed customer expectations. Since 2014, Stripe is part of the ICT Group in the Netherlands. The ICT Group is a stock-listed company on the Amsterdam Stock Exchange and employs more than 1,000 professionals. Since 2017, I have the privilege and honor to drive Stripe forward in the role of CEO. We offer solutions to our clients in digital transformation, smart applications, and infrastructure. Our mission is to build smart solutions that create business impact. We are Stripe.
We're a pretty resilient species, and that's true now more than ever. So we deserve app experiences that are as resilient as we are. This starts with apps that can scale to keep pace with shifting demand, or update at a moment's notice to support entirely new business models. In a time when the app experience has become the human experience, being future-ready means keeping people at the heart of innovation and flexing to meet their needs. Because technology really can change the world, but the best technology changes with it.
Markel започват официално в България на 1 януари 2022 година, но двете компании, които обединява са на нашия пазар доста по-отдавна. ISTA Commerce и Life Area стартират съвместна работа като част от новата бизнес линия на Markel Commerce and Experience. Аз съм част от това семейство от 13 години и заедно с много мои колеги преживяхме най-различни метаморфози на фирмата. Започнахме като малък стартъп, наречен Икомера през 2008 година. Тогава празнувахме успешен декемврийски ден на коледно пазаруване с цели 1000 онлайн поръчки за 24 часа. През 2015 година Екомера беше придобител от ISTA и стана част от бизнеса на Денцо. Това ни позволи да спечелиме нови вълнуващи клиенти и на последния черен петък през 2021 година достигнахме пикови стойности от 1000 поръчки в минута. През цялото това време сме разработили и внедрили над 400 transactional сайта. Работили сме с клиенти в над 60 държави и имаме онлайн магазини на 6 континента. Качеството на кода и поддръжката ни е ненадмината. Затова свидетелстват и нашите клиенти, с които работим заедно вече повече от 13 години. Днес сме Markel и целим да поставим нови рекорди с качеството на кода, който пишем.
SAP focused on making businesses run better by pushing the boundaries of innovation and impacted the world and people's lives beyond anything the founders ever imagined. With 50 years of groundbreaking work, SAP will continue to lead the way with innovation and help the world run better and improve people's lives.
Stripe Bulgaria was founded in 2008 by the Dutch entrepreneur Koen van Wijk. His vision was to create solutions that exceed customer expectations. Since 2014, Stripe is part of the ICT Group in the Netherlands. The ICT Group is a stock-listed company on the Amsterdam Stock Exchange and employs more than 1,000 professionals. Since 2017, I have the privilege and honor to drive Stripe forward in the role of CEO. We offer solutions to our clients in digital transformation, smart applications, and infrastructure. Our mission is to build smart solutions that create business impact. We are Stripe.
We're a pretty resilient species, and that's true now more than ever. So we deserve app experiences that are as resilient as we are. This starts with apps that can scale to keep pace with shifting demand, or update at a moment's notice to support entirely new business models. In a time when the app experience has become the human experience, being future-ready means keeping people at the heart of innovation and flexing to meet their needs. Because technology really can change the world, but the best technology changes with it.
Markel започват официално в България на 1 януари 2022 година, но двете компании, които обединява са на нашия пазар доста по-отдавна. ISTA, Commerce и Life стартират съвместна работа като част от новата бизнес линия на Markel Commerce and Experience. Аз съм част от това семейство от 13 години и заедно с много мои колеги преживяхме най-различни метаморфози на фирмата. Започнахме като малък стартъп, наречен e-commerce през 2008 година. Тогава празнувахме успешен декемврийски ден на коледно пазаруване с цели 1000 онлайн поръчки за 24 часа. През 2015 година e-commerce беше придобител от ISTA и стана част от бизнеса на Денцо. Това ни позволи да спечелиме нови вълнуващи клиенти и на последния черен петък през 2021 година достигнахме пикови стойности от 1000 поръчки в минута. През цялото това време сме разработили и внедрили над 400 transactional сайта. Работили сме с клиенти в над 60 държави и имаме онлайн магазини на 6 континента. Качеството на кода и поддръжката ни е ненадмината. За това свидетелстват и нашите клиенти, с които работим заедно вече повече от 13 години. Днес сме Markel и целим да поставим нови рекорди с качеството на кода, който пишем.
SAP focused on making businesses run better by pushing the boundaries of innovation and impacted the world and people's lives beyond anything the founders ever imagined. With 50 years of groundbreaking work, SAP will continue to lead the way with innovation and help the world run better and improve people's lives.
Stripe Bulgaria was founded in 2008 by the Dutch entrepreneur Koen van Wijk. His vision was to create solutions that exceed customer expectations. Since 2014, Stripe is part of the ICT Group in the Netherlands. The ICT Group is a stock-listed company on the Amsterdam Stock Exchange and employs more than 1,000 professionals. Since 2017, I have the privilege and honor to drive Stripe forward in the role of CEO. We offer solutions to our clients in digital transformation, smart applications, and infrastructure. Our mission is to build smart solutions that create business impact. We are Stripe.
We're a pretty resilient species, and that's true now more than ever. So we deserve app experiences that are as resilient as we are. This starts with apps that can scale to keep pace with shifting demand, or update at a moment's notice to support entirely new business models. In a time when the app experience has become the human experience, being future-ready means keeping people at the heart of innovation and flexing to meet their needs. Because technology really can change the world, but the best technology changes with it.
Oracle започват официално в България на 1 януари 2022 година, но двете компании, които обединява, са на нашия пазар доста по-отдавна. Isobar Commerce и LifeArea стартират съвместна работа като част от новата бизнес линия на Merkle Commerce and Experience. Аз съм част от това семейство от 13 години и заедно с много мои колеги преживяхме най-различни метаморфози на фирмата. Започнахме като малък стартъп, наречен e-commerce през 2008 година. Тогава празнувахме успешен декемврийски ден на коледно пазаруване с цели 1000 онлайн поръчки за 24 часа. През 2015 година e-commerce беше придобита от Isobar и стана част от бизнеса на Денцо. Това ни позволи да спечелиме нови вълнуващи клиенти и на последния черен петък през 2021 година достигнахме пикови стойности от 1000 поръчки в минута. През цялото това време сме разработили и внедрили над 400 transactional сайта. Работили сме с клиенти.
Звукът нещо.
Hi everyone, my name is Christo and I will be hosting the agenda for track 1 by the end of the day. I hope you had a nice networking time during our lunch break. It is time now to continue with our agenda and I can't wait to introduce our next speaker. His name is Peter and he is an expert, entrepreneur and innovator that dives quite deep in the area of virtual teams. His book, Empowering Virtual Teams, is actually translated in 6 languages, and it reached top 3 in the Amazon category for international management. His passion and mission is to help as much as possible teams and managers to support their culture despite challenges such as age, geography, and culture. Please give your warmest welcome to Peter Ivanov.
Thank you. Благодаря ти. My presentation today starts with 5 words, which 52 years ago have casted the world in fear and hope, which are still a symbol of the unexpected that calls for urgent action, which for 3 men and their family meant 1 week struggle for life or death. These 5 words are, Houston, we have a problem. Imagine the year is 1970, by the way, the year when I was born. Precisely, it is 11 of April, and the clock in Houston shows 13:13. Precisely in this moment in time, the American Space Agency, NASA, shoots the spaceship Apollo 13 to the moon. The experts plan to land on the moon in 4 days. On the 3rd day, April the 13th, there is a loud crash, and the 3 astronauts see how white powder flows into the space. This is their oxygen. 2 from their 3 oxygen tanks have just exploded, and their entire oxygen flows into the space. The Houston Control Center is in panic. No one has ever planned with such a disaster. The families of the 3 astronauts are completely horrified. How many of you have seen the film Apollo 13? Give me a hands up. Yeah, not so many, young audience. If this here is the Earth, and up there is the moon, on the 3rd day, April the 13th, when the explosion happens, they're very close to the moon, where is the cross. If they continue flying according to the plan, they have energy until somewhere between the Earth and the moon, when the line stops, but not enough to reach the gravity of the Earth, and so to be pulled on the Earth's surface. It is clear now the mission landing on the moon has failed. All already planned geological or other lunar research have been blown away by this explosion. Now, the lives of the astronauts are at stake. Now it is a matter of life or death. In the Houston Control Center, there is one man in charge, the 37-year-old Gene Kranz. He, with his short and flat haircut, he looks you always into the eyes and acts tough but competent. Gene grasps immediately that in order to save the lives of the astronauts, he has to win one fight, the fight for energy. Energy in the space is everything. You need energy in order to move the spaceship, in order to navigate it, but also to communicate with the Earth. Now, every energy unit, every single amp, has a life meaning. Now, they need a miracle. What does Gene Kranz do in this historical moment? He gathers his entire Houston team in one room. The room boils from anxiety and nervousness. The heads are challenged, the ideas rush around, the hearts are full with care, fear, and hope. Gene listens each and every one very carefully. At one point, he calls for silence. Then he pulls all these people spread around the space together. Everyone, the 3 astronauts in the space, the Houston Control Center, scientists, engineers, hundreds of people. Gene says, we haven't lost a man in space until now, and as long as I'm responsible, no one stays there. Failure is not an option. He succeeds to pull all these people spread around the space through a magical gravity force in one strong virtual team. One team aligned towards one goal, to save the lives of the astronauts. These are 7 days filled with incredible character strength, genius feats of engineering. Among others, they built CO2 converter into the spaceship, but above all, an extraterrestrial triumph of leadership. On the 17th of April, the land capsule of Apollo 13 lands, or rather splashes, in the Pacific, and the 3 astronauts are rescued. This is a miracle. This is virtual power. This is a virtual power team. Now, why I'm telling you this story? How many of you have worked on a project where something unexpected happens? Give me a hands up. Okay. Much more than Apollo 13 story. So how often is the go-live date brought forward, or the budget reduced, and you still have to deliver with less energy? Or how often the team members in different locations, home office, different countries, sometimes they lose motivation, and that deteriorates the team performance. So I personally heard the statement, Houston, we have a problem, more than once in my career. Luckily, it was never life and death situation, but for the project, it was quite critical. And now, COVID came, made us all remote and virtual, lockdown, and we responded quite well with good, well-honed digital skills. But the longer this period expands, the more we need to set goals remotely, we need to resolve conflicts remotely, we need to establish a structured communication in remote and now hybrid teams, and maintain the winning team spirit. And for this, we need a system. And this is what I will share with you today, a system to build powerful virtual and hybrid teams, and also to motivate the remote team members, the home office workers. Now, I was 20 years IT manager, so like many of you, or being on the client side, deploying SAP and so on. And the last 8 years, I decided to dedicate myself to the topic of virtual power teams, as Christo mentioned. And what keeps me going now, 8th, 9th year, is that the system works. For example, one 2-year project involving 20 countries in Europe. We delivered 3 months early and we saved 250,000 euro. That was establishing global shared services, and I'll share in the end of the presentation. On another one, it was 1 billion euro project involving Alibaba and e-commerce. We delivered on time in a very dispersed team, had 80 million profitability. Now, 9 years work with many different clients, some of them big. I live in Germany, in Hamburg, like BASF and Lufthansa and so on. But some of them, like many of you, how many of you come from mid-size SME, small and medium enterprises? Although it's a matter of definition, yes, okay. And probably, how many are from big multinationals? Okay, and the rest must be scaling startups. So here you have all range. You have the big multinationals, you have medium enterprises where we also connect not just the internal teams and internal employees, but also their clients and sometimes partners and strategic suppliers, and also scaling startups. And also, if you take there some NGOs like United Nations, quite a big non-profit organization, where people are not on salary, they don't have career or bonus scheme, same principles apply. Now, from all these experiences as a manager of large teams and also coaching now some global teams, I can tell that the virtual team is like the atom, where you have a nucleus and then you have various particles flying around. In a virtual team, we aim to retain the gravity despite the distance. The gravity between the individual team members, which are the particles in this model, towards the nucleus. But the nucleus is not the manager, it's not the company owner, it's not the project manager. The nucleus is the team purpose and goal. So you will see we put a lot of emphasis to put the goal bottom up in this method. And I'll explain how we do it. Now, the virtual power teams comprises the 10 big rocks. And these are 10 success factors for retaining the gravity in a virtual team and unleashing the team power. And these 10 success factors, 10 is a big number, they're broken down in 3 main parts. If you imagine your team, by the way, how many of you work in virtual teams? At least one team member is, now we have quite close, probably around 85%. If you imagine your team as a human being, the first part, the logical part, is the head. This is the logical, the cognitive part. And here come the first 3 big rocks, namely, big rock number 1, personality in focus. Some managers say, I don't see the people, why should I bother what are they as individuals? From my perspective, big mistake. So I will give you a couple of formats where even people, even if they don't have a chance to meet face-to-face, they can go deep and connect on a human level, not just expert to expert, brilliant machine learning or data scientist, human level. That helps to retain the gravity. Second big rock, strengths matrix. In the poorly led virtual teams, people feel anonymous. They feel isolated, they feel not understood. Here we will establish, we will find out the natural strengths and talents of the people. And I'll share with you a script, they coach each other. And when we put all the strengths in a strength matrix, a new feeling emerges. Like everyone, instead of feeling anonymous and isolated, he or she feels like a hero, because every one of us brings a special skills and strengths and talents to the table. And when people see all the strengths on a strength matrix, a new feeling emerges. With this bouquet of strengths, with this mix of talents, we could achieve any goal that we set to ourselves, any nucleus. So simple steps you will see, but they help each one of them to strengthen the gravity and the team spirit, the sense of belonging. Big rock number 3 is interdependent goals. So here is the place where we define the nucleus of the atom in a special 3-step process. So in the first part, the head, we are aiming for clarity. Who is a member of the team as a human being, and what is the goal of the team, the nucleus of the atom? The second part is the body and muscles. This is the dynamic part. And big rock number 4 is forums and agenda. What online meetings do you need? What forums, asynchronous and synchronous forums you need in order to keep the communication? Then knowledge management, and we link it to the strengths. You know, the strengths that we identified in the strength matrix, they become the knowledge champions and custodians in this particular, for the team, relevant areas. And then big rock number 6 is regular feedback. Sometimes scarce in local team and even more in virtual teams. And here we are aiming in this part, the body, for structured communication. Not like in poorly led teams, sometimes the manager calls a meeting. If there is a problem, starts some finger pointing, or he speaks most of the time. No, we are aiming for structured communication where everyone has a slot to contribute and to shine. And the last part, the third, my favorite, is the heart. So here we're talking about recognition. Do you know, by the way, what's number 1 reason for people leaving companies? Software development, anyone? It's not salary, although here is a big driver. Salary is number 2. Number 1, not enough recognition by the line manager. So people leave managers and bosses, not companies. Big rock number 8, diversity. If you have a multiple dimensions, multicultural teams, or different ages, age diversity, how to establish the optimal team culture. Number 9, winning spirit. Tell you a story in the end. And number 10, which is like overarching, is next generation leaders. So how to involve the millennials and digital natives in order to, they contribute and shine in the team. Now, as Christo mentioned, the book that I've written, I'm a mathematician, then IT manager, so process and numbers guy, written a book. For my big surprise, it was translated in 6 languages, including Bulgarian, Kipi bez granici, and then it was Amazon top free just for a week, but I keep this screenshot like dear to my heart. Now, that was a bit of a spoiler. This 81 is, the question to you would have been, how many are the virtual teams globally? So it's a study from Forrester Research, before COVID, 4 years old, and they found out that there are 81%. And do you know how many of them are in more than one time zone, quite dispersed? What's the percentage? 70? 40, said someone? 60%. More than 60% are in more than one time zone. If you look around the room, how many of you have a colleague who is in another time zone? Just let's have a look. Yes, you see 60% or 70%. Okay. Now, I written another book during COVID. I didn't travel so much on conferences. And first one was about business. This is more about uniting global talents also to tackle the toughest challenges, like climate change that we heard today from SAP and so on. Now, another spoiler. Google wanted to find out what the best global teams have in common. And they started a project called Google Project Aristotle. And they wanted to find out what is the one characteristic that their best performing teams have in common. They researched. At some point, they found that their best teams, when they have a meeting, they have an equal share of talking. So at some point in time, the introverts will shut up by themselves, or the extroverts will shut up by themselves. The introverts will gain and speak up. So they end up with like equal share of talking. It was quite a discovery for them. But it was not 100%, it was 90+% applied to this rule. And they continued to research. And in the end, they found it. What do you think? Just what's your first thing? What is this characteristic that all best teams have in common? In this case, virtual global teams. Anyone? Trust. Very good, very good. So for the benefit of time, I wouldn't go further. They call it, and trust is the key ingredient, psychological safety, which means that people in the team feel safe enough to take risks, not being afraid that if they fail, they will be laughed at, or they'll be fired, they'll have negative consequences for their career. They feel safe enough to take risks. And secondly, they feel safe enough to show vulnerability in front of each other. Not just their perfect side, as sometimes we do in social media, they show their vulnerabilities. They show their weaknesses, they ask for help and so on. So psychological safety. And then comes number 2, dependability, relying on each other and so on. Clarity of role and structure. Now, how do you feel in your team? It's more a bit of a workshop question. Let's go into the 10 big rocks, the methods of virtual power teams. I will cover some of them in more details, some of them in less. Now, in poorly led teams, like in the Atom, some team members get lost in space. And that drives the performance down. So I ask myself the question, how can we retain the gravity so they feel really connected to the nucleus and improve performance even exponentially? And those teams that manage to do that, I call virtual power teams. And let's start building them now with the 10 big rocks. By the way, I'm a father of 5 girls. 1 wife, 1 marriage, 5 girls. Apparently, it's the only thing I can. I've tried long and hard enough. But 2 of them are now in the USA. The rest lived in Hamburg, in our family house. So next book project will be cracking the code of the virtual power family. Now, I do this little intro because every time I'm appointed as a manager of a new team or now I'm as a coach, I try to go deep in the personality of the people. So I invite people to present themselves with their lifeline or life journey. And here are the moments of excellence, moments that you are most proud of, but also the lowlights, moments that you struggled, but nevertheless managed to overcome. And if you invite people to present themselves from this perspective, you will be amazed. Within like 5 to 10 minutes per person, you will find out what makes the heart of each and every one singing. It's really very powerful. And as a smart manager, you may ask those questions during the recruitment, but in this way, everyone on the team finds out about everyone else, what makes their heart sing. So you see, as we said, psychological safety, you start building trust, you start building commonality, and this translates later on in performance. I also work with pictures. This is Oscar, lives in Madrid and weighs 9 kilos, so a real monster. I ask people to come up with a picture that they either find funny or identify with it. And again, within 30 seconds, just by the picture they pick and the way they present it, it opens the window to the soul of your people. And working with scaling startups, they have no budget to get together. We do this online, a lot of gravity. You start building the lifeline, the picture, and the third one that we do is so-called flash intro. 4 simple questions. I would have loved to do it now in like 3 minutes, but the time is very limited. Siblings, brothers and sisters, hobby as a child, what you are most proud of, and then what else should others know about you. Try this one with a friend, try with your colleagues. Again, you'll be amazed by the level of depth you get. First 2 questions, very easy. You don't have to think what to answer. Second 2 questions, you need to decide what do you share. So you're forced to show vulnerability, and this is exactly what Google discovered that builds trust. Because we have our Bulgarian saying, you know, to trust someone, you need to eat 2 kilos of salt, sort of. So many years together so you can trust him. But the other, the speedway for building trust, is opening up and showing vulnerability. And I would only recommend to try it out. You will see with completely uncommon and unknown people, if we do it like for 2 minutes, you will find out commonalities and start feeling trust. Trust, by the way, which is essential ingredient, as here someone mentioned of the psychological safety, is component of 2 things. Personality. Will he or she do it? Can I trust him? Will he or she do it? And for this, you need to know a little bit more the personality. And that's why we do these formats even online. And then, can he or she do it, if he has the skills and the competence? And this is where the second big rock, the strength matrix, come in. But the combination of 2 gives you the trust to your team members. And this is the fundament for your success as a team. By the way, the slides that I will share, they have some question for self-coaching. You could use it for yourself or for your team. The second big rock is strengths matrix. I'm a big fan of strengths-orientated management, which means strengthening the strengths instead of developing the weaknesses. It's not mine. Gallup International came up with StrengthsFinder 2.0. How many of you have come across? Not so many. So I made it simple. When we do the workshops, I ask people to list their strengths. And for those of them who come with a list of 100 strengths, I explain that this is not a strengths competition. We will use it for additional roles and responsibilities and say, oh, but why additional? We are already 150% overutilized. But for those of them who struggle to list a single strength, there is a script. Simple script, you do it in pairs. One is a coach asking the question, the other answer. What is easy and fun to do in your job? What is your biggest success in life, not just in work? What are people coming to you and asking you for help? If you ask, who is your best friend? Like Christo. If you ask Christo, what is your biggest strength? What would he say? And then, in the end, you ask, from everything you told me, what is your biggest strength? Again, you will be amazed. And then you as a coach can say, I think from everything I've heard, your biggest strength is this. So everyone will end up with 2 strengths. What is the internal perspective, what you think of yourself? And again, this question will give you to come up with something that you probably will be surprised. And then how others perceive you, the external perspective. And we put on top, what is your avatar, a question, and we put it in this strength matrix with avatar like celebrities, movie characters, whatever. Some people go for animals like elephants or diamond and so on. And when people present themselves with their strengths, as I said, new feeling emerges. Everyone feels special because everyone is a star and brings a particular skill set to the team. And then when they see the rest of the talents, say we can achieve any goal that we set to ourselves. And the more That's the trick in teams. The more you work in your strength area, the more joy you feel. How many of you have come across the flow state? Flow state? If you're fully focused, so that's yes. If you work in your strength area, you fall in flow. You're fully focused, this is the area of top performance, and you feel joy. And if you know the strengths of the others, and you have psychological safety, if something is not your strength, instead of struggling and frustrating, you would ask for help, the people that have the strengths, and then 1 + 1 + 1 becomes much more than 3. Just one simple story. I have a client in New York who runs MOOCs. MOOC stands for Massive Open Online Course. And he's gathering 35,000 students, and he's teaching modern architecture. So they're building resilient schools for the Philippines. When the tsunami in the Philippines destroyed the infrastructure, the government decided to build the schools in such a resilient way, so they will be, in normal case, there will be schools, but in case of natural disaster, they will provide shelter to the people. And 6 weeks, he recorded everything in videos. Each week gives some new instructions, they build a school. But his problem was, week 5 comes, people drop out. Learned enough for free, just dropping out. Why for free? They were paying in the end when they have a successful project, pay for the certificate and get it. They didn't care for the certificate so much. He tried to get the money up front, only 2,000 subscribed. So we get together with his team and agreed to divide them in groups of 5. Not us, it's a mammoth task. Self-organized, get together in a group of 5, based on proximity, time zone, whatever principle. And then, in these groups of 5, they presented themselves with a life journey. They discovered their strengths, and they were designing just one school, not 5 individual, based on their strengths. And when the critical week 5 came, they couldn't let their teammates down. There was already so much gravity in the team, so they couldn't let their teammates down. In the end, 27,000 people stayed into the end, and with this simple measure, just letting people connect on a personal level, he had a nearly $500,000 revenue improvement. Now, interdependent goals. This is the nucleus. It's a very important big rock. I will explain the principle. Each organization has a vision, but sometimes it's difficult to translate it into a team on a team level. You have a choice either in the Martin Luther King style, I have a dream, to present it so vividly that everyone follows, or you can let the team work it out. And I've streamlined the process for breaking down, defining the vision, and breaking down in the goals. And essentially, these are 3 steps. First, you discover the 3 hottest topics of the team. Regardless how smart are you as a manager, if you have a multiple location, time zones, and culture, you don't know. So it's a bottom-up process, 3 groups, silhouette, issues and opportunities, symbol of success. People vote in the end, you discover what are the 3 hottest topics of the team. Step number 2, we convert them into the SMART goals. SMART, the specific, measurable, and so on, but in a very rich script, so it makes it really tangible for them. And then we build for each of the SMART goals a roadmap. And then people pick from the roadmaps their goals. So the roadmaps are the nucleus, and people pick their goals and justify it by their strengths. So there is no delegation. People pick their goals, and they work in their strength area. And from kind of day one, ensure much bigger commitment, even from the distance. Now, let's move to the second part, the body. I'll give you a couple of home office tips. 2019, I was speaking on an event in Bali called Running Remote. So there were organizations and companies having, some of them 10,000 plus people, like Shopify, and not having an office. So they decided from day one to be fully remote. Their people can work wherever they like, and even whenever they like, as much asynchronous as possible. And they asked the question, what is the #1 skill to lead remote workers? And we were voting with Slido, with the mobile phones, and the topics which get resonance were bigger and centered on the screen. And at some point in time, there was one word in the middle of the screen, the #1 skill, according to this audience, to lead remote workers. What do you think? What is this skill as a leader to lead remote workers? Give me a few ideas. Empathy, big time. What else? Self-driven, yeah, you need self-motivators, self-starters, yes. So the word which was on the screen was over-communicate. May sound a bit negative and surprising. it has two aspects clarified. First of all, if you give a task remotely and you put it in an asynchronous channel, you don't see if the people not in agreement or they're puzzled. So give them not just the task, give them why we do what we do. Give them the goal that this task will achieve. Because otherwise they will start bugging you back on their peers and you will waste time. Invest a little bit to give them the bigger picture, the big why and the big what. And second aspect is make sure they understand what do you mean. Sometimes we give a task, when we see the result, has nothing to do with what we expected. Who is to blame? Me, the communication sender. So make sure, ask them to rephrase, that they really understood. So these two aspects of our communication can, over time, spare you time and have a better result. The second tip, which I use in my family, is praise, praise, praise. I've tried with my girls with constructive criticism, using the best practices. I failed miserably. The only thing that works is praise, praise, praise. And similarly apply to virtual teams. What to praise, you may ask? If there is a result, if there's a deliverable, praise the result. If there is no result yet, but you see supportive behaviors, psychological safety, praise the behavior. If there is neither result nor behavior, look harder. There is always something to praise, but be authentic. And then there are many others, like take regular breaks. I take like every 25 minutes if I'm not on stage, Alexa, set an alarm. Take regular breaks. You will see. You'll be more productive in the end. And particularly if you're like in a multiple time zones, as we saw in the room, agree on a single channel for urgent communication and agree on the response time. Don't use email for urgent. Let the team decide. Now, forums and agenda. I will just mention here that how many of you use like Scrum or any of the agile methodologies? Quite a few. So in your regular communication, make sure you have a meeting with a core team, core project team, or core leadership team, the core members, the manager and his reports. And whatever your periodic is, like weekly or daily, start with a personal update. Start with a highlight from each one, share within 2 minutes, what is my highlight since we last met? You will see, particularly if it's fully hybrid or remote context, this is the spice of the meeting. People share what's my record in half marathon, and I've seen many sporty people here. I was positively surprised. Or how it tastes, red wine from Chile, Reserve 96. So very personal, 2 minutes, set the tone. Once, if this is like your weekly team meeting, the core team, like monthly, but it's key that the team decide, not the manager, I invite a bit of a bigger body. It could be, if you like, multiple hierarchy, their direct reports. So the leadership team is the manager and his direct reports, and here is the extended leadership team. Or if it's like a smaller team, you could invite key partners and suppliers or different stakeholders, key interfaces within the organization. It's very important. Once you set the goals, the interdependent goals, the nucleus, and everyone is having a goal, here everyone reports, where am I with my strategic goal? So, and you open it for key interfaces to also find out. That will ensure from a virtual power team center, you go and spread the message and your mission within the organization. VR is coming big time. Recently, I had a VR keynote in a hotel room, and we were on the Necker Island, so this immersive thing is coming and will make our meeting probably a bit more exciting. And then a little bit on the psychological safety in hybrid teams. Do you know how many people want to come back to the office the old way? What's the percentage? Yes? Yeah, you want to, okay. Let's ask the room. How many want to go back 5 days a week? Okay. 20%, yes. So global research says 25. 70%, like in this audience, 75 prefer to work remotely, if possible, even if they have a pay cut. But 2/3, 66, want to have a meaningful interaction with their colleagues. And you will see how the fully remote companies do it. So a few ideas how to set the psychological safety if some people work remote. As a manager, call the team members and get their needs. It was easy to distinguish work and non-work in the past. Now, if you work from home, you have different needs, different constraints. Young kids, all the aging parents, and so on. Get the needs of everyone. Then you can put the needs of the team. Maybe you need a really synchronous time where everybody is online. Lead the way, share your constraint first. You don't expect that everybody will open up and share, and you in the end don't share anything. Start, share your constraints, your vulnerabilities. That's how we build trust. You wouldn't fix it with one meeting, make it a recurring format, and make sure if people share, this is not penalized, it's stay confidential. Share the quick wins. If somebody share a constraint, don't have a room for like 3 hours budget review, maybe co-working space and so on. If there are solutions to their problem, share. That would make people that it's not just a lip service, we mean it. And then very important, be a watchdog. Watch the language. Don't, we miss you, come to the office, why don't you come? Doesn't help, just pressure. We miss your ideas, we miss your empathy, but we understand your constraints. How can we help? This how can we help? How can I help as a leader? This is the key question. And again, micromanagement is not an option in virtual teams. You cannot control, it's counterproductive. The name of the game is empowerment. So put the goals, put the roadmaps, let the people choose. So you set the nucleus as a team, people choose their individual goals, and then set them free. On the how, let them decide, within some budgetary and time constraints. And then if you made a mistake, because we live in an agile world, be the first one as a leader, hey, I made a mistake. The first one as soon as possible. Celebrate the mistakes. This is how we learn. Because of this, this, and that. Because that's the learning. Maybe you made the wrong assumption. You don't do it on purpose. In this way, you enable others also, if they do a mistake, to share. A few ideas from Google. They have their hybrid work. They have this team pods. Everything is on wheels. You could build as big as you need space with this smart camera. Everything on wheels. You have this privacy robot. So this is a wall which is inflating. If you need privacy, you click a button. It gives you visual privacy and audio privacy. You finish, click, this robot wall disappears. And then you could just scan, and if you need a standing desk, this will adjust to your preferences. Now let me share a few tips of the companies that work fully remote, that don't have an office and still deliver best results. Like Airbnb, they had their best results in the last 2 years. Even that the tourist industry was negatively impacted by COVID, working fully remote, they had best years. And now they go remote first policy. 3 principles: full transparency, very brief. Each employee have the information of the CEO. The P&L, if you need to lay off people, what are the arguments? Full transparency. Second, the leaders. This organization happened to be flatter. So the leaders master the video. They send the messages why we do on the why, 10 minutes video, and they track if people watch or not. And then they do retreats. If they don't have the office, twice a year they meet, all hands, build a project roadmap. There is a lot of know-how how to leverage on these events. As a mathematician, cannot leave you without one formula, and this is virtual power teams. P is personality. Let people present themselves as human beings. V is vision, the nucleus. Make sure the nucleus is defined bottom up. I is intimacy. Let them connect as human beings, not just an expert. And S is self or ego. The less, the better. If we define the team, in some corporations, some managers have hidden agenda, which facilitates their career, their bonus scheme. If we have the goal set up as a team, and everyone picks his individual goal, and a lot of praise, 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 you don't have to develop your hidden agenda. So just mention this story. That was the €1 billion project. That was a client, global fast-moving consumer good companies, and they had Chinese traders buying their goods in 6 countries: Australia, UK, France, and putting them on Alibaba. And the overall volume was €1 billion. And then the vice president of business development said, okay, let's be smart, ask the general managers in these 6 countries, get together, accumulate the volume, so the procurement can do a deal with Alibaba. 1 year passed, nothing happened. Very busy people, big egos involved, so he said, okay, let's set up a project and build a powerful virtual team, very diverse. So 10 people, the 6 GMs, supply chain, finance director, HR. We were in Amsterdam for 1 day, and we defined the culture on 3 scales. First was the leadership scale, distinguishing between hierarchical culture, and where you have big distance between boss and employee, you ask for permission, wait for approval, and egalitarian. You're expected to be proactive, to challenge your boss. And different countries, they fall on the scale in a different, like, it will be interesting whether you see Bulgaria, but like China, Russia, Japan, they're very hierarchical, Scandinavian egalitarian. So ask them to put their optimal position on the scale. And their aha moment was, they say, okay, we will be more egalitarian, where is the first star, until we reach project mandate, high-level project definition. And then we'll be more hierarchical. Now, this is the brief. Give it to the Chinese. Now go on and deliver. Similarly was the decision scale, top-down versus consensus, and then disagreeing or conflict scale. And then everyone committed based on this, what can I do in order to enable this culture? And what our leader can do in order to enable it. So culture is a soft thing. You cannot impose it, but if people choose it themselves, the team in a well-moderated format, and they make a commitment, they hold each other peer accountable. So this is the only way, from my perspective, to introduce culture. Let them choose it and hold each other peer accountable. So we had, in the end, 0.1% profitability, which reducing the project cost was 80 million. So winning spirit, I will send you a video on the winning spirit. This is the Global Services Project. It's a very nice story. I love it, but happy to share a video with you. We went to Tenerife, Canary Islands. We said, if we finish this 2 years project, 3 months earlier, we'll go all 30 people to Tenerife, Canary Islands. We convinced the project board because the people cost was €1 million project, 1 million per annum. If we finish 3 months earlier, we save 250, and with 50 we go. We had this visual reporting, which is key, like an island, and the palm tree and the parachuters, 20 parachuters for each of the country. And visual and virtual is key. If you know where we are towards our goal at any moment in time, if you know who needs help, who can help, who already landed on the island, you create a winning spirit. People go extra mile. So we had a top customer feedback, we saved 200,000 net, and we had a great party. Now, concluding, again, questions for you. To do all 10 big rocks in the detail, usually we do a tailored workshop, 2 days, when we tune it for your organization, your reality. And there is also, because time is very pressured nowadays, a digital masterclass where you, all these 10 big rocks, 6-hour videos, 20 videos, you can digest in your own convenience when you have the time. Before I go to the universe, and I see we have 5 seconds, if you scan this, you can get the Virtual Power Team book. It's already 5 years old, so now I'm happy to share with the world. Let's go back to the universe just for a moment. We started with a space journey. Let's go to the universe just for one kind of minute. Do you know that in the universe only 10% is material? 10% are planets and stars. 20% is like nothing, like black holes or phenomena the scientists still cannot explain. And 70%, the major part, is invisible energy, like the gravity that holds the universe the way we know it. In a virtual team, it's quite similar. 10% are the team members and the infrastructure. 20% are undeveloped yet potentials. And 70%, the major part, are the relationships, the trust, the gravity that holds the universe together. So the art to lead virtual teams is to focus on the 70%. And I'm sure you will be amazed by the wonderful fruits to come. So let me conclude with one sentence which has guided me through the years. And it goes like this. If you dream alone, this is just a dream. If we people dream together, this is the beginning of a new reality. Thank you so much.
We can do one question. Who would like to ask a question? Come on, don't be shy. Okay, I'll ask a question. What's your biggest strength, and how did you figure out that this is your biggest strength?
My biggest strength?
Yeah.
My biggest strength, I think, is because I was IT manager. I hope I'm not kind of overestimating myself, but it's inspiring people. If I'm inspired about something, I can transfer this energy and passion to the others. And I changed my job 8 years ago, and I never worked again, you know. So I think that's my biggest strength.
Amazing. Thank you.
Thank you, guys.
If you have further questions or you would like to reach out to Peter, you can find him in the networking room. It's right there, my right. Yeah. Yeah.
SAP focused on making businesses run better by pushing the boundaries of innovation and impacted the world and people's lives beyond anything the founders ever imagined. With 50 years of groundbreaking work, SAP will continue to lead the way with innovation and help the world run better and improve people's lives.
Как размера няма
Умре
значение.
циганката да точва.
Да.
Тест, тест.
Окей.
Трябваше да ни предупредят. Айде, долу.
Готови?
Седна.
Ние ще сме долу.
Ама може да ги спрете докато...
Okay, so what's coming next is a group of three. Yeah, I guess you already noticed them. We have Dimitar, Maxim, and Pavel. They are part of the Alcatraz AI team. This is actually the same team that Vince mentioned during the morning keynote. So they're here today to provide a little bit more details on the challenges that they're facing from scientific and technology perspective, and basically what it means to develop a product in the area of deep tech. Please give them a warm welcome. Guys, the stage is yours.
Let's, whoop. There you go. Hi, welcome to my to our talk. We'll be exploring a little bit about the technology behind our product that we call the Rock, that you can see here. Yeah, as Chris already mentioned, there will be a couple of us that will talk about different aspects of the software development and testing around this product. So first, a little bit about me. I have some experience in a low-level C++ development, in computer vision, and some years ago I did a PhD in applied mathematics, and right now I'm leading the machine learning and embedded team in Alcatraz. So the responsibility of our team is developing this device. And this is a brief outline of what I'll be talking about. So I first mention what is our core tech, what are our core features, how do we go about solving them, and then I'll give a couple of examples about a high-level overview of the major features that we provide, and some technical detail, not too much. So okay, let's begin. What is our core tech? What do we provide? What do we try to do with this device? The thing we are trying to do is we're trying to replace or augment the ubiquitous batch reader that is present in a lot of offices and a lot of places. We're trying to supplement it with facial authentication, where you can use either one or both. We are trying to do all of this here. Besides this, we are also trying to do stuff like tailgate detection. We're trying to support large data set. This device needs to be able to work alone or in a fleet of other devices that communicate with each other. And additionally to that, we also integrate with various via video management systems that you can use to directly stream whatever we see. So as you can imagine, these problems are not so easy to solve, especially on a small embedded device. So first, I'll give you a quick overview of how we go about solving these challenges. And what is our approach for development? First, we started, we control the full vertical integration of the product. So we do the hardware platform selection ourselves. We select what kind of cameras will go. Do we need color cameras? Do we need infrared cameras? Do we need depth streams? Stuff like that. After we selected the hardware, we go about using our own custom Linux image that is based around the Yocto project. Maybe some of you are familiar with it. that is tailored to our needs. It only has our services. It only has whatever we say is available. Only our ports are open, etc. And the final step, and this is the main responsibility of my team, is developing the applications that run on this device, like reading the frames from the camera, doing face authentication, RTSP streaming, stuff like that. How do we develop this thing? So as you can imagine, we are trying to squeeze as much as possible from this device. So we are using low-level languages for developing all the heavy hitters that run there. Specifically, we are using C++. We also need to be able to analyze whatever is happening there. So we developed some lightweight tools that don't impact the performance of the device itself, but can actually get tons of algorithmic data per second that we can later use to analyze and optimize our algorithms. On the machine learning side, you can use whatever model you like, but it just doesn't run as well on such a device. So we are doing specialized machine learning models that are tailored for our hardware and still perform nearly state-of-the-art. We also spent quite some time, of course, tuning our cameras for various lighting conditions. You need to be able to work in bright light, in low light, in various rooms, etc. We need to be a little bit. We need to be structured. We are a small team, so we need to be able to move very fast and not worry about, hey, what we did last year. Okay, we can't reproduce it, but let's redo it again now. We spent some time on doing our machine learning infrastructure. We are doing stuff like tracking our models, tracking training, and visualizing wherever we have errors, stuff like that. And we support training on the cloud, training on-prem. We're trying to make things as easy as possible for our development. And we also developed some tools for data collection, visualizing this data, and annotating this data. So now I will mention some of our main features that our product provides, and I will give you a brief overview of what we had to face in order to solve them. So for the main feature, of course, is facial authentication, since if you cannot do the facial authentication okay, you cannot really replace batch readers. So what are our aims here? We are trying to accurately identify a single person in a relatively large database of profiles. You have tens of thousands of people enrolled there. Indeed, this also needs to be cheap enough so that it can run on this device. And we're also aiming to be frictionless, so you cannot just stand for 10 seconds there and you have a queue of 10,000, 100 people behind you. So it needs to be fast. And you also need to make sure that you don't just show your phone there and suddenly you open up the door for everyone. And of course, like I mentioned several times, this needs to work in a lot of places. I wouldn't say everywhere, but you cannot really say you have to modify this lighting here. This is no good for us. So I will focus particularly on one of these issues. On the spoof detection, liveness check, there are different ways you can turn this. So this is specifically this check to see if this face is real. Is it a mask? Is it a paper? Is it phone, tablet? So why is this challenging? It's challenging because unlike other machine learning programs where you have vast amounts of data, you can even scrape your own data from the internet, or there are just big data sets of links that you can use to download various data online. There are actually not a lot of data sets that tackle multimodal data. And even fewer are targeted specifically for liveness detection. And you have various modes of attacks, like I mentioned, papers, bent papers, masks, phones, tablets, etc., etc. And even if you find something, it most likely is collected with a specific camera, which I don't know how many of you are familiar with computer vision and machine learning, but if you actually collect the data with just a single device, the model itself can learn intricacies of just this specific sensor, so it wouldn't perform very well if you move it to another type of camera. Or sometimes even in the same family of cameras. So what this brought us is that we needed to do some data collection, that we had to organize, we had to pay actors, we had to hire venues, etc., and we had to plan and budget this. And our final model that we currently use is a combination. It uses a multimodal input of our color, infrared, and depth streams that we have available on this device. So the other thing I want to mention is tailgate. This is actually a movie. Can you just click? OK, anyway. In the movie, you should be able to see two persons walking through the door. One of them has access, and we open the door, they go in, everything is fine and dandy from their point of view. Yeah. However, a nefarious person tracks them behind. And this is when we trigger a tailgate alert that goes to our online platform that Pavel will talk about in a minute. So first, what is tailgating, right? As it turned out, when we started doing this feature, everybody had a different opinion what we need to do with it. So of course, the first obvious thing is many people say, OK, let's just prevent entry. But doing further thinking about it, we decided that this can actually introduce friction, which is one of our core tenets, that we don't want to introduce friction for our users. And so what we decided is, imagine that you're just going for lunch, a big group of people comes back, not everybody authenticates, but you still don't want to close the door. It's just the front door of your office. So what we decided is that we'll actually target tailgating alerts upon door entry, and it will just be alert, but it can send this alert to various places, not only our platform, but also to access control systems that are specified for it, etc. So we distinguish three types of alerts. We distinguish tailgate, where you closely follow someone walking in front of you. Then we also have crossing, when somebody just walks out of the door and somebody that shouldn't be there sneaks in. And the final one is just general unauthorized entry, where somebody propped the door open. You don't know who it is, but somebody who shouldn't be there goes in. So what are the challenges around tailgating? As simple as it sounds, on first view, you actually have to consider that there are multiple variables to consider here that you have to take into account. For example, these people can walk from various angles on this device, and they can try to sneak in, etc. Some people walk very fast, some walk very slow, so we have to be able to properly track all of them. And you also, since we cannot use very wide angle lenses or fisheye lenses, because we want to have accurate facial authentication, actually you have to be able to see the door with just regularly wide lens, not so regular. And we also have, some clients have small doors, some have wide doors, some can place the device next to the door, some have to place it like half a meter away or something. So just a brief overview, how do we solve for these problems? First is a hardware solution. I don't know if you can see it easily, but we have a slight 30-degree tilt on the device so that we can actually see the door whenever somebody enters. Then we chose such sensors that they're very, very quick, so that you don't need high exposure times, which can lead to motion blur, etc. And of course, this allows us to see people better. Then we also track all of these people in the 3D space at 30 FPS, which accounts for very fast walking people. At 33 milliseconds, you cannot just take a lot of, you cannot cover a lot of distance. And to account for the various doors and specifics that each client has, we expose a lot of controls that they can tweak for their specific needs. And in order to benchmark all of this, we gathered, again, hundreds of real-world scenarios where we are trying to simulate this tailgate in various conditions, various attacks, etc. And I don't really have the time to go in depth in this, but in the end, if somebody has questions, we can answer them. And with that, I will hand the baton to my colleague.
Hello, everyone. My name is Pavel Zlotanov, and as you can see, I'm the full stack team lead at Alcatraz. A little bit about me is I have over 10 years of software engineering experience. I have worked on large-scale applications, and I always had a passion for IoT and embedded devices. And in the last 3 years, I had the pleasure of working on one. So today I'm gonna tell you about how we created the backend, so the device actually operates as a fleet and not as a single entity. I'm going to talk about what was our first and initial idea, what we wanted the product to be, how we deployed to pilot clients, and what we learned from them, and how that actually evolved and changed our product. So initially, when we talked about what we want to achieve, we set out to make a cloud solution, a cloud backend, where the devices can connect. And of course, we needed to develop our own custom synchronization algorithm for the device, because we have a lot of logic we want to apply about security, where different profiles of people go and why, and what happens when you enroll, and etc. And once we had the basic components of that, we wanted to start deploying to pilot clients very early, so we actually can gather feedback and develop the rest of the platform based on those feedback. And of course, clients wanted different ways of visualizing the tailgate events that Max just mentioned, different controls over when a person enrolls with his card on the device. It goes to all the other devices that have never seen that person before, etc., etc. But one of the big things that we found out is that large enterprise and government institutions actually are required sometimes by law to have their biometric data stored in their own infrastructure, behind their firewall, and in their building sometimes. So this created an issue for us that we had to solve, and solve actually pretty quickly, is that we had to move from a cloud product into an on-premise solution for our clients. On the cloud, we had a very standard setup and infrastructure. We had microservices that were running on a Kubernetes cluster. The microservices were written in many different languages. We had some Go, we had some Node.js, we even had some Python scripts running on AWS Lambdas that were triggered when needed. And even though we tried, that wasn't going to work for on-premise deployment for a client, because we want the product to be easily installable and easily maintainable afterwards. And that setup required a lot of attention from DevOps people. So then we sat down and thought about what can we do about that? How can we solve that issue? And out of that thinking came out the realization that we would actually have to start from scratch and rewrite the whole backend, basically, so it can fit to an on-premise solution. We chose to rewrite everything in Go, which allowed us to produce native binaries for Windows and Linux, and use those to containerize them in Docker and still deploy in the cloud, because we wanted to keep our cloud for multi-tenants and for clients that actually didn't care for on-premise and wanted to not manage anything, can use directly a cloud solution, which also one of the options we had to get. And on the cloud, we were using many databases for different types of data sets that we had, so we had to move into one. And with all that rewriting, of course, we had to rewrite our CI/CD pipelines, so they support this. They can now produce builds for Windows and Linux natively, and also deploy on the cloud simultaneously, and to QA environments, etc., for testing. And the other thing that we had to solve that was easy on the cloud, especially in the AWS environment, is the backup, debugging, and monitoring of those services. So we had to do a lot of changes there. But in the end, by using Go and between the services, so from microservices, we went more into services that are based, for example, one service is doing only the syncing between the devices, one service is doing only the UI, another one is doing the firmware upgrades and configuration of the devices. So even if any one of them goes down, while Linux, for example, is restarting it, everything else continues to work normally. We used, between the services, we moved completely into gRPC communication. We used protobuf to define the APIs, and that made it actually quite easy to have different people or teams working on different services and knowing what they want to achieve in the end. So we defined the API, people started working simultaneously, and everything worked out great in the end. So here's a small diagram of how actually the ROC works in the client. You can see the ROC itself is connected to the access control panel, which opens the door, and also to the reader by which it collects the badge data for the person that is currently being enrolled or in front of the device. Then the ROC is connected to the Ethernet, and possibly if the client has a video management system, it goes directly into there. And in the case where he has more than one device, which is all of the cases, it goes into either the cloud solution that we provide or the on-premise appliance we give to some clients, or their own infrastructure if they choose so. So once we are able to produce native executables for the platforms, we actually had to, of course, build installers for those. So we built a Windows installer, we built a Linux installer. Actually, for the Linux installer, we had a specific requirement that it should be a terminal-based one. So people that have, for example, tools for automation of deployment can use those, or deploying a VM, they can just use the terminal to connect SSH, install the backend, and from there, the same tools can be used to monitor and gather logs. In order to do that, we also had to solve specific platform issues, like, for example, where do the logs go? On Windows, they're going in their correct place, which is an event viewer. On Linux, they're going into the journal. So this way, when someone is trying to debug what's happening and why the system is not working, and it's an on-premise solution, and especially some of our clients required it to be an air-gapped on-premise deployment, so no connection to the internet. They know where to look for what, and then in the case where they cannot figure it out, they can send us the log so we can help them and move forward. Another thing we found out and didn't anticipate in the beginning is that many of the clients have unique infrastructures, and we started deploying to clients that were waiting for this feature for a long time, and they call us and say, hey, it doesn't work because the ports you're requiring are actually blocked by our firewall. So we had to adjust the amount of ports we were using and some other network-related issues, which, again, were unique for each and every single client. The last thing that was kind of hard is that even though we rewrote all of our code base from scratch, we still had some third-party dependencies. For example, the software we were using for firmware upgrades was not really designed to be deployed on-prem and forgotten about. It was more of a cloud solution that had many services. It used 2 different databases, so that wouldn't really work for us. And in a very short amount of time, we had to actually produce our own in-house solution for that. And I think those are many of the important lessons that we learned from having a cloud-based product and wanting to move it on premises. And again, the hardest of those was the air-gapped, where no internet connection is provided, so the installer has to bring all its dependencies with it. Also, unique problems came out that one time Windows decided to update its Defender, and Windows Defender decided that one of our services is a back door for some reason, and will not let it work. So yeah, interesting things came out of the deployments. And during that time that even initially developing the backend and the rewrite we had to do and moving to the on-premise solution, we always had in mind that the privacy of people is very important. Our ROC is not designed to contain any personal information, so once you are enrolled, it creates a biometric profile for that face. If it's connected to a platform, it's going to sync it. The platform is going to deploy it based on the access controls to different doors that this person has access to. We take that out of your card, so we communicate with the access control system to figure out, okay, this person needs to be this door, that door, and so on. We, of course, do end-to-end encryption on all communication between the ROC and the platform, the ROCs themselves, everywhere. We have never developed a feature where the ROC is tracking or collecting any data or information about someone that has not already willingly enrolled on it. So if it doesn't know your face beforehand, it will just ignore you, or maybe in some case, give a notification when you try to run in if you are doing a tailgate, as Max explained. And we have added many features in the platform about deleting profiles. We have features where if a profile is not used, it's automatically expired and deleted and cannot be restored back. And we even have a full privacy mode, which when turned on, the ROCs and the platform stop collecting any kind of pictures of anything, which is not that useful in the case of the tailgate, because you want to see who actually did the tailgate. But some people actually want the frictionless access and moving fast while you're having a coffee in one hand, a book in the other. You don't want to pull out your card. In that case, we don't even collect the pictures, but the device continues to operate normally, simply because of the fact we build your biometric profile and we don't need or use the pictures anymore. And that's about it. So now I'm going to give the word to my colleague Dimitar, who is going to tell you more about how we actually test the ROC, the platform, and the integration between them.
Thank you, Pavel. So this is me. My name is Dimitar. I'm leading the QA team in Alcatraz. I've got a little bit of experience in the software testing sphere. I have some certificates, and usually I have to travel and ski. So before going to the agenda, I want to jump in with an abstract, and we have to always consider one thing, no matter we are testing traditional technologies or legacy systems where we have tons of automation or documentation and oracles, etc. Or we are approaching to test modern solutions like machine learning algorithms or AI cutting-edge devices, and this is the quality. We have to consider the quality. So these new technologies bring new challenges in front of us and new obstacles that the engineers have to deal, also the testers. The most critical thing that this solution have to make is the decision whether to grant or restrict access. Latest security research shows that malicious physical breach could lead to data loss or value loss for companies that are too costly to measure. They vary from a couple of millions to hundreds of millions, or company bankruptcy. So we have to make sure this is a quality solution and impenetrable. No one should bypass this solution and gain malicious access. So the agenda that I'm going to talk about today is topics in the testing in the domain of Alcatraz, which are face detection and recognition. It's data collection. This is vital part of our testing process. Then how we train the machine learning algorithm, because testing is actually training the algorithms. And of course, as a tester, we have to verify the negative part of test case, which in our domain is spoofing, someone trying to bypass or lie the system that there is a human being in front of it. And at the end, I'm going to talk about testing the platform and our approaches there. So, talk about face detection recognition. What are the challenges in this? It is the same that a human being is detecting that an object is a face or an AI solution, and it's the human face characteristics: eyes, mouth, nose, ears, hair, etc., skin temperature, and so on. And we can, on top of this, add accessories like glasses, heads, swimming glasses, scarves, etc. And on top of this, we could add environment conditions like lighting, position in the office space, etc. So all of this brings the challenges that we have to solve when we are going to about detecting and authenticating a human face and distinguish between real and fake. So about the algorithms, non-deterministic and deterministic algorithms, what's the difference? Deterministic algorithms are simple one and traditional one, where we can 100% predict the output when we have the same input data. Non-deterministic algorithms are more complex and heavy. They're used to solve complex solutions in a very small amount of time, where if you attack those problems with traditional algorithms, it will take almost infinite time to solve them. Those algorithms are such that you cannot predict the output even with the same input data every time. So modern machine learning algorithms are developed to be deterministic, but they are proved to be error-prone. What this means, even an insignificant change if the input data, for example, the lighting conditions, could lead to very different output data from the algorithm. And how we, for example, solve this? Let's say a developer comes to me and say me, this is a method that detects whether a face is male or female. Okay, I appear once, twice, 3, 10 times. It say, okay, but is it actually real? What if one of the 10 times it says I'm female? I discuss with the developer. Let's have different environment conditions, different scenarios with the same person, run it 20 times, 30 times, 50 times. And then we can have this success rate measuring, and we can talk about properly algorithm working. And as you can guess now, the data is the critical part. We need lots of data, tons of data, variety of data, and most important is the balance of the data, because if we train more the algorithm in one area, it became biased in this area and less successful in other area. So I'll jump with a small example here. I have just a little group of classification of the short parameters of human face, and we can end in total of 600 combinations with just this sample example. And if we, as I say, run 20 times in different conditions, this test case, the same test case, with a very slight change in the input parameter, we end up with 12,000 tests without even including the accessories that we could have, scarf, heads, glasses, etc. And this is why the data is important. So how we execute the data collection? We make it in different locations because it should be diversity. We collect real face data, we invite actors, and we collect a couple of hours, a lot of scenarios in different conditions, different accessories, so we can have correctly classification, correctly balanced data, and diversity data in the same time. We organize and store this data appropriately so we can easily approach the training part of the algorithm. How we do the training? We have multiple iterations. On each iteration, we add the right portion of balanced data. After that, we measure the success rate. And then, if we are happy with the success rate, we continue in the next phase. And we have multiple iterations where we add right portion, right balanced data to make sure that the success rate remains the same as initially and as we want it. And when we conclude with this, we are approaching to cover the negative tests, which in our domain, as I mentioned, is spoofing. Spoofing is when someone is trying to bypass the system or penetrate the device. So what are the spoof attacks levels in our domain? First one is photo attack, print attack, when someone is showing a photo in front of the device, trying to simulate a human face. The second one is eye cut, nose cut, mouth cut, where you're trying to make some of the characteristics of the person real. Third one is wrapped photo attack, where you're trying to make a 3D effect of the object inside. The next one is replay attack, when you're recording a video or presenting it to the device, whether of tablet or phone. And the next one is the 3D mask attack. We have lots of masks in our office. You put a mask of a person that you have his picture, etc., and you're trying to mitigate the same face, but with some limitations. And the final one is the makeup attack, when someone is making his face exactly the same as the person he wants to look like, trying to penetrate the system. So how we approach to collect data here is the same way, but we multiply the process 6 times and collecting the same data, same conditions, same environment variables, but just we multiplied by 6 in order to mitigate each of these spoofing attacks. And then we have the same data for each of these spoofing attacks. We are approaching to train again the algorithm in this way, not to authenticate, but to detect whether this is real or fake face. We, again, do the same iterations. We add the right portion of balanced data, and we measure the success rate there. And if you're OK with it, we continue, etc. We have the bug testing iteration with developers, and those incremental iterations with balanced data lead us to the same frictionless experience that we state we want to achieve initially. And last part is testing the platform. It's a kind of traditional solution, but our approach here, on top of each unit test, API test, UI test, is having a different view, like profile synchronization. We have to be sure that the administrator of this platform is able to pick whether the right person have access to the right door to prevent malicious access. And we are testing the synchronization of the network of all AI edge devices that are working correctly. We are testing that configurations has correctly spread the integration. We are testing that whether the range of view, the length of view is the same. Is the device usable? Do we bring this frictionless authentication to the user that we want, no matter of the environment condition? And for reliability, is the device working 24 hours? Is the device working all the time? So in case of there is some network loss, is the device continue to work autonomously because it not need connection to the server? It still delivers the same functionality due to the edge computing part and brings this frictionless experience to the users. And finally, we are approaching the scalability. We are testing whether a large corporation could have their employees coming to, for example, in the morning burst, coming to work in the entrance of office on the turnstiles, for example, 10,000, 20,000 people want to grant access with the same frictionless experience that, for example, you can have in a small office. So that's about testing the platform. And I'm going to show you a demo of our device, which is here. We believe that we are revolutionizing the way people enter secure spaces by this. So the device can work in 2 options. One is the legacy, which is some legacy organizations are using. They're trying to, when an employee comes to the office, they're going to the facility manager. It grants him personal badges, and they have to enroll in front of him. And we have the self-enrollment part where user just badge on the device, and the device learn his face. And after several badges, the user has not the need to bring his badge, and he can be just authenticated with his face. And that's about it.
Do we have any questions? OK. Just wait for the microphone.
Do you guys also test that nobody can kind of hack the platform itself? For example, communication between the device and the, for example, upload a profile or something like that?
So communication between the device and the platform services happens through secure layer with certificates, and it's encrypted.
And to add on top of that, we are going through yearly security reviews, meaning that we send our product to a third-party company that do the penetration testing for us and then give us a certificate for that. Does that answer the question?
OK, it doesn't seem that we have more questions. So thanks a lot again.
Thank you.
Изядох ви времето аз.
SAP focused on making businesses run better by pushing the boundaries of innovation and impacted the world and people's lives beyond anything the founders ever imagined. With 50 years of groundbreaking work, SAP will continue to lead the way with innovation and help the world run better and improve people's lives.
Stripe Bulgaria was founded in 2008 by the Dutch entrepreneur Koen van Wijk. His vision was to create solutions that exceed customer expectations. Since 2014, Stripe is part of the ICT Group in the Netherlands. ICT Group is a stock-listed company on the Amsterdam Stock Exchange and employs more than 1,000 professionals. Since 2017, I have the privilege and honor to drive Stripes forward in the role of CEO. We offer solutions to our clients in digital transformation, smart applications, and infrastructure. Our mission is to build smart solutions that create business impact. We are Stripe.
We're a pretty resilient species, and that's true now more than ever. So we deserve app experiences that are as resilient as we are. This starts with apps that can scale to keep pace with shifting demand, or update at a moment's notice to support entirely new business models. In a time when the app experience has become the human experience, being future-ready means keeping people at the heart of innovation and flexing to meet their needs. Because technology really can change the world, but the best technology changes with it.
Merkle започват официално в България на 1 януари 2022 година, но двете компании, които обединява са на нашия пазар доста по-отдавна. ISTA Commerce и Life стартират съвместна работа като част от новата бизнес линия на Merkle Commerce and Experience. Аз съм част от това семейство от 13 години и заедно с много мои колеги преживяхме най-различни метаморфози на фирмата. Започнахме като малък стартъп, наречен Никомера през 2008 година. Тогава празнувахме успешен декемврийски ден на коледно пазаруване с цели 1000 онлайн поръчки за 24 часа. През 2015 година Екомера беше придобита от ISTA и стана част от бизнеса на Денцо. Това ни позволи да спечелиме нови вълнуващи клиенти и на последния черен петък през 2021 година достигнахме пикови стойности от 1000 поръчки в минута. През цялото това време сме разработили и внедрили над 400 transactional сайта. Работили сме с клиенти в над 60 държави и имаме онлайн магазини на 6 континента. Качеството на кода и поддръжката ни е ненадмината. Затова свидетелстват и нашите клиенти, с които работим заедно вече повече от 13 години. Днес сме Merkle и целим да поставим нови рекорди с качеството на кода, който пишем.
Okay, we're ready to continue with our next speaker. His name is Stefan Zhelyaskov, and his passions are about simplicity, cutting-edge technologies, and performance. He used to work for teams that were developing products for companies such as WeWork, the Goldman Sachs, and Honest Buildings. Lately, in his role as an associate architect with Musawasoft, he's dealing mostly with topics related to security, digital signing, and authentication. So, Stefan, the stage is yours, and let's give him a warm welcome.
Okay. Thank you. Okay, so this is an interesting scheduling of talks because the previous presentation was about authentication in the physical world. And this one is going to be about authentication in the virtual world. And authentication in general is a very hard topic. And one of the players that makes all of this possible is called JWT. And what powers JWT are the principles of cryptography. So a little bit about me. Hi, I'm Stefan Zhelyaskov, and I work at Musawasoft as an associate architect. As Christo rightfully said, the areas that I currently focus on are digital signing and public key cryptography. And previously, I worked for several years in the United States at companies of various sizes. So you've probably seen this everywhere. These are the two most popular and the most dreaded fields on any website. You need your username and password. And you need this for your online banking, social network, professional network, or your email account, or when you use a search engine, or for video streaming, or your phone carrier, as well as when you do like shopping, maybe for food or clothes or technology, gadgets, and the list just keeps growing. And what's more important is that each of these websites asks you to register uniquely with it, and it's preferable if you use a different password. And on top of that, the password must be something that is hard to guess. Like it needs to use uppercase characters, lowercase characters, special characters, digits. And this is difficult. And so a lot of modern browsers, what they do is they actually suggest to you strong, secure passwords, like this one. I mean, what is this? Like, how can you remember this? Like, we're all human. Like, a password is supposed to be intelligible. It's supposed to be something that you can actually remember. Like, password consists of two parts. Password, it needs to be a word, something that you can actually put your head. And if for all of these websites you need a unique password, and you put them together, it's going to look something like this. And can you remember this? Like at this point, all that we need is just put a header and a footer, and we figured out how OpenSSL generates certificates. This is a joke. It does not work that way. So it would be great if we can live in a world where we just don't use passwords. Literally, it will be great. But at the same time, because we use different apps, we actually need something to uniquely authenticate ourselves. It's got to be something different that provides each time. And so there is a solution for this, and we're going to look at that in a little bit. But you might also notice that on the slide, there is a third bullet point, and it's empty. And that's because there is another challenge that we need to solve, and we're going to look at that in a little bit. But first, let's solve the first two problems. So here we have something called a session ID. So our user Ivan is a fan of ISTACon, and he uses the app, and he supplies his credentials, and the server returns a session ID. So what does the session look like? Well, let's take a look at a server. So here, I'm showing you two screenshots from a real Apache server that I have at home. And so in the bottom screenshot, I've catted the session, and I can see what's in the session. I can see my first name is there, my last name. There's also expiration date for the session, other information. And so what's interesting is that this is in the session. This information is in the session. Where does that session live? Well, let's take a look at the first screenshot. It lives on the hard drive of the server. It's literally on the physical server in a directory. And so maybe at this point you're starting to see a problem, but let's look at an example. So what if we take the server and we replicate it multiple times? This is very common for modern day apps. And in front of it, we put a load balancer. And so we still have our user Ivan. He sends a request with his credentials, and the first server returns back to him the session ID. Now, Ivan wants to go to a different page on the app. So in the subsequent HTTP request, he submits the session. But this time, the load balancer sends the request to the last server in this picture. What do you guys think the server says? It says, excuse me, but who are you? And that is exactly the problem. In this setup, the last server does not know who that person is. And so this is the third bullet point. We need to fix this for a replicated environment. And so, ladies and gentlemen, here I present to you the JWT. What is the JWT? Well, it stands for JSON Web Token. It's supposed to contain in itself the information that we need to know about the user. So pay attention to this. The session, the information lives on the server. In the JWT, it's in the token, and the token is on the client side. Different setup. Now, because of this, it has to be small because you're going to send this in every request. So if you have a lot of network traffic, it's got to fit in. Now, the JWT has two flavors, JWS and JW. They both have claims. We're going to look at that in a little bit. And something that I found interesting is that the W in JWT is pronounced like the Greek letter omega. It's pronounced jot. And I know some people call it jot, but more people call it JWT, including myself. And so what is the diagram, the relationship between the different tokens? So JWT is actually an abstract idea. And it has two implementations. One is JSON Web Signature. The other one is JSON Web Encryption. And at this point, you might be like, wait, I only know about JWT. What are these other two guys? And the truth is, JWS is what everybody calls JWT. Basically, JWE is not in the picture. So the wisdom of the day is JWT is JWS. And I'm going to use these two interchangeably. But we'll look into details in a little bit. Now, let's take a look at this structure because it's more popular. You've seen it. So it consists of three parts. It has a Josie header, which I also call Jose header. And the header contains information about the cryptographic algorithm that is used. In this case, it's HMAC with SHA-256 hashing function. The type of the token is JWT. Now, the second object is the claims. This is what I said earlier about the information. It lives in the token, not on the server, in the token. So here we have the subject. So SUB is subject, EXP is expiry, and ISS is not the International Space Station, it's issuer. And recently I had a funny anecdote at work where I wanted to add a custom property, and so I called it cus. And a colleague asked me, why didn't you just call it custom? Like, what's the big deal? And I said, well, I follow the conventions of JWT. So, and the last component is signature. That is also base64 encoded, and this is a cryptographic signature. When we look at when all of this is put together, it looks like this. The three components, you can see them colored in different colors. So we have the header, the content, the claims, and the signature. And so when we take a look again at the two different structures, JWS and JWE, they actually look like this. So in the JWS, or what we call JWT, we have the header dot claims dot signature. Now JWE is a little more interesting. It has 5 components. It has, again, the header, which contains the cryptographic information. It has the key that encrypts the data, real encryption. It has an initialization vector, then the cipher, which contains the encrypted information, and authentication tag at the end, which is just for verification. But again, this structure is not popular. I don't want to talk much about it, just this is the slide, because it's not popular on the web and people mostly use JWSs. Now again, something that maybe comes to mind is when you look at this and it looks like gibberish, you can't read it, and you think, oh my God, this must be encrypted, I can't read it. No, it's not encrypted. Just because you can't read it, it doesn't mean it's encrypted. Actually, encoding, in this case base64 URL encoding, is different from encryption. In encoding, you convert characters from one type to another type, and you can do that back and forth. There's actually things online, websites you can go to, and you can convert back and forth between base64. So all of this means that the claims, the information in the token is public. It's always public. So this is something that is important. And here I'm showing to you how base64 URL encoding can convert between the claims back and forth. Again, this is the important information in the token. Now, you might think then, well, I don't want everybody on the internet to see what's in the token. How do I protect this? One option for you is to use JWE. Another option is to use secure protocols like HTTPS, because there, everything is encrypted, including the headers. And the token lives in the authentication header, so it's encrypted as well. So this is a solution. And also, something that is important as well is that if you don't want your token, or you worry your token might be read by someone that shouldn't, then just don't put sensitive information in it. Don't put your social security number, personal identification number, passport ID, or something like that. It's not supposed to be in that token. Like, just put information like that is enough for you to authenticate on a server. Now, authentication, as I said earlier, is difficult to get right. And how do we trust this technology? Well, the reason we trust it is because it employs the principles of cryptography. So here are the abbreviations. HS-256 stands for HMAC with SHA-256. RS-256 is RSA algorithm with, again, SHA-256 hash function. ES-256 is elliptic curve digital signing algorithm with a curve with a hashing function. And we use these algorithms to verify the tokens. So let's look at this, at the first one. as an example. So HMAC stands for hash-based message authentication code, which uses an internal hashing function, SHA-256 in this case. So here we can see that we have Ivan again. He wants to log in onto the servers, but the servers have a special key on each of the servers. So this is something that is embedded, hard-coded in the server, and the server is replicated. This server can issue tokens using that secret, using the HMAC algorithm. So Ivan submits his credentials and gets back from the server a JWT. Now he stores it locally in the browser, and then on every subsequent request, he can send that token over to the server, and it doesn't matter which server it hits. Each of them know the secret, and they can use the secret to verify the message. So they both sign and verify the message with the same secret. So this is a very simple scenario for where you control the whole application and you decide on the authentication. A different mechanism is to use public key cryptography. So here we have RSA and ECDSA. RSA, a popular algorithm for cryptography. It uses the theory of very large semi-primes. And large semi-primes are the product of large prime numbers. So it relies on that theory. And ECDSA is elliptic curve digital signing algorithm. It uses elliptic curves, a special type of mathematical functions. And specifically, this curve in this case is P256. That's a special curve in that algorithm. I'm just reading the abbreviations for you. Now, how does this work? Well, in this case, we actually don't have just one thing, like a secret on a server. We have two things, a private key and a public key. The private key must stay secure in the server. The public key can be public. Anybody can read it. You can send it to friends. You can send it everywhere. Now, how does this token then authenticate? Well, Ivan submits his credentials. The server receives the credentials and issues a token using the private key. And then on subsequent requests, Ivan sends back that token in the request, and then the server can use the public key to verify it. And this all works good, but when you control the server, you might as well use HMAC because it's just one piece, and you can use it back and forth. The public-private key relationship is more powerful in situations like this. Let's say you have a website that you want to log into, and a lot of websites nowadays actually provide you with this option to use an identity provider. And so in this case, Stack Overflow trusts these identity providers. It trusts Google or GitHub or Facebook. And pay attention to this. It doesn't say sign up or register. It says log in, because that's what you do. You actually can log in without creating a profile. How does that work? Well, we have this identity provider G, and Ivan submits his credentials to G. G has a private key, which it keeps private, but also has a public key, and everybody can read that key. And so when we receive the token from Google, then we can send it in our requests to our application. And then the server can look up the public key, verify the token, and it lets you in. And in this case, we can even improve it a little bit. Why don't we just memorize this public key? I mean, this public key isn't going to change often. So we can just put it in the server and launch many instances of that server. And it's always going to trust that issuer. And so with this, we've actually solved the three problems. We can log in without passwords. Each time we log into a different service using an identity provider, we have a different JWT, which acts like a password in this case. And this all works in a replicated environment. And with this, I thank you very much for your attention.
We can have a couple of questions, actually. So who would like to try first? We have one question there.
My question is, how to invalidate those tokens? So imagine that I want to now restrict the access.
Yes, so very good point. Something that is important about these tokens is that you don't want to make them without expiry. Like they cannot be infinite because inherently they can live forever and they will be forever valid if they have no expiry. So what companies usually do is they have very short expiry for these tokens, maybe 24 hours. So even if, for example, a person works at a company and he has access to the internal network, in 24 hours he can lose that access and no one needs to worry about it. So, 24 hours is a good deadline. Some other places have it after 8 hours, so that tokens can expire fast. But also there is a concept in the Open ID protocol. There is also like a list of tokens or public keys that shouldn't be used to verify these tokens. And so there are these lists that are also publicly available, but the concept there is a little bit more complicated, but it exists as a solution.
Okay, do we have other questions? Okay, then I wish you a nice coffee break and see you in half an hour. Thanks, Stefan. Thank you.
SAP focused on making businesses run better by pushing the boundaries of innovation and impacted the world and people's lives beyond anything the founders ever imagined. With 50 years of groundbreaking work, SAP will continue to lead the way with innovation and help the world run better and improve people's lives.
Stripe Bulgaria was founded in 2008 by the Dutch entrepreneur Koen van Wijk. His vision was to create solutions that exceed customer expectations. Since 2014, Stripe is part of the ICT Group in the Netherlands. ICT Group is a stock-listed company on the Amsterdam Stock Exchange and employs more than 1,000 professionals. Since 2017, I have the privilege and honor to drive Stripes forward in the role of CEO. We offer solutions to our clients in digital transformation, smart applications, and infrastructure. Our mission is to build smart solutions that create business impact. We are Stripe.
We're a pretty resilient species, and that's true now more than ever. So we deserve app experiences that are as resilient as we are. This starts with apps that can scale to keep pace with shifting demand, or update at a moment's notice to support entirely new business models. In a time when the app experience has become the human experience, being future-ready means keeping people at the heart of innovation and flexing to meet their needs. Because technology really can change the world, but the best technology changes with it.
Мъркъл започват официално в България на 1 януари 2022 година, но двете компании, които обединява са на нашия пазар доста по-отдавна. Isobar Commerce и LifeArea стартират съвместна работа като част от новата бизнес линия на Мъркъл Commerce and Experience. Аз съм част от това семейство от 13 години и заедно с много мои колеги преживяхме най-различни метаморфози на фирмата. Започнахме като малък стартъп, наречен Икомера през 2008 година. Тогава празнувахме успешен декемврийски ден на коледно пазаруване с цели 1000 онлайн поръчки за 24 часа. През 2015 година Икомера беше придобита от Isobar и стана част от бизнеса на Денцо. Това ни позволи да спечелиме нови вълнуващи клиенти и на последния черен петък през 2021 година достигнахме пикови стойности от 1000 поръчки в минута. През цялото това време сме разработили и внедрили над 400 transactional сайта. Работили сме с клиенти в над 60 държави и имаме онлайн магазини на 6 континента. Качеството на кода и поддръжката ни е ненадмината. Затова свидетелстват и нашите клиенти, с които работим заедно вече повече от 13 години. Днес сме Мъркъл и целим да поставим нови рекорди с качеството на кода, който пишем.
SAP focused on making businesses run better by pushing the boundaries of innovation and impacted the world and people's lives beyond anything the founders ever imagined. With 50 years of groundbreaking work, SAP will continue to lead the way with innovation and help the world run better and improve people's lives.
Stripe Bulgaria was founded in 2008 by the Dutch entrepreneur Koen van Wijk. His vision was to create solutions that exceed customer expectations. Since 2014, Stripe is part of the ICT Group in the Netherlands. The ICT Group is a stock-listed company on the Amsterdam Stock Exchange and employs more than 1,000 professionals. Since 2017, I have the privilege and honor to drive Stripes forward in the role of CEO. We offer solutions to our clients in digital transformation, smart applications, and infrastructure. Our mission is to build smart solutions that create business impact. We are Stripe.
pretty resilient species, and that's true now more than ever. So we deserve app experiences that are as resilient as we are. This starts with apps that can scale to keep pace with shifting demand, or update at a moment's notice to support entirely new business models. In a time when the app experience has become the human experience, being future-ready means keeping people at the heart of innovation and flexing to meet their needs. Because technology really can change the world, but the best technology changes with it.
Murkle започват официално в България на 1 януари 2022 година, но двете компании, които обединява са на нашия пазар доста по-отдавна. ISTA Commerce и Life стартират съвместна работа като част от новата бизнес линия на Murkle Commerce and Experience. Аз съм част от това семейство от 13 години и заедно с много мои колеги преживяхме най-различни метаморфози на фирмата. Започнахме като малък стартъп, наречен Икомера през 2008 година. Тогава празнувахме успешен декемврийски ден на коледно пазаруване с цели 1000 онлайн поръчки за 24 часа. През 2015 година Ecomera беше придобита от ISTA и стана част от бизнеса на Денцо. Това ни позволи да спечелиме нови вълнуващи клиенти и на последния черен петък през 2021 година достигнахме пикови стойности от 1000 поръчки в минута. През цялото това време сме разработили и внедрили над 400 transactional сайта. Работили сме с клиенти в над 60 държави и имаме онлайн магазини на 6 континента. Качеството на кода и поддръжката ни е ненадмината. Затова свидетелстват и нашите клиенти, с които работим заедно вече повече от 13 години. Днес сме Murkle и целим да поставим нови рекорди с качеството на кода, който пишем.
Oh, neat. Oh. Yes.
welcome back. Glad to see you again here. I would like to introduce our first speaker after the coffee break. His name is Ingu Mujenets. He is an architect, manager, executive with 20+ years of experience leading various global teams. His areas of expertise include mobile, software as a service, cloud, web, desktop, you name it. In his current role, he's responsible for defining and communicating, making transparent of architecture for basically the whole organization he is in. So his topic will be also focused on architectures. And yeah, please welcome Ingo.
Thank you. All right. Hi, everybody, and good afternoon. So today, before I start, I want to say great job pronouncing my name. I understand that it is complicated, but if it makes anyone feel better, pronouncing Bulgarian names is no easier for me, so we're kind of equal there. Anyway, so today I'm going to talk about architecture in the city of tomorrow. So a little bit about myself. Name is Ingo Mujenets. I'm Vice President of Architecture at Axway. I arrived at Axway in 2016. So Axway is a company that we have about 11,000 businesses worldwide as customers. We specialize in products such as managed file transfer, business-to-business interchange, and API management. And you may not know our company or our products directly. We have an office over here in the business park. But you likely know our customers, and they use us as part of their supply chains, as part of their interfaces with partners, and other things like that. So I arrived at Axway in 2016 via a company called Accelerator. Accelerator developed cross-platform mobile applications, and we had a SaaS platform that was part of that overall solution. When I came to Axway, I took that experience and that technology and helped build what we call the Axway Amplify platform. And that is the focal point of all of the connections from the various products we talk about. And then in 2020, I was promoted to chief architect for all of Axway's products. So looking at Axway as a company, it's not dissimilar from, I'm sure, a lot of the companies you work at. In our case, we are mostly formed via acquisitions, a lot of inorganic growth. So we have about 1,600 employees worldwide and about 5 or 6 main product lines. Each of those are really under a general manager model. So it's almost impossible to centralize all decisions. It wouldn't be worthwhile. But where we can combine or make things come between them, that really leads to cost efficiency and reuse. We also have multiple teams in many places. So we have engineers spread worldwide, and if we were to pursue something where we really had a centralized method of making decisions, it would likely introduce bottlenecks to people across the globe. And that's what we definitely don't want. We want developers to have autonomy within reason in their area, to feel empowered to develop things that are great. So when we talk about cities, and we talk about great cities, one of the things we think about is, yes, they are often beautiful, but that's not the only feature that's really valuable about them. They're also a great place to live. They are livable. So they have individual neighborhoods. They have individual buildings inside there, but they are within those neighborhoods, and those things that make it great are also in the fabric, a common tapestry across the city, which enables people to have a livable experience. When we think about smart cities, and I know that was mentioned this morning, smart cities are often smart because of technology, but that is built on the infrastructure that exists there. It is built on the pipes, on the buildings, on the roads. All those things contribute to making sure that the technology can really lay on top of that and provide the additional experience we need. Now, when we're talking about architecture, both at a city level, we'll talk about city planning, and then we'll talk about it in the context of architecture at a company. First, you really need a vision. Without that vision, whoever is providing it, that's what's going to enable you to take the vision, translate that what into a how. And so I'm going to focus on this at two parts. The first part will be thinking about it from a city planning level, laying out the overall idea of how we have progressive levels of architecture definition. And then I will go into the how of how we do this using working groups and the model we pursue on getting that both top-down and bottom-up innovation from our architects and developers. One thing you may see is there are other ideas out there like this that play into this, but this is kind of a holistic way of looking at it. If you're familiar with something like Netflix's paved roads, these are technology paths they create to make sure that developers have a great developer experience. This is one of those ways to decide which roads to pave. So first, we're going to focus on the what. I'm using some space-themed imagery here in between, but the idea is basically vision, then you're going to go to execution. So first, we're going to start with a city master plan. So in this case, the city master plan is provided either by the mayor, it could be by a master plan developed by a council within the city, but that provides a vision for where we want to go, and it also provides some detailed statistics, graphs, supporting evidence to make that happen. For our particular example, just to make it a little more concrete, we are going to think about the idea where all city residents need indoor plumbing and can have clean drinking water when their building is first built. Now, the idea of having running water in a city is not unusual or new these days, but that's because someone years ago, decades ago, thought of that idea and created the infrastructure to make that happen. So first we start with that vision. Then we get to the next level, which are zoning codes. So those zoning codes are done by a zoning council, and they structure where things will exist in this infrastructure, where we're going to put purification plants, where we're going to put our water reservoirs, our rivers, things like that, and then also the sewer lines, both the pipes to take the water there and the sewer lines to take it away. Next, we'll have building codes. Those building codes take that general definition of where things need to exist in the zone and make it more specific. So how does a building actually connect to the pipes? That's where you get to that next level of detail. At this point, we get blueprints. So we're going to have blueprints for that particular building, and then within that, there's going to be definitions about the specific connections, all these things. And this is the case where a developer gets to have, or an architect in this case, gets to really have their own stamp on the building. Now, I think most of you would recognize many buildings are unique, but they all connect to water in the same way. So this is how we provide that level of autonomy within a constructed framework. And then finally, using this model, we get a completed structure with running water. Now, one of the aspects here is during that process, there is an opportunity for feedback. So we have public comments whereby during the first two steps, the public can give feedback on these various zones, the zones and codes, and then we get a chance where we have blueprints. And the building inspectors look at those blueprints and make sure that the building is being built according to what we expect. Now let's take the example from a business context. So for this example, we'll use a similar idea of plumbing, but we'll use a model of all services need to connect to each other through service interfaces. So if you think of that, this is effectively what we think of when we talk about Amazon's early memo written by Jeff Bezos, which said effectively that. And that's one of the reasons Amazon was able to be so successful. Services will offer support through several defined interface types. So we create an architecture roadmap that's a bit more specific, but doesn't really get to the details of exactly how things can be connected, just that there are various connection types and that we can take advantage of. Now, we define those pathways. We say there are specific guidelines around maybe the protocols that are used or the authorizations that are enabled. Those are the kinds of things that then, when an architect goes ahead and designs that service, they make sure that they adhere to those particular guidelines. Finally, that service is then deployed, and it works and is connected to the cloud or connected to the overall infrastructure like we expected. The difference here is we also have comment periods, but it's not quite the same thing as what we have from the city level. At the city idea, that's a very top-down infrastructure. You have the city government basically enforcing these things across. In our case, we really want to have bottom-up involvement as well, where those developers are involved in the construction of these particular rules and regulations. So that's what we create working groups, and I'll go through that in just a moment. Next, during the service design phase and the service building phase, we want to make sure that those services adhere to the overall guidelines. Ideally, though, that is something that is done using automation as much as possible. Because, for example, in this particular case, you might well want to have a set of API guidelines. And those guidelines need to be validated against the APIs that are developed. But you don't really want an architect or a senior developer spending their time checking that. So can you make a linter to do that? And then the architect or developer gets to focus on the far more interesting task of what is the developer experience talking to those particular APIs. So now we'll get to the how. And in our model, the way we do the how is that we use what are called working groups. And fortunately, there is already a great model for what a working group can look like in the internet community, and that is the IETF. So the Internet Engineering Task Force has an idea where they create, well, first there is what the IESG, so the Internet Engineering Standards Group, or Steering Group, they decide what are areas that the working group should focus on. For example, it might be authorization, it might be HTTP protocols, it might be HTTP errors. Those are areas where they will create a working group. The working group will create an RFC, a request for comments, and eventually that becomes the standard. And I'm sure many of you are familiar with RFCs and use them every day. In our model, the idea is very much the same, but we have it where the architecture group internally, again, creates working groups. And those working groups then work together on a problem and create what we call an ADR, an architecture decision record. So an architecture decision record is kind of like an RFC. It's a little bit smaller in scope, and obviously it's only internal to our company. But the idea behind an ADR is really understanding what the technological choice was, some comments and feedback on what that choice entails from a variety of stakeholders. And when I say stakeholders, it's really important those stakeholders are not just developers. Because when you think about a technological choice, it may not just be the developers that have an opinion. Ops may have an opinion. Support, PM, docs. There's a larger customers. There's a larger community of people that you want to ask to make sure you understand who and how this choice affects. And it's different per ADR, but the idea is still very much the same. And then finally, that is the last part about it is when you make the decision, you encode why. So the last piece of the ADR is that it's the reasons for why you made that choice in the end. And then that gets published into a public place, internal to the company, but still something like Git, where everyone has access to it from that point on. Now, when you think about where to do this and when to do this in the process, architecture is always cheapest earlier in the process. So what we want to do is we want to make sure that we are doing these things early as possible in the planning phase. I don't know what kind of planning you do. We do PI planning, so program increment planning. It's a quarterly sort of increment. But that first time at the beginning of the 3 months, when you're thinking about what spike to do, that's an awesome time to do this kind of work and then create ADRs. Now, not every ADR is going to be something that applies to every single product. When I talked about we want to find common ground where it exists, API definitions are probably an easy one to be company-wide. You want to make sure everyone's APIs adhere to a common standard. But then there may be things that are only cross-product technology decisions, or even then, there may be very product-specific architecture decisions. And in that case, you're going to have different kinds of working groups. So you may have, for a big challenge or a big problem like an architecture definition, you're going to create a working group with a bunch of developers coming together, working on that problem for a month or more, then creating an ADR and maybe even some artifacts. Like in our case, when we did that, we created a schema for what our APIs could look like, and then we attached that to a linter. So as everyone is doing their development, they can run it against that. We still have to do some manual checks, but it lessens the burden. That's very much a cross-product top-down. Other cases, you may have more bottom-up sort of initiatives that you need to look at. In that case, you have the team who's making that choice. Like, let's say they want to say, or they want to know, which database should we use? Should we use Postgres or MariaDB or something, or MySQL, something like that? And they want to get the benefit of experience from other teams. Then you have a governance council. And when you say governance, it's as much a forum for providing experience and learnings from previous times as it is stamping down and saying, this is exactly what needs to happen. But that team-led proposal comes up to the governance council, and the end result is still an ADR. Or it could be other artifacts too, but that ADR is really crucial because it lets people know what was decided and why. So when you think about implementation, I think the most important aspect is you're going to have different levels of specificity, but they need to be shared so it's really easy for people to find and build on the experience of others. One of the common questions I get asked is, when should you make an ADR? And so there's a bunch of criteria that I think are useful in thinking about that. One of them is it an important technological choice? So I mentioned a database. It could be authorizations. It could be, what tools should we use? Does anyone have experience using a third-party library? Those are great questions that happen. And this is something that, I will admit, is not natural to begin with. But as long as you can really insert it into the planning process, that tends to make things much easier. You also want the benefit of many people's experience. So that's a great time when you can say, hey, has anyone else used this? What was it like? In one case, we were looking at a new technology. We talked to another product. They had a lot of customer feedback about how that was a problem to use. Great experience, us getting that ahead of time rather than figuring out later. And the purpose of ADRs is really to socialize that particular understanding. And then finally, you want to record the reasons why you made that particular decision. So when you go back 2 years from now, you can say, that was a dumb decision, but at least you know why. Or maybe it was a great decision, and you also have that justification. Or maybe you even had other options you considered, and then you can then build on that for where you want to go next. So another piece, when I mentioned it's really important to have communication across, there's lots of things you can do to help understand what other people are doing at the company. You can build tech radars. Tech radars are very interesting as a way of understanding what the company's doing as a whole. You can also use that for guidance. You can say, these are the items that are appropriate to use within our company under this particular situation. And then later on, you can vote items in or out. Also, ways of spreading information. We have our ADRs in Git, but we cross-publish them to Confluence to make them easier to find and search, in some cases comment on. And then there's other tools you can use to make sure that information is easily accessible and not siloed in a particular location. Finally, the last thing, I just covered it briefly. I don't know if you'll get the copy of the slides, but there's a thing called golden rituals. Ideally, that ADR becomes, or the creation of ADRs become a golden ritual. It's something I just learned a few weeks ago at a different conference. But the idea of a golden ritual is basically one of those things, like the Amazon 6-pager. It's a technique or it's a process that everybody knows basically from the time they start. They need to know that this is something that is important to function at the company. And there's a fascinating book being written about all the golden rituals at various companies. I encourage you to check it out. So with that, that's the end of my talk, and I will be happy to take any questions. What? You like the picture? Oh, well, he has questions about what he's up to. I like a little humor in a presentation, so. Unfortunately, my choice of images was limited on the plane, so I could only do with what I had currently on the hard drive. I've been saving them up. Other questions?
Yeah, thanks. The question that I have is, you mentioned that for the ADR, there are different parties that are able to provide their opinion. But my question is, who's the decision maker, and how do they make the decision?
Oh, inside the ADR?
Yeah.
Okay, so there actually is, kind of like when you create a working group, that working group, the people in that working group provide they're the people who get to make the decision. They're the decision makers. And that can be different. If it's across the entire company, then you might have a case where you're going to have stakeholders from each product line. If it's only within a single product, maybe it's the PM and the chief architect and a few other people that get to make that decision. And then you go ahead, and there's a bunch of different ways to sort of build consensus. One of them is the fist rule. I don't know if anyone's familiar with that, where you basically say, if you have a fist, you're going to the block. Like, this is not an acceptable idea. To like, let's 1, it's okay, up to 5 where it's great. I'm totally on board with that. And really, you want to get to the, you can disagree but commit. So eventually you need to find some solution that everyone can live with. You're not going to get perfect agreement, and I don't think you should even expect to do that. But you have to find this is good enough for us to be able to progress. And that requires, some skills in leading groups and whatever else, but a lot of employees can figure out how to do that. So there are tools and techniques that you can use to make that kind of decision happen. The important thing is figuring out who the stakeholders are for that particular ADR, that once you do it, it has a stamp of approval for the groups that's implementing it. Other questions?
Okay, don't do it. Thank you.
All right, thanks. Please reach out if you have other questions. Thank you.
SAP focused on making businesses run better by pushing the boundaries of innovation and impacted the world and people's lives beyond anything the founders ever imagined. With 50 years.
Okay, hi everyone. We're ready to proceed with the next speaker. This is Petio, senior software architect, tons of knowledge and expertise. He's here to talk about one of the trending topics so far. And yeah, please welcome Petio.
Thank you, everyone. Yes, I confirm what Itu said. My name is Petio Dimitrov. I'm a senior software architect at Musava Soft. And for this session, we want to do something quite ambitious. For 20 minutes, I want you to exit here by having a good overall understanding for NFT and also some technical insight, which for 20 minutes is quite nice. So what we're doing now is we want to figure out what the essence of NFT is in a nutshell. So a little bit of background, like why I'm presenting this topic to you. About a year ago, we had a client which offered a software as a service sales platform, which allows their customers to sell photographs, ebooks, music, and any other digital content that you can think of. And they were interested in the idea to use NFTs to offer like limited releases, alongside the digital resource. So you can still buy the photograph, and you can buy as many as you want as long as you have money, you get the copies. But you can also get a limited amount, 10, 100, 1,000, how much the creator decides themselves, of tokens, which are kind of, you get the photograph, but you get the photograph with kind of a signature for the artist, from the artist, which makes it unique, scarce, and kind of desirable to be owned. So these are what NFTs are on high level, but we'll get deeper into the topic. What we'll do is first we'll see what they are conceptually, then we will address the big question in the room: how can I steal it? Like, I suppose everyone has heard the news how much they sell for, and you tell yourself, okay, there are images on the internet. I copy images on the internet every day, so let's settle my children through college now, today. So I'll show you a demonstration of a theft. So yeah, hopefully you get rich soon. Then we'll do something more creative. We'll actually create a token, or so-called minting, which is inspired by the term from coin minting in the physical world. And finally, we will discuss a little bit the opportunities and problems for NFTs, so that you have kind of a broader perspective, not just technological, the technological side. So to understand NFTs, first we need to hit the term fungible. And I've been using NFTs for a year. When I hear fungible, the first thing I think about is food with mushrooms. And I love mushrooms. So unfortunately, this is not exactly what it is. The term comes from finance and economy, and this diagram should help us understand it. So focus now on the right side of the diagram, where we have the tangible resources, the physical ones that you can touch. So there in the top, we have a banknote, a gold bar. Those are fungible resources. What I mean by that? I mean that they're interchangeable. They're not distinguishable from one another to fulfill their purpose. You don't care if I give you a certain 20 left banknote or a different 20 left banknote. As long as it's 20 lefts, you're happy, right? You get free 20 lefts. So this is what fungible means. On the other side, non-fungible is like your apartment, your car. Sure, there are many other similar cars or apartments, but one is yours. It is specific to you. It is scarce to you. It has its own history. So if I swap your apartment right away, you will notice. It will not be indistinguishable for you. Maybe for the worse, maybe for the better. Depends on the apartment, I guess. So this is in the physical world. Now if you move to the digital world to the left, we see first the representation of a fungible digital resource. Bitcoins and Ether are an example of that. Again, you don't care if I give you one Bitcoin or another Bitcoin. You have Bitcoin. You see the price. You're relatively happy. And non-fungibles are NFTs. They're scarce. They have identity. And yeah, this makes them non-replaceable and interchangeable. So NFTs stands for non-fungible tokens. And when we say tokens, you can think of a reference to an object. In the physical world, when you play a board game, you can have a token that represents you on the board. With NFTs, you have a token that is for an image, as we'll see in our example soon. NFTs started with Ethereum about 7-8 years ago and exploded in popularity about 2 years ago. I'm sure every one of you have heard at least of them. And it was made possible by the Ethereum's capability to work with smart contracts. There was already a session about smart contracts. Hopefully you attended and you liked it, so we will not dive deep into them. But the important thing to know is that these are specific pieces of code that allow you to deploy functionality on the blockchain. So you can actually have state and have behavior there, unlike normal Bitcoin where you just track transactions. Like you track Petyu gives Yanchu 1 Bitcoin, for example, but nothing more than that. With smart contracts, you can do more. You can track state, you can track behavior, which enables NFTs. Then we have the blockchain benefits. Since it's on blockchain, it benefits from some of the blockchain's characteristics. So you have permanence. So this is a resilient distributed network. The NFT will not disappear if one node goes down, which is nice. Then you have ownership. You own your crypto resources, and this is nice, so you own your NFTs as well. There is transparency. You will see in the demonstration that everyone can go to the blockchain and see the NFTs there and track the transactions associated with them. And finally, there's the topic of security. The more eagle-eyed tennis players in the room will notice that there's an asterisk next to the name, and this is because security should be taken with a grain of salt. What I mean by that is you often see articles, NFTs are on blockchain, blockchain is secure. Sure, but it depends on the perspective. So for now, you can think about it like you have a bank vault. And sure, if your money is in the bank vault, it is secure. But nothing prevents someone from stealing them on the way to the bank vault, or actually replacing them with fake money, or as I saw in one movie, putting money in something combustible so they burnt overnight and in the morning there was nothing in the bank vault. The bank vault was still secure, like blockchain is secure. And those things quite literally actually can happen with NFTs, so one should be aware of them. We will talk a little bit more about them at the end. So we are in a mischievous topic, like stealing money from a bank. So let's see if we can steal an NFT. We already know what the benefits are of stealing one. So for this purpose, I have prepared an incriminating video of how one can do this feat. Yes. So in this video, we will follow up the steps. So hopefully afterwards, all of you can steal an NFT. I'm using a popular marketplace for NFTs where you can mint and trade NFTs. OpenSea is the name. And then I pick a collection. This is a collection for a comic book. I like the picture. This is why I chose it, nothing more specific. Ghost Comics. The artist created the first chapter of the comic book and issued 900 and something NFTs, like tokens, for that first chapter. We pick one. We pick number 788. It will be important a little bit later. We see the price. It's quite expensive, so fingers crossed we can steal it, right? Here we see some extra information, like attributes, metadata, as well as some technical description and some technical details. The important part is we see it's on Ethereum because we need to know where we are stealing it from, right? Ethereum is the bank vault in our metaphor. Here we also see a history of the transactions, who sold it, who bought it, who made an offer. At the root of this is the actual minting, the creation of the NFT. And if we follow the link, we go to the Ethereum blockchain. It is public, it is accessible. You can see the history of all transactions, including the transaction of the NFT. We confirm that this is for our comic book. We also see this ID here. It says ERC 728, if I remember, 21, sorry, with the specification for NFT. And also we can have visibility for the input data. In this case, it's not very useful. So far, we are still not stealing it. We want to get to the high resolution image, remember. We click on the link of the NFT itself, and the browser opens its representation. It says number 788. Let's correlate. Is this the one that we want to steal? It will be a nightmare to steal something else, like both a crime and we didn't get the result that we wanted. So it's the right ID. Here we see that it was minted with an initial transaction, and we have access to the smart contract that I mentioned. We can interact with its read-only API. So it's kind of an interface. And we can call methods and get the result. So we are interested in a method called token URI. If we enter here the ID of the token 788, did we steal it? Almost, but not yet. We see some jumbled data, which is actually base 64 encoded data, which if we copy and decode to see what is the content inside it, hopefully, still not an image, but it's a JSON document. And this JSON document we can format to have a better look, and we're getting very close. So we see the name of the token with the ID. We see properties, description, and we also see a link to an image, which is hosted somewhere publicly. So fingers crossed, we take the link, we go to the site, we hit it, and voila. We got to the original image with the highest quality it was created with, and we kind of stole the NFT. So we got the image itself. But what we got is an anonymous image, like which you can copy as much times as you want. In essence, on the blockchain, it still says that the identity of that image is owned by a specific person who bought it for God knows how much money. And we cannot touch that part. So maybe we stole, we got to the image, but we didn't change the ownership. We didn't really steal it. And from my perspective, stealing is not the right question. So yeah, it's not the perspective that you should take about it. What is more interesting for me is the next question, which is how you can create one. How can you mint an NFT? And as IT people, we are interested in creations. So we will go through the steps of doing it, so you have a better perspective of that as well. I wanted to have even a more technical demonstration there, but yeah, the time is limited. So what did you need to do? First, you need to pick a blockchain. Ethereum is a popular choice. Everyone, I'm sure, has heard it here. There are other blockchains as well that support NFT. Solana, Clayton, Chewo, Polygon, to name a few. So you choose to use it. And what you're using when you're using the public Ethereum is what is so-called mainnet. But when you develop, you don't want to hit the real mainnet because that costs money. So to feel safer, what you would use is the testnet, which is again a public network, which you can access, but it's limited with some more restrictions. And less nodes, but still quite sufficient for your needs to test your application. And this is what we did in that project as well. Currently for Ethereum, Giorli and Sepolia are popular test nets. Last year there were a few, but actually last week one of them was made read-only, so quite a dynamic field. Then you need a wallet. The wallet basically will give you your public address where your NFTs will be associated. So it will be like a real wallet where you put your virtual, like digital NFTs. It will also hold the password that gives you security and that blockchain security aspect that we can discuss later in the questions if you want. And you don't need to add crypto to the wallet in order to pay. Whenever you do something on Ethereum, you need to pay for the transactions, for the cost of those transactions. And yeah, you need to charge your wallet with crypto for that purpose. Now we move to the smart contract. We will not dive into the smart contracts themselves because it's quite a time-consuming topic. But I wanted to show you one just so you have seen it and have a first image of it. And the impression that I want to leave you is that first, look, like it's quite short. Like it's not a big deal, at least in this representation. Not that there are not complicated and troublesome smart contracts that need to be tested, etc., as the colleague shared earlier. Why this is possible is because we are actually using a library called OpenZeppelin, which gives us a default implementation. The smart contract, in essence, is an interface which allows you to interact with it and kind of give it commands and react to specific events. And OpenZeppelin provides a default implementation. So actually, we need to just provide our custom logic in the mint NFT part. It also has a specific extension on the second highlighted line, which is to store URIs, as we want to store the reference to our NFT. And next, we have the mint NFT method. We specify a recipient and a token URI, as you saw in the example that we demonstrated. And from there, the other two highlighted methods are actually internal. We are using what we inherit from the source specification on the top, implementation on the top, and reuse them for our purposes. So this is an example of a simple smart contract which you can set up. There are many more on the internet, and yeah, they should be stable and tested in order to be reliable. Then you have the question of the content itself. Like in the example I showed you, the image was, we accessed it via an HTTP request, you probably noticed. And this has two major problems. I guess you already think about some of them as well. First, that server might go down. If it goes down, yeah, the NFT still exists and is resilient on the blockchain, but you cannot really get to the image itself, which steals a little bit of its charm. Like you still have some bytes somewhere, but it's not the same. And secondly, someone can go to that HTTP server and can replace the image. You have the same name, the URL works the same way, but it's a different image itself. If you want to address this, you can do it via IPFS. This is a distributed file system where whenever you put something there, it's resilient because it has redundancy in multiple nodes. So yeah, one node failing is not a problem for us. And more importantly, the reference that you get, this IPFS URL that you see at the bottom of the slide, is tied to the content. It's kind of linked to the hash of the image in our case. So if the content changes, actually it will be a different URL, like URI. And this ensures that you cannot kind of swap the image in the case that I showed you. And for those of you that are proactive, if you scan the QR code, you can actually see a teaser of the NFT that we are minting virtually now in this session. Okay, to do this, next you need to use an API. This is the easiest option. We deal with APIs on a daily basis. So whenever you want to mint an NFT, you can do it differently, but API is the easiest option. For Ethereum, Alchemy is a popular choice. It offers a nice REST API. Tatum is the one that we use because it offers kind of a meta API and gives you flexibility to switch between blockchains. It's kind of more abstract and gives some extra features. But besides that, it's like any public service that you use either the free option or a subscription. You get an API key and you make the calls. And the calls themselves are nothing too exciting. We show here two API calls. The first one deploys the contract, like an example contract like the one I showed you. This one is deploying a predefined one because this is the Tatum scenario. So we need to provide which is the blockchain, because as I said, Tatum supports both. You specify a name of the contract, and you specify the private key. Why? Because you need to pay for the transaction. And this is the private keys access to your wallet, so you can pay. Once you create the contract, you get an address, which then allows you to make invocations, like calls to mint your NFTs. And on the right side, we have an example of those calls. So we again specify the blockchain. We give an ID to our token. We give to whom the address of the wallet where the token will be stored, so you keep it in your wallet. The address of the contract that will do the job. Here it's a parameter. And we have the private key for payment as well, and our URI. And in this case, we did a best practice. We did it via an IPFS link, not just HTTP. Yeah, and once we do that, voila. We actually minted our NFT step by step. We get a reference to the transaction itself, which is shown here at the bottom. And if you scan the QR code, you actually open the NFT in the browser via an explorer for the blockchain. And on the left, you actually see it, the similar technical details to the ones that I showed in the demo. And you now know that our NFT is actually the image of this year's ISTA conference. One thing that the more eagle-eyed of you will notice is that this one, for variety, is not minted on Ethereum, it is minted on Cheo, which is another blockchain, so you can see it there. What lessons did we learn from our experimentation with NFTs for our client? There are many, but the ones I want to highlight are, first, Ethereum is fancy, but it can be expensive and slow. Here you see an example that the cost for minting one NFT can vary between 10 and 100 euro, and I have seen online even larger variations. We just didn't experience them. And it also might take minutes, which means you need to plan it in your architecture, in your design. Like it's not something that you expect synchronously. But there are alternatives. We went with Cheo as well. What we did was we actually, based on the business use case, supported both. For more fancy images that are expected to sell for thousands, this cost is not a big deal. But for something smaller, cheaper, the other option is nice. Like you allow the people to dab their finger in NFT without robbing the bank in the process. Next, you will notice if you search for this that there are a lot of sales materials online with a lot of buzzwords, but not that much good developer information. The API this is getting better. Like last year, it was not as good. This year, it's better, etc. But the APIs that I referenced, like Alchemy and Tatum, have quite nice documentation with online materials, Discord channels where we communicated with the developers, so quite nice. And then it's a dynamic area. And this has many implications, like the prices are volatile. Testnets get deprecated, as I mentioned. One happened last week. New blockchains are introduced like yearly almost. So be prepared for that aspect of it. And now for the final part, I want to discuss some kind of more general topics associated with NFTs, a little bit to exit the technical part, to see what are the opportunities and problems there. I don't exhaust the topic because the time is limited, but I want just to briefly mention them. One is that they introduce uniqueness and scarcity for digital resources, so they're quite useful for collectibles. If something is scarce, and you can own it, people will have a desire to own it themselves. It also has the potential for an investment, but again, take it with a grain of salt because it's quite a hype market, it's very volatile, so it depends. Like if you have proficiency in the area and think you can distinguish the good from the bad, you can try, but I personally am more conservative about it. There are other problems, like I mentioned the illegal activities earlier. One part of it is the example with the link. So everything that is not on the blockchain, like the link on HTTP to a different resource, or maybe an NFT promises you that if you go to this bar, you get free drinks. It's possible, people can support it. If it is off the chain, it is not really guaranteed, so it might disappear. This is called rug pulling. And there are other problems there. Yeah, we can discuss them afterwards if you wish. And finally, the intellectual property is one I want to highlight. Some people quote NFT as solution to problems with intellectual property, but that's not really the case. Like when you get an NFT, you don't get actual rights of the digital resource. So if you take my NFT or ISTA's NFT and you put it on billboards and you start getting money out of it, in the general case, you can be sued. Like there is no protection. There could be, but usually there is not. And with that, we finish our talk, and I leave you with a summary. So NFTs basically allow our poor Smigo to not have the One Ring itself, but to have a reference, a token to its digital representation that is stored in the distributed database. So this is a technology that is new, quite modern. It has potential, but it also has kinks that need working out before it matures more. So if you have any questions, I'll be glad to try answering.
We have time for one question. Okay, we have one there.
There were some slides mentioned the value of NFTs, but what is the real value of owning or creating them just to put TV representation on the wall in home? Or
well, it is something that is still being clarified, but it allows you, for example, like there are several scenarios that I didn't dive into, but one aspect of it is it allows you to make something scarce. Like normally an image can be copied multiple times, but when it is a reference of it is stored on the blockchain, it becomes scarce and kind of unique, which adds an extra property to it. How much value you put on this is subjective. Like this is something that kind of depends on the community itself. There are other parts, like there are tidbits there that technically would allow an artist, when that NFT is resold down the line, if the smart contract allows it, they will get kind of royalties, so they can get extra returns on them. As I mentioned, you can use it as a speculation on the market, like you would buy a painting and you hope the price will inflate. But all those come with large asterisks next to them. If you want, we can discuss them afterwards if you're interested in the area. And yeah, before we close, if someone scanned the QR code, it's actually access to the slides themselves, and you guessed it, they're distributed and stored on the IPFS.
Okay, thank you.
SAP focused on making businesses run better by pushing the boundaries of innovation and impacted the world and people's lives beyond anything the founders ever imagined. With 50 years of groundbreaking work, SAP will continue to lead the way with innovation and help the world run better and improve people's lives.
Stripe Bulgaria was founded in 2008 by the Dutch entrepreneur Koen van Wijk. His vision was to create solutions that exceed customer expectations. Since 2014, Stripe is part of the ICT Group in the Netherlands. ICT Group is a stock-listed company on the Amsterdam Stock Exchange and employs more than 1,000 professionals. Since 2017, I have the privilege and honor to drive Stripes forward in the role of CEO. We offer solutions to our clients in digital transformation, smart applications, and infrastructure. Our mission is to build smart solutions that create business impact. We are Stripe.
We're a pretty resilient species, and that's true now more than ever. So we deserve app experiences that are as resilient as we are. This starts with apps that can scale to keep pace with shifting demand, or update at a moment's notice to support entirely new business models. In a time when the app experience has become the human experience, being future-ready means keeping people at the heart of innovation and flexing to meet their needs. Because technology really can change the world, but the best technology changes with it.
Oracle започват официално в България на 1 януари 2022 година, но двете компании, които обединява са на нашия пазар доста по-отдавна. Isobar Commerce и Life стартират съвместна работа като част от новата бизнес линия на Merkle Commerce and Experience. Аз съм част от това семейство от 13 години и заедно с много мои колеги преживяхме най-различни метаморфози на фирмата. Започнахме като малък стартъп, наречен e-commerce през 2008 година. Тогава празнувахме успешен декемврийски ден на коледно пазаруване с цели 1000 онлайн поръчки за 24 часа. През 2015 година e-commerce беше придобител от Isobar и стана част от бизнеса на Денцо. Това ни позволи да спечелиме нови вълнуващи клиенти и на последния черен петък през 2021 година достигнахме пикови стойности от 1000 поръчки в минута. През цялото това време сме разработили и внедрили над 400 transactional сайта. Работили сме с клиенти в над 60 държави и имаме онлайн магазини на 6 континента. Качеството на кода и поддръжката ни е ненадмината. Затова свидетелстват и нашите клиенти, с които работим заедно вече повече от 13 години. Днес сме Merkle и целим да поставим нови рекорди с качеството на кода, който пишем.
It's time to introduce the next speaker. He's from Romania. His name is Cornel Amarie, and he is the founder and CEO of Dotlumen. Dotlumen is a startup company which mission is to build classes that support blind people to live a better life. On top of that, he's an inventor. He has more than 30 patents on his name, multiple awards and nominations, such as Forbes 30 Under 30 for Europe. Cornel is here today to share some of his takeaways and insights that we came up with during his innovation journey. So please welcome Cornel.
Thank you. Thank you. Good morning. Let me start with a question. Raise your hand if you ever failed a class. Okay, okay. Keep your hand up. I don't know what's happening here. Keep your hand up if you failed 2 classes. Okay, okay, a few ones. Keep your hand up if you failed 5 classes. Well, apparently there are 2 of us who failed 5 classes. Happy to meet you. Yes, I have failed 5 classes, and I actually want to tell you the story of what happened the first time when I almost failed a class. So I was back in the 10th grade. That's like high school. I was 15 years old. and the chemistry professor asked me and a colleague of mine to go in front of the class. And they say, guys, you haven't learned anything. And I am a professor for quite a while, so I know you're not going to learn anything new. So I have no other option to teach you a lesson but to fail you the class. And of course, because we were students, we said, no, professor, of course we're going to learn from now on. But he knew us too well, and he knew we wouldn't. But he said something very interesting. He said, guys, you love computers. What if you do something with your passion for computers for your colleagues at the chemistry class? So do something with computers for chemistry, and if I like it and if it helps, I'll pass you the class. So that was back in 2010, finishing 2009, beginning of 2010. And we went back home and we're thinking, hey, what can we do? And it was kind of cool back in 2010 to develop apps. And so we said, hey, let's build an app which does something for chemistry. So we built this thing. We called it Chemcraft. It was a periodic table of elements app back in 2010. Yes, that's the iPhone 4. That was the coolest thing in the world back then. And it basically showed the periodic table of elements in a more interesting way, a more graphical way. Don't ask me, I have no clue what's in that app. I still don't know any kind of chemistry. But we built this in like a month, and we went to our professor and we showed, hey, we did this. Do you like it? And he said yes. And he barely passed us the class. But something else interesting happened a few days later. We found out about a business competition called Company of the Year. It's an international business competition for high school students organized by Junior Achievement. And we said, hey, we built this thing. What about making it into a business? And so we registered for the competition. It had a local face in Bucharest, Romania, where I'm from, the capital of Romania. We won that one, and then we went to the national phase, and we knew that from each country, out of the 70 countries which are worldwide participating, and I think largely 50 to 60,000 high school students, from each country there's only one team going to the finals. And we won the national finals. That meant we were the one team which were about to represent Romania into a worldwide competition which happens each year in a different location. 1 year before our year it was in Switzerland, 2 years before it was in Brazil, and we couldn't wait to find out to what exotic country we will go with our chemistry app to represent Romania. And for the first time in the history of the competition, the worldwide finals were held in Romania. Yeah, that's myself a few years ago when I was in my 10th grade, 15 years old, with Stefan, my colleague, which were both failing chemistry, representing our chemistry startup and not winning the worldwide finals, but learning a lot of things. First of all, learning what's about building a business. Second of all, learning about how we can transform a problem which we have in something that helps others. Because by us transforming our failure in chemistry into this business, we actually helped 300,000 people who bought the app. And one of the most downloaded chemistry apps in 2010 was made by 2 failing chemistry high school students. Absolutely amazing where problems can lead you or failures can lead you. My name is Cornel. I'm 28 years old. I was born in Romania, 28 years ago. And maybe a bit about myself chronologically. This was me at 3 years old. Not really that important. However, maybe a bit more important, I was born in a family which is a little different. Both of my parents and my sister have disabilities. Both of my parents have locomotive disabilities. They cannot walk without aid from different kinds of devices. And my sister has cognitive disability. And you can imagine that growing up in such a family had a really big impact on my life. I couldn't do the same things that most of you done with your parents growing up. I did never learn to play football from my dad. My parents were never able to go to a parents-teacher meeting at the school, which is not necessarily a bad thing. But it also made me very curious. Why am I coming from a family which is different? Why can't I do the same things that my colleagues are doing with their parents? And I discovered many years later that curiosity is just the first step. Because when you're curious, you want to learn from a lot of things, and you get a diverse background of knowledge. So from curiosity comes diversity. And when you have this diverse knowledge set, you want to build new things. You want to assemble the things which you know into new things, and that's creativity. And from creativity to innovation, it's only one last step. And I was incredibly curious from a young age. I began reading when I was 3. I began programming when I was 7. And I continued doing things like this, learning electronics, and most of the time staying in engineering, until roughly when I was 12, I started building something we called robots. This is me with my first robot. We haven't changed that much. That's me when I was 14. I'm exactly twice the age of that photo. But that yellow small thing is actually interesting. That was built in 2008. It was designed to be sent in the debris after an earthquake to identify victims. So you could control it wirelessly. It was built out of a bulldozer toy, actually. It had gas sensors to detect leakages. It had an infrared camera, so you can see actually in the dark. And it worked marvelously. And we know that because we tested it. But we really haven't tested it in the environment it was built for. We tested it somewhere else. When I went to high school, which is 9th grade in Romania, the high school I went to, I actually lived in the dormitory of the high school. And that dormitory had a very simple rule. On the 3rd floor, it's the boys' dormitory. On the 1st floor is the girls' dormitory. And for no reason can the boys go to the girls' dormitory or the girls to the boys' dormitory. But I haven't said anything about a robot. So one night, with a few of my colleagues, I take this small yellow thing and I put it at the entrance of the girls' dormitory. I go back to my room, and in my college room there were already like 40 boys behind of me. I opened my laptop, and we began exploring the girls' dormitory with this small yellow thing. If we were building that, if that's what we were using technology in the 9th grade, you can imagine what we're doing in with technology in university. What I remember from that night, the building was identical, each floor was identical, so our floor and the girls' dormitory was supposed to be identical, it mostly was, but there was a keen difference. We had the showers on, on the hallway, so all the boys were sharing like 6 showers, and all the girls were sharing their 6 showers. But the robot couldn't enter the boys' showers because there was like a very big gap he had to climb. There was a ramp at the girls' dormitory, so you can imagine where this robot stood. Anyway, we recovered the robot after like 2.5 hours. We promised that we will not tell anyone about this, of course. And the second day I will go to high school. It takes 20 minutes from the moment I arrive in the high school until the director of the high school calls me to his office. And he tells me 2 things. Colonel, first thing, if the robot was recording, delete the recordings. Let's say I did. And 2, if the most discussed subject in the entire high school is about a robot, what about building a robotics club? And that was actually how the first high school robotics club in Romania was founded back in 2008. It all started from this small yellow thing, which was sent into the girls' dormitory. And the high school director, that rather than kicking me out of high school, because he had enough proof to do that, he allowed my passion to build something else. This robotics club still exists. It brought Romania 150 international medals. Romania is #1 in the world right now in high school robotics. And there are 85 high school robotics clubs in Romania today. It all started from that small yellow thing sent into a girls' dormitory. And of course, from a high school director, which rather than kicking me out, he gave me an opportunity. And thinking about these 2 sort of failures which I had, I really understood that failures are just opportunities in disguise. Failing chemistry led us to build a business with 300,000 clients from over 100 countries. And breaking the rules led us to revolutionize STEM education in Romania. Failures are just new opportunities in disguise. Now, for the following story, I need a bit of help from your side. So can you please stand up? Come on, everybody stand up. I will need some help from you on this one. Everybody must stand up, perfect. If you wear glasses, take them off. Take them off, put them on your seat. Perfect, thank you. Raise your left hand. The other left. Raise your left hand, perfect. And now I want you to perfectly cover your eyes with your left hand. I don't want anybody to see anything, except me, I'm filming you. So cover your eyes with your left hand, keep them covered, nobody is allowed to see anything. Now, try to shake hands with the person next to you. Cover your eyes, you're not allowed to cheat. Come on, try it. If anybody's cheating, I will ask you to move around the room while not looking. Come on, try. Try to shake hands with someone you're not allowed to look. I'm sorry for the ones which are alone on their seats. You can also look behind and forward. I mean, don't look, just try to find. Come on, try. Okay, half of you managed, half of you managed. Okay, take your hand from your eyes. Perfect. Now, before sitting, take your glasses. And then you can sit. I think already the camera guys hates me because I'm moving all the time. And as amusing as this is for us, because it's an amusing exercise, I mean, for the people which were alone, it was kind of a lonely exercise, but anyway. As amusing as this is for us, it's an unfortunate reality to 40 million people in the world which are blind. We have 40 million blind people in the world today, and if you look at what solutions are available for them, you'll not really find that many. Even today, the most used advanced mobility solution for the blind is the guide dog. But to train a single guide dog, it can cost up to $60,000, and to take care of a guide dog is almost impossible for a blind person. Because of this, in the entire world, to 40 million blind people, you only have 28,000 guide dogs. Simply put, the best mobility solution is not a scalable mobility solution. But here's where we come in. We founded this company we call Lumen, which builds glasses that empower the blind to live a better life. What we do is we took the autonomous driving and artificial intelligence and robotics technologies, but mostly autonomous driving, and we scaled it down to something you can wear on your head to replicate the main features of a guide dog without the drawbacks that make the guide dog a non-scalable solution. But rather than talking about the technology and everything, I know everybody's from tech here, that's exactly why I don't want to talk about tech. I actually want to talk a bit about the people behind and what we learned from that aspect. And I want to start with Ciprian. Not sure if that's an easy name to pronounce for you, but Ciprian is his name. Ciprian is an industrial designer. That means he doesn't work with a keyboard, even if he has one. He actually works with the paper in front of the keyboard. He draws. He builds products. He tries to design something that can be easily used, easily manufactured, etc. 2 years ago, when we founded the company, the company is 2.5 years old at this point. So 2 years ago, at the beginning, we were doing marvelously on the technology, but what we were building was not really that pleasant to be used, manufactured, etc. And somebody recommended me this guy. And I gave him a call. I say, hey, this is what we're building. Do you want to help? And he said yes. The following week, he started drawing sketches based on some of our requirements on how this product, which we're building, can look, feel, be manufactured, etc. And then he comes in the weekend presenting me like 100 sketches. And they were horrible, all of them. But there was something there. There was something there which I couldn't understand, but it was there. I told him, Ciprian, this is shit. But let's do something. We can continue working together on one condition. For the following week, 4 hours a day, you're going to be blindfolded. And for the other 4 hours, you're going to spend time with blind individuals to really understand what they're facing and to really converse with them and understand their point of view in this. And Ciprian did this. And the following weekend, he drew 70 more. And these ones were very good. Out of the 70, we voted upon 8. And those 8 we 3D printed, put some weights, dummy weights in them, and we sent them to blind people in our country to actually test them a bit and see how they feel for them. And one design line won. And that design, we iterated at this point over 100 times. But at the beginning of last year, when we were iterating this design, we get an email. After we publish it and we make it public, what was the design of our product, etc., we get an email. And it was from Red Dot, the largest industrial design association and award in the world. And it started with congratulations, which meant I read it. And it said, congratulations, you have been nominated to be one of the 40 designs to win the Red Dot Best of the Best award. Now, let me explain what that means. Each year, you have 4,000 products which win a Red Dot award, 40 products which win a best of the best. 20 of them are Apple. And there we were with Apple. But it was something else. You are also nominated in the last phase among 4 other design studios from the US, UK, and Romania. It was the same email to everybody. We were the only one from Romania. For something called the Red Dot Luminary, which is the award which is only given once a year to the best industrial design in the world during that year. And it followed some judging, and followed a lot of emails and discussions and interviews. And we found out our competitors. For example, Spaceship Unity from Virgin Galactic was our competitor. So yeah, no big competition. And then in November, at the worldwide premiere, we found out that the best industrial design in the world was designed in Romania by a guy who initially couldn't get, out of 100 sketches, a good one, by a country which has nothing to do with industrial design. The best industrial design in the world was won in 2021. It was our glasses from Romania. And I really understood a lot of things. First of all, Ciprian is very good with champagne. That's him next to me there. But the second thing, this award made Ciprian one of the best industrial designers in the world. And then I realized, Ciprian was always one of the best designers in the world, industrial designers in the world. He never knew. He never had the opportunity to prove himself. He never had the context which can showcase the skills which we have. And that's one thing which I really learned in the last 1.5 to 2 years. Ordinary people, in the right context, can do extraordinary deeds. And it's our job as leader or as colleagues to create that context for the people around us. Because in my company, we have won so many awards, we have made so many things which were never possible before possible, only by creating the right context. Ordinary people in the right context can do extraordinary deeds. Lumen is growing, is accomplishing a lot of things. For example, she's Andrea. She's blind from birth, since birth. And to give you a bit of background, no blind person in the world can go to a large store like, I don't know what you have here, Kaufland or Metro or large grocery stores. They can't go in such a store alone, not even with a guide dog. It's simply too complicated. Andrea was the first blind person in the world who was able to go alone in such a store and purchase what she needed, empowered by our technology. When we're testing in various environments, she was the first to actually accomplish this, and now this is possible by a whole lot more people. And I remember the night we were testing this, the moment she actually, it's not visible here, but the moment she reached the cash out, or I think that's how I call the cash out location, she found out I was there and she gave me this hug. It's absolutely, absolutely amazing. And we began thinking of what are the things which, well, what are our values, what are the things which allows us to accomplish so much in just 2.5 years since we're founding. Because, for example, we're also the only company in Romania to win funding from the European Innovation Council. In Bulgaria, we actually have 2 companies. But in Romania, there's only 1. And today, in 2.5 years, we raised 13 million euros already. We're growing at a rate which no other Romanian company has ever grown. And we're providing innovation in the least innovative country in the EU, which is Romania. So you actually bet us. You actually are better than us on that. You're second to last, and we are the last. So... But we're doing great, we're trying. And that's how we actually identified our main value. Make meaning, not money. We never founded this company to make money. We founded this company to help people. We founded this company because we knew there's a huge problem and we kept understanding it. And we never cared about the money. And exactly because we never cared about the money is why we had the largest investment round in our Romanian startup, which is still in Romania. Because we didn't care for the money, we built a product which is actually empowering people. And that's when we realized it's make meaning, not money. Money will come after. And with everything you do, if you prioritize helping, you prioritize building things to help, and not thinking about the money, you will inevitably get to the money the moment you are helping. It's about seeing the problem and understanding it right, and continue understanding it, and then come with a solution only for the purpose of helping. And then lastly, money will come. Unfortunately, as you know, business is exactly the opposite way. We think about the money, we search for the solution, and at the end we find the problem which the solution tackles. And that's not scalable. If you put it in the right order, make meaning, not money, money will come after. So 3 things. Failures are just new opportunities in disguise. Because I failed several times is why I became an entrepreneur. It's why I built some things which help many other people. Ordinary people in the right context are capable of extraordinary deeds. My team is an example of that. We build a context for each other, and the best work of our lives was done in the last years since we are together. But it's our job as leaders and as colleagues and as humans to create that context for the people around us. And lastly, if you want to remember one thing from everything I told you, make meaning, not money. Money will come after. Thank you. You can find me on LinkedIn.
We can do a couple of questions.
Sure.
Okay.
Questions?
Questions?
I'll also change the image to a better one. This is better. There's a question over there somewhere. I think I saw something.
How did this idea come to you?
Sorry?
How did the idea for these glasses come to you?
How did the idea come to me? Yes, by accident, like any idea. Before answering your questions, I just want to mention ideas are worth nothing. It's just the implementation which really matters. I would actually argue the problems are much more important than the solutions, and ideas are mostly worth nothing. I was in a discussion with a friend, and we're discussing about everything, 2 tech people, myself and him. And at some point, we say glasses for the blind, and we're like, that sounds nice, let's search. And we couldn't find anything, but that's how we actually got to the problem. And that's when we began understanding the problem. And that's where the first ideas of helping came from. Because from the initial idea of helping up to the point which we are now, it was a very long way. It was a very, very long way. But I think a better question is what motivated us to start. Before doing this, I was head of innovation in one of the largest automotive corporations in the world. I had a very nice life. And suddenly I decided to quit all of that in order to basically go into a suicidal mission to try to do something which nobody was ever able before in Romania, which is a country, as I mentioned, very good at innovation. And that's definitely because of my background and of my family. Not sure if I answered your question, but that's my answer. Another question. There's one over here. By the way, I can't really see you that well from the stage because of the lights, so sorry if I'm not looking at raised hands.
How does the product actually work? Does it speak in the ears of the user?
Let me make an analogy. If you have a guide dog, you can ask the guide dog to take you to the door, to take you to the stairs, or to take you to an empty seat. And the guide dog will do this by pulling your hand. That's what it does. You give the command, it pulls your hand, it stops you at the stairs, it guides you around, keeps you safe, etc. You can ask the Lumen system exactly the same commands, and it will do the same, with one key difference. Rather than pulling your hand, as the guide dog, the glasses pull your head. What do we mean? We have this patented interface which we developed. It basically feels like something is holding your head and pulling you in the direction you have to go. It's immensely intuitive. We tested with over 200 blind people. I would say it's more intuitive than somebody pulling your hand. We also have audio feedback, but that's for some very specific use cases. But in general, that's how we give the input. Guide dog pulls your hand, we pull your head. On a technological aspect, it's a bit more complicated because we're discussing outdoor, indoor navigation, we're discussing visual odometry, we're discussing SLAM, of course, we're discussing depth processing, we're discussing, I think, over 25 machine learning models running, some of them in parallel, and we're discussing all in 600 grams. That's an autonomous driving car on your head. So it's absolutely amazing how much technology we're able to fit in that thing. I think it's most probably the most advanced wearable in the world at this point. So yeah, that's how they work. Other questions? There's a question over there. And the microphone is coming. Well, now you have two microphones.
All right, this is awesome, and thank you for the thank you. This was a very inspiring and very interesting presentation. That much that I couldn't hold myself. I was actually not going to do this because I'm following you, and it's gonna be a tough act to follow. But I have a question. We've seen startups in that space where you try to enable technologies, unfortunately fail. Now, of course, I wish yours all the best, and I'm sure it's going to go great. But what happens, because we've seen tech, come from startups, be used by people who need it, and then unfortunately when the startup fails to operate or ceases to operate, that tech is sometimes useless. Or no longer maintained, or the cloud servers that enable it don't work, but yet the people need it. So have you given any thought in that regard? Just in case, are you planning to open source or perhaps widen the availability to that technology to community so that it can keep on regardless of what happens commercially with your venture? Thank you.
Sure. Yes, a lot of startups fail, and it makes no sense why we haven't failed yet. I mean, we started with the idea that most probably we're going to fail. It's just not happening. It's not coming to us. Okay, why do startups fail in this space? First of all, doing any kind of assistive technology which is aimed at helping people with disabilities, it's hard. It's hard because it's very hard to emphasize, to understand a disability, and blindness is one of the worst disabilities to understand. We do exercises almost monthly. We blindfold ourselves. We do new things together. We try to understand even better what it means to be blind. We test in tremendous amounts of times with blind people to really, really understand how we can help and with what we're not helping. We're working with over 600 blind people on that. So for us, what always kept us afloat is the fact that we always try to focus on the problem and to understand it even better and to really work with the blind people up to some point, because it's not really that easy. Again, it's very, very hard to understand the disability. And that's one of them. The second part of them is definitely the stupid ambition that we are able to do this. Honda tried this 6 years ago, they failed. Toyota tried this, they failed. It's immensely, immensely complicated, immensely difficult, but I think we're at the right time and with the right amount of stupidly ambitious people to make this work. And we are surrounded by absolutely great people and great company. We are working with some of the best companies in the world which want to see us succeed. We already are working with governments which want to purchase this technology. And then lastly, maybe another thing, what we develop, the moment you take autonomous driving technology and you scale it to something you can wear on your head, you are pushing some limits of technologies and you're pushing some technologies forwards. And those technologies can be reused in other spaces as well. And we see the opportunities on that, working on certain business cases in other directions, but our main focus is the same. We started this with only one purpose, to help people. And we started with people which are blind, we will continue to people with severe visual impairment, and more we will announce soon. Yeah, I think that's the answer. Thank you. Thank you for having me.
Thank you.
SAP focused on making businesses run better by pushing the boundaries of innovation and impacted the world and people's lives beyond anything the founders ever imagined. With 50 years of groundbreaking work, SAP will continue to lead the way with innovation and help the world run better and improve people's lives.
Stripe Bulgaria was founded in 2008 by the Dutch entrepreneur Koen van Wijk. His vision was to create solutions that exceed customer expectations. Since 2014, Stripe is part of the ICT Group in the Netherlands. The ICT Group is a stock-listed company on the Amsterdam Stock Exchange and employs more than 1,000 professionals. Since 2017, I have the privilege and honor to drive Stripe forward in the role of CEO. We offer solutions to our clients in digital transformation, smart applications, and infrastructure. Our mission is to build smart solutions that create business impact. We are Stripe.
We're a pretty resilient species, and that's true now more than ever. So we deserve app experiences that are as resilient as we are. This starts with apps that can scale.
Hi everyone, time flies, you know, it's time for us to announce our last speaker, our keynote speaker. His name is Vasily Narnudov. He is director of the Advanced Development Center at VMware. His focus is actually to bridge the gap a little bit between the technology and science. He's here today to tell us how to get with the times. Please welcome Vesko.
All right. Well, it's great to be here. Thank you for having me, and thank you for staying. Now, I go by Vesko. I do lead the Advanced Development Center at VMware, and that means my day job is to, work with amazing people, get disruptive tech, and try to de-risk it so that it goes into the business lines. But now, my good friends and colleagues at ISTA, organizational committee, they came and said, all right, you do interesting stuff, right? Can you do a keynote? And that was my reaction. And pretty much the hair is kind of like that. If you're as old as I am in this industry, you know this guy, Doc Emmett Brown, crazy stuff, right? But they're like, OK, what do I talk about? And they're like, don't worry, this is the closing keynote. This is just between, you're going to be the last thing between a day of interesting stuff and the cocktail. So no one's going to pay attention. Don't worry about it. Right. But still, after 2 years of staying off stage, I said, all right, what can we do? And thinking of Doc Emmett Brown, I was thinking, hey, it's kind of like a Back to the Future moment for me, because I was on this stage in 2016. And in 2016, I had a talk about polyglot developers. Right. So back then, we talked about different languages, ways to what to learn, what to handle. We spent most of the time talking about two important topics. One was ransomware. The other one was blockchain, smart contracts. And mind you, that was 2016, so for better or worse, I think it's mostly worse, the predictions came true. I guess both of these topics are very relevant right now. So in preparing this talk, I wanted to think about what is going to be useful for you. And maybe we can get back here in a couple of years and see whether this panned out, right? So if you pay no attention whatsoever from now on until the end of the talk, which is fine, remember two things. I want to take you on a brief journey through two topics. One of them is going to be AI and machine learning. And my claim there is going to be that actually some real progress is made, and you should care. And we're going to talk about perhaps some areas you should care about that may not be the most obvious ones when we say AI and ML. The second one is going to be good old systems engineering. I'm talking about languages, compilers, architectures. And in particular, I'm going to talk about something we call WASM. A lot of you probably know it, but I'm going to touch base on WebAssembly. So with that, let's dive in. Obligatory disclaimer. This is a keynote. I love doing talks. I love doing hard ones with data and performance stats and all of that. This is not it. These are opinions. They're my opinions. I tend to be wrong about stuff, so keep that in mind. Still, I claim AI/ML is eating the world. And if this is familiar to you, it's because Mark Anderson from the VC firm Anderson Horowitz said it circa 2011. His quote was, "Software is eating the world," and the claim was that software is getting into so many of the domains, be it healthcare, autonomous driving, or something like that, that everything is going to be disrupted and changed by software that we are building. OK. I'm playing a twist on that and claiming that AI/ML is eating the world. So to tell you the truth, I was usually reacting like this guy would on the picture, eye rolling. The reason why I would eye roll like that is because, well, we have this internal innovation conference. I used to be chair of it a couple of years in a row. And, you know, circa 2017, AI and ML were at the height of the hype curve. If you've never seen one of these before, that's Gartner's hype curve. Until you get to the plateau of productivity where we all want to be, you have to go through all of that. And at that time, it was up there. Every second paper, that's sort of between academic and industry papers, was about machine learning. A lot of it was statistics, hidden like machine learning, but doesn't matter. So I was a little bit skeptical. Let's try to use this everywhere. But then, in preparing for this talk, I was I said, OK, how do I demonstrate the immediate value of machine learning in our lives to grab your attention? And you know what? The previous slide, that was a stock photo. I just found it on the internet. I hate using stock photos. Don't do that in your presentations. You could even see the water markings. And I was like, OK, I'll never use that. Can I do something better? And I could. I actually went in, ran the Stable Diffusion model. Stable Diffusion is, we're going to talk a little about OpenAI, but it's one of the OpenAI-based models that can draw based on a prompt. So I gave it a prompt, watercolor, Sophia, Impressionist, and best of a subreddit. It tends to work good for the model because of the way it has been trained with other images. And it produced this. And I think it's pretty nice. This picture is going to be free of copyright, free of any licenses. I could use it in my presentation instead of an ugly stock photo, and it's unique. It was generated for me. And now, I started playing with it, and it's doing pretty good. And by the way, I tried to do a small tweak. I added to the prompt watercolor Sophia pavement. Impressionist and best of watercolor, and if you live in the city, you might get the joke. The pavement that it produces is pretty good, I would say, but the machine prompted me that, look, this is taking longer than expected. So if normally it would take 30 seconds, this one took 3 minutes. And I was like, yes, I know it's taking longer than expected. So another one of pavement jokes. But all joking aside, it's actually doing pretty well. So this is a conference in Sofia that the computer imagined. The next one is Sofia City Sunrise. The third one is the Sofia City Autumn in Vitosha. And I think they're pretty good. Maybe they're not as good as some other things, but we're getting there, and we're getting there very fast. So let's talk a little bit about DALL-E. DALL-E, which I used for the previous 3 pictures instead of Stable Diffusion, is another. Actually, this is how it started. You've probably seen this all over social media. Now, also regular media is piggybacking on this. It was presented as a paper. Originally, I think it was even a blog post at the beginning of 2021 by Adam Kuciak and his team. So you could generate images from text captions. It's a 12 billion parameter version of GPT-3. GPT-3 is the OpenAI's model. You have a big data set of text-image pairs, and it gives you the power to combine unrelated concepts, like this illustration that they use in the paper of an avocado chair. And this is the computer's interpretation of what an avocado chair is, because usually avocados are not related to chairs, but at the end of the day, I think it's doing a pretty good job. Again, opinions here. But still, I mean, what is DALL-E? How magical it is? Well, it's actually very evolutionary, I would say, in terms of machine learning techniques. I mean, if you know what an autoencoder is, what a variation of autoencoder is, and now they did present the technique of the vector quantized variation of autoencoder, and let me tell you, that's a mouthful. It's a pretty interesting paper if you're into that kind of things. Actually, as part of this paper, you realize that every good scientific paper, you should be able to replicate the results. And to replicate the results, the problem is you need 1,000 of NVIDIA's Tesla GPUs, which are about, I don't know, these days they're about $3,000 to $4,000 each. I don't want to imagine what it was back then, but you need a pretty big cluster. So it's cool, and it's getting more and more accessible. And 2 things that you can learn from that. If you have a lot of data, and we can go into how we generate that data, because could we use AI and ML techniques to do that? Yeah, sure, we can. GANs. If we have a large enough model with a lot of parameters, we can have some impressive results. Caveat is, training that model is going to be hard. Now, about machine learning. I'm not going to give a talk going into the specific of what an autoencoder is, how to use it, how to apply it. But I wanted you to recognize the fact that the machine learning algorithms hidden under the hype are nothing but good computer science and applied math. And I personally trust computer science and math. Of course, there is a lot of computational power involved. And we'll get to that in a minute. Now, with that, you can have some amazing results, and not only in image making, you can have song composers that actually can, given a prompt of music, can continue the song. You can have solutions for, I love the previous talk about enabling people who cannot see and bettering their lives. You can have self-driving cars and all the other things that you regularly hear when you associate with machine learning. But now, what does that mean to me as a computer scientist? Well, I love this quote. It's by one of the former VPs of Airbnb, who was saying that every time you interact with our service, be it the website, be it the mobile app or something like that, you interact with machine learning. And I bet you that the top apps that you use on a day-to-day basis, no matter where you're based, here or elsewhere in the world, are going to be using machine learning, or in some shape or form interacting with machine learning models. So what does that mean? Well, that means that you need some, I would call it a working knowledge of the machine learning concepts. Now, this is an illustrative workflow. Don't worry about it. But do you know if a model that is being deployed by your data scientist group is CPU or memory intensive? Does it need specialized hardware? What is the cost of a training run? Do you do it in the cloud? How often do you have to rerun it? Some training runs of some commercial applications cost hundreds of thousands of dollars to train the model. But then do you need to retrain it? What do you do? Does it make sense to invest in your own infrastructure if you're going to be doing that fairly often? And even from a product marketing standpoint, from a product ownership and business standpoint, how do you work with machine learning when you have it as part of your apps? Do you create a horizontal product, and so you make one model and you apply it in different scenarios, sort of like OpenAI with GPT-3? Or do you tailor the model because you need to for each individual customers? And what that means, if you choose the second route, is that you perhaps need to structure your business in a different manner. Maybe now you're a services business where you have sub-teams customizing each machine learning model for a particular customer, and then dealing with a different level of margins and way of doing business and fixing things. And I don't know if any of you are running or working in machine learning startups, but perhaps this sounds familiar to some of you. So what I'm getting at is that machine learning algorithms that are most commonly displayed are just a tiny fraction of the ecosystem that we should care about as professionals. We need to care about configuration. We need to care about feature extraction. We need to care about how data is being collected. We need to care about the infrastructure that runs this thing. We need to care about boring things like monitoring and process management and all the rest of the usual software engineering business. But are you going to be able to do all of that we do without at least having some concept understanding of what it is? And you know, this conference started as a quality engineering conference back in the day. How do we do quality engineering on one of those? Do you understand the attack models? I mean, I love this because it's easy to understand. It's you've probably seen it. You get a picture of a dog, and you add some very well-constructed noise to that picture, in which the human eye cannot discern it, But of course, the computer can. So it gets correctly classified as an ostrich, which is, of course, hilarious until you realize that you can actually do it with real objects. And perhaps, as this experiment showed, you can have specially crafted stickers, stick them on a stop sign, and then the self-driving car interprets that sign as, let's drive with 120 kilometers per hour. And then it stops being funny very quickly. So how do we curate our data? How do we work with it? How do we deal with biases in the models? There are studies that show that your output is going to be as quality as your input for your training data. So you are going to run into problems if your training sets have a bias in them. How do we do explainability? And as we start to interact with machine learning applications more and more, for example, even when we don't realize it, we go to the bank, we ask for a credit, and the credit inspector actually asks an app what your credit score should be or where your trustiness. Or maybe you go to the doctor wanting to read an X-ray, and the practitioner relies on another app that actually looks at and tries to help them interpret the X-ray or the scan. Now, it's going to give you some result with some probability, but that practitioner right now is going to have a very hard time explaining why that particular result came into being. So explainability, tomorrow, it should get the user of machine learning applications knowing exactly why the machine decided a certain outcome instead of another one. All right. And you might say, OK, honestly, I don't care about that. That's for QE, for DevOps folks to worry about infra. It's for the data science folks to figure out with the models. I'm a software engineer. I write code. I don't care. Well, have you seen Copilot? If you haven't, do so. But in this particular tweet, someone was complaining, all right, look, I actually wrote a function, and you write the function name, and you rely on Copilot, if you haven't used it, to give you suggestions. And in this case, the suggestion gave you, OK, you should throw an error because you don't want to invert the binary tree. That's dumb. And obviously, that's not the function you were looking for and the help you were looking for. But again, that's the data sets. All right. So this is going to be more and more pervasive. Pay attention to it. But learn at least enough about machine learning to have an idea what it's doing behind your back. All right. Shifting gears. Enough about machine learning. I hope I turned at least some of you from skeptics to curious people. Now, I look around the audience right now, and I see a lot of you using devices while I'm speaking. Now, some of these are ARM-based devices, right? Some are, I see laptops, so Intel probably based, but I see some MacBooks as well, so M1 or M2 chips, I don't know what's inside. I probably don't see any RISC-V devices, but trust me, soon there's going to be at least, if not here, then around the lights or in the control pods over there. So lots of architectures. Let me tell you about WebAssembly. Now, WebAssembly is a very cool open standard that defines a new binary format. And that binary format is started with the browser, as many things do these days. It's supported, in fact, by all major browsers. You could run an executable program there. It's very cool. I like it even more because, I mean, riffing on the theme of polyglot development, you could write in Rust, you can do Golang, C, and then you get into this portable bytecode format that the cool part is it executes across architectures. Now, I'm a server-side person, so these days you can do a lot of that magic in the browser. Google Earth, Figma, Unity all have WebAssembly in them, but Solomon Hykes, one of the initial creators of Docker, was saying, all right, if in 2008 we had WebAssembly and the system interface, we would not need to use Docker and containers. We'll probably not need to create it. Because it gives you a lot of the power, WebAssembly has a very interesting sandbox. It's very efficient. It's polyglot, so you could fulfill some of the promises of what containers gave us as engineers. It's open, so it's a little bit in a better position than, for example, what Java was when it was invented, backed by only one company. WebAssembly is backed by the Bytecode Alliance. And most of all, it's portable. Because, look, as software engineers, we always solve, there is a lot of boring stuff that we need to do until we get to production. I mean, we create the technology, but then we need to build it. And do we keep different branches for the different architectures normally? Do we need to perhaps just have different make files and build different deliverables and then store them in different repositories? And then, OK, if we need to patch one, do we patch the other one? I mean, I'm talking about that whole sequence of, I would say, important but boring work that we do right now, and if we have even more architectures, we'll have to do even more of that. So it's exponential, actually, expansion. And this is a cool piece of tech that promises maybe what Java promised originally in terms of not only cross-operating systems, but in this case, cross-architecture. So with that, to recap, and as I promised, I'm not going to go over because I'm the only thing that's between you and the cocktail. I didn't know even that it had some music, but this is Stable Diffusion, one of the AI models I showed you, running on the new virtual reality platform that was just showcased by Meta this week. You can see that it actually gets generated, computer-generated. You need a lot of firepower. You need a lot of computational power to do it, but you can do it on the go. So imagine being in a virtual reality landscape that gets auto-generated for you by the computer just by prompts. No designers, except for the ones that give you the prompts. I find it amazing. It has its quirks, it's early, but I find it pretty good. And enough of that. Before we get dizzy, because that's another area, but I'm not going to go into it, virtual reality. I love this quote by Bill Gates. It's an old quote from '96 that we tend to overestimate what's going to happen in the next 2 years, but severely underestimate what's going to happen in the next 10. So how about we do this? How about we do this? In 6 years, we all come back here and see how many of these things panned out. Thank you. By the way, if you want to geek out about some of these topics, find me afterwards in the speaker's corner. Are there any questions?
OK. Thank you, Vesco.
Awesome.
Rafa, right? OK, in a couple of minutes, we proceed with the raffle and the closing ceremony here in the building, in the room.
We're a pretty resilient species.
Yeah,
and
we'll
that's true
kindly
now,
ask
more
you
than
to
ever.
stay in the room
So
because we're
deserve-
starting any moment with the raffle. Thank you.
Shifting demand, or update at a moment's notice to support entirely new business models. In a time when the app experience has become the human experience, being future-ready means keeping people at the heart of innovation and flexing to meet their needs. Because technology really can change the world, but the best technology changes with it.
Мъркъл започват официално в България на 1 януари 2022 година, но двете компании, които обединява са на нашия пазар доста по-отдавна. ISTA Commerce и Life стартират съвместна работа като част от новата бизнес линия на Мъркъл Commerce and Experience. Аз съм част от това семейство от 13 години и заедно с много мои колеги преживяхме най-различни метаморфози на фирмата. Започнахме като малък стартъп, наречен Никомера през 2008 година. Тогава празнувахме успешен декемврийски ден на коледно пазаруване с цели 1000 онлайн поръчки за 24 часа. През 2015 година Екомера беше придобита от ISTA и стана част от бизнеса на Денцо. Това ни позволи да спечелиме нови вълнуващи клиенти и на последния черен петък през 2021 година достигнахме пикови стойности от 1000 поръчки в минута. През цялото това време сме разработили и внедрили над 400 transactional сайта. Работили сме с клиенти в над 60 държави и имаме онлайн магазини на 6 континента. Качеството на кода и поддръжката ни е ненадмината. За това свидетелстват и нашите клиенти, с които работим заедно вече повече от 13 години. Днес сме Мъркъл и целим да поставим нови рекорди с качеството на кода, който пишем.
You guys hear me? Oh, okay, nice. Alright, so yeah, this was the schedule for ISTA 2022. We actually messed up a little bit at the end because me and Ivan should have been ready by the time that Vesco was done with his keynote. Well, we were delayed a little bit, but final words, I'm not going to stay here for like 10 minutes talking to you about how great this conference has been because you had actually the opportunity to see for yourselves. You're going to be able to give us feedback. You're going to receive a feedback form. Is that correct? Okay, good. I'm not talking lies. Okay, so you're going to receive a feedback form, and then you're going to be able to tell us, just exactly how much you like this conference. And be honest, your feedback matters to us, and it matters because we use this feedback in order to adjust each and every year. And now that we are back in this format, we will use this feedback to make a better and larger conference next year. I want to thank all of you in this room. I want to thank everyone that is watching online for attending ISTA for yet another year. We do our best to deliver a conference that really matters, that can change the way that we see things, that can allow us to dream, that can allow us to invent, that can allow us to, I forget the third word.
Dream as well.
Dream was the first one. Okay. See, I'm messing, To explore, exactly. See how unprepared I am. And that's it from me. So what we have left for tonight is I'm going to hand it over to Ivan for the raffle from our sponsors and our organizers. And then we're going to have a really nice cocktail outside provided to us by Johnny Walker, I believe, yeah? And we'll be able to network and mingle there in probably about 10 or 15 minutes, right? Ivan, it's your turn.
It's going to be more than 15 minutes. But before we go to the raffle, everyone that was part of the organizational committee, could you come guys on stage?
Oh yeah, that's a good thing to do, right? the organizer.
Hold on. A few more are just coming.
Kadebet. Where's Betty?
So if you like the Johnny Walker event, these are the guys. If you like all the sessions, these are the guys. If you want to be next, if you want to be here next year's, these are the guys that practically start preparing ISTA 2023, practically as of tomorrow, and I'm not exaggerating.
November.
Cool. It won't be tomorrow, right? Anyway, once again, big applause for these guys. Okie dokie, guys. Thank you. So, we have 15 companies that are going to participate in the raffle. And we have a 16th one, which is Johnny Walker themselves, which are going to award some Johnny Walkers to lucky guys. And I want to ask Experian to come on stage. So the award for the raffle is a smartwatch.
Okay, so the number is 384 or 300.
384.
Yes. Thank you.
That was a good one.
Is 384 here?
Okie dokie, sorry for you.
Okay. 268.
Добре. Понякога така започват нещата.
И след 30 минути по-късно. 289.
289. 289. Ба!
No 85 085.
85. That was a relief. Okie dokie, can we have Infogistics on stage, and their award is an ultimate subscription to their developers toolkit. So they have 3 vouchers, right?
Yep. Three.
Can we have the next one as well?
Absolutely.
I hope this isn't a back-end developer.
$134.
So 134. 134. На чист български. By the way, if you get an award, keep the ticket. It won't be the first time when someone actually gets 2 awards, so keep that.
291. Sorry, 298. Sorry if I got anybody excited.
So 298. So thanks. Next one is Musawasoft. And their present is going to be an Apple Watch.
Four 480. 480.
So next, we have SAP, who have a backpack, a player, and a power bank. And it might be that they have 3 of them. Let me do this for you.
So the winner is 377. 377. The next winner is 350. 350.
Не нужно.
And the last one is 190. 190.
Остави му го, ако искаш, защото може да спечели още нещо. Точно така. Okay, so next we have VMware. And I will see Vesco with this one. Cool.
Can you hold this first? All right, let's see. And the winner of this musical device is 480. 480. Oh, well. You should play the lottery as well.
So that's the lucky guy today.
I didn't do any magic, I promise.
Next we have Merkle, and what they have is a backpack, and a surprise in that backpack. And the surprise says, enjoy the adventure.
The winner is 441. 441.
And now smile for the camera as well. Thank you, Merkle. Could we have Bosch on stage? and they have a backpack and a smartwatch.
And the winner is 463.
Аз ще ти го дам след малко. Smile for the camera, guys. Could we have progress? So let me help progress as well.
Two, 7, 8, 278. Някой? Да. Congrats.
Smile for the camera and keep that. Could we have resolve? And after that, we have Axway. So that's the automation ninja if you don't see it.
So the winning number is 485. 485.
Bang! So Mr. Automation Ninja. Axway. Ooh, this one is heavy. So could you guess what that is? So that's 77. There was some excited guys over here. 77? Sorry, 77. 400. You might need some help. So next is Commerzbank.
The number is 34.
Thanks, guys. So next is Ocado, and they have 3 Lego sets for 3 people.
Okay, guys, so we have 094.
So she could pick up.
Okay, that's for you.
Time.
Next one. 1, 1, 2. And the big one, the most interesting one, goes
I've never
to...
seen a Lego guitar.
Yeah, right. 4, 1, 6.
Ooh, 1, 6. So next is stripes, and they have something that you could use to do a round trip. And she's not from Stripe, but she'll help with. So it is 449, 449, 449. So next we have TIC 42, and they have a backpack as well. One more, and we have the Johnny Walker Awards. Hmm?
Go ahead.
460. 460, 460. Come on stage, smile to the camera with those lovely girls. So dev experts, and they have a voucher for virtual reality escape room.
$18. 018. 18. Anybody who's 18? 18.
No, leave that. Moni, how do we deal with the Johnny Walkers? So that was 76, guys. 436. 436. So what's that, by the way? $304. 304. И наградата е книга, както разбрах. Okay. Last call. So it is 474. 474. if you leave the room without Johnny Walker, there will be Johnny Walkers actually in the lobby. So that's 177. 177. So I leave you to the Johnny Walkers and their friends. Once again, thanks for being at ISTA. See you next year.